Good morning.
Morning.
Good morning.
So welcome to Azure Lowlands.
Yes, welcome everyone. Okay, let's start things off. So welcome everyone to Azure Lowlands. So this is our third edition. We had two in-person ones in Rotterdam, and this year we'll all do it from our respective homes. So Eldert and Angelique in Rotterdam, and I'm in the central of the Netherlands, Ede, and we're doing this virtual. So we're having 3 tracks this time. So usually in the person we had 2, and now we're going to do 3 tracks for you. It's going to be Eldert in track 1, Angelique in track 3, and I'm in track 2, and we are accompanied by some co-hosts as well. So Eldert will have Adi and Alex Mang in his corner. I'll be joined by Magnussen and Tommaso, and Angelique will be joined by Rick Hepburn. So those are the guys that also have been doing some stuff for us in the past as well as speakers and such. So 3 tracks. You can switch to the next slide, I think. Yes. So there's 3 tracks. So I already told you who are the hosts and co-hosts. You can see those tracks. They're going to be live. They're going to be streamed to YouTube, Twitch, and Facebook for each respective tracks. Yeah, over to you, Eldert, about Discord.
Yes, thank you. So indeed, of course, we are going virtual this year, so it will be a bit different than previous years. However, we still want you to have interaction with each other, with the sponsors, with the speakers. So what we did, actually set up a Discord, so you can go here and you will be brought there. And on Discord, you can interact with all the speakers. They have their own sessions channels over here. If you expand this, you'll see that for each session, there will be a separate channel. You will also see our sponsors. So, of course, we want you to go drop by there as well. And we have the lobby and the breakout rooms just to mingle with your other attendees. Now, if there's any issues today, Angelique will tell more about this, but there is this Ask the Organizers channel over here. So if you have any issues, just come in and let us know. So if you have the link over here, it should also be in your invite, and it's also here in the stream, so you can actually see it anytime you join us. You will see where you have to go. Moreover, after the last session, we will be doing a raffle. So for everyone that has registered, you will be joining us for a raffle, and always, like everyone that has registered, will be joining on this. Also, I just told you about Discord. If you are active on Discord, we will be doing a raffle also among top 10 people that were active on Discord as well. And of course, this year we are virtual, so we want to have something that does this whole virtual thing. Everyone is working from home. So we are decided to do these 2 sets over here. These are the sets that we are going to raffle. So if you want to join in, just make sure that you are in Discord at the end of the session and that you are watching the stream, of course, so you can hear your name when we call out. We'll be doing the raffle live, so you will be watching us who's actually going to win. If you hear your name, please let us know on Discord that you are there, because then we will pull you into the stream and we'll make sure that you can get your prize and we'll get your contact information to actually ship this to you. So with that, let's go over to Angelique.
Yes, without the sponsors, we don't have an event, of course. So that's why we want to thank every sponsor we have to make this possible to go live also for the events. And I will tell also a little bit of the rules and about you can also visit the sponsors at Discord, like El told us already. So don't forget to go there to them for a little bit of speak with each other. I can think we go for the rules now.
Yes.
So we are here for you. At Twitter, we have Azure Lowlands, the hashtag, and the Twitter angle you see here. Don't forget our code of conduct. We want to have everyone to respect each other like you want to respect yourself. Don't forget that. And if there's any problems, you can message us to email at board@azurelowlands.com or to Court, like El told us already, and ask the organization. Don't forget to go to Discord for the raffle gifts. And I want to tell everyone to have fun today. And
Yes, enjoy.
Does anyone else something to add that?
Yeah, just everyone have fun.
Have fun.
Hear the different tracks.
Yes. Okay.
Awesome.
Awesome.
So, what will happen now? So Angelique and Steve-Jan will go to their respective tracks. I will be staying here. I will be joined by Alex Meng in just a moment. So just go to the favorite tracks. All the information is on the website. So let me just quickly share this. So all the information is on the website for every session today. Nope, this one. So go to the website. You should see like that we are live now. You can join the different streams over here. You can join the different tracks over here. You can join the different tracks over here. 1 second, because I now hear myself. So let me just switch. There we go. So you can join different tracks. If there's any problems, if you don't see this yet, like I pulled this website up an hour ago. So if there's still in the cache, do a hard refresh. If there's nothing in the cache, then it should be okay. Otherwise, if you have any issues, you can just go to YouTube, look for Azure Lowlands. We will be there as well. Just to make sure everyone knows that everything should be up now. Okay.
Yes.
With that, let's go to our different tracks.
Yes.
I will bring in Alex Meng in this track, and everyone enjoy today.
Enjoy.
Hey,
Alex.
good morning.
How are you doing?
I'm very fine. I was actually having some fun on Discord right now with the Azure Lowlands bot. First and foremost, I'm so impressed by the organization. The bot first thing, of course, because I was having fun with it. I was greeting it and so on. But greeting everyone is a great idea. Now, I don't know if the audience knows this. I used to be a speaker, just like you've mentioned, like Rick was, like Magnus was, the other editions of Azure Lowlands. And you've told me one thing last year. If you remember, you've asked me if I'm free on 29th of January, 2021, last year, right? When I was presenting, I told you, well, yeah, Alder, you know, I have such a good time here at all of the editions that you guys have put together, but I actually have my son's birthday today on 29th of January, so I'll probably not be able to make it for your third edition at Azure Lowlands. To which you replied, yeah, you can bring your son here. But the real story is not my son's birthday. The real story is that you guys are actually preparing this a year in advance. And I don't know, but maybe, I just speculate, maybe you're doing it for the venue because it has to be booked. And yet you went through a pandemic, you didn't require a venue, and you still have such a good organization for this stuff. Kudos. Amazing job, guys.
Thank you. Yeah, so indeed, we do plan this long ahead. One is indeed the venue, because you have to know, okay, are we going to do this? What are we going to do? But the other thing is also just to make sure that everyone is actually up to date, like expect that we are going to invite you. Also, like there's a lot of other conferences around as well. So we also want to make sure that the other conferences know, like we are planning to do it in this time frame, so we don't, because you don't want to poach each other's speakers and stuff like that. So that's also one of the reasons we do this, like just to make sure that everyone knows, okay, this is going to happen, and just to make sure everyone actually can join in and stuff like that.
I love that. I really love that. And I really appreciate the organization that you guys have put together. Definitely, this is not a 2-day organization kind of an event. You fix it like a week in advance or something like that. You've done it a year in advance, and you went through the pandemic, which I really appreciate. I am curious, however, how many attendees do we have?
So we had 650 registrations. And then, of course, there's we are open for everyone. Like the registrations were mostly so people could put into the calendar, and also, of course, with the raffle. But everyone can actually join in. Like we are just open on YouTube, on Twitch, on Facebook. So everyone that wants to join can actually just join us. So for the people at home, if you want to share this with your colleagues, with your friends, feel free, because everyone can join in.
So let me get this straight. If people are looking at us from YouTube right now, they have probably registered and they were told in advance, but they can share the link with anyone else. Nobody needs to register. They can just watch the stream if they want to get some great content and deliver some great feedback back to the speakers. And if they do register, then they are part of the raffle where they can get crazy good stuff, right?
Exactly. So the registration is closed
Awesome.
now. So if you didn't register, you are not in the first raffle. You can still join in for the Discord raffle, of course, because we have the 2 raffles. So if you are active on Discord, at the end of the day, we'll look at the most active people, and they will all join in in a raffle, and then they can also do Lego sets.
Brilliant. So there's a chance for somebody to win stuff, even if they have not yet registered.
Exactly.
Is there a place for people to sign up maybe in a newsletter so that they register in time for next year?
So we don't have that yet, but I would say keep an eye on the website at least, and I will actually think about doing a newsletter. And of course, we have our Twitter and our social media like Twitter, LinkedIn, Facebook. That's where we always publish everything. There's also where all the links to the recordings will probably be published later on, where we announce speakers and everything like that. And
sounds good. So Twitter, Facebook, and Discord for today. Get active over there and watch great content. Is that it?
Exactly. And so talking about speakers.
Awesome. It's easy enough.
Yes. So I want to bring our first speaker for today into the stream here. So Will, welcome.
Hello. Can you hear me?
Yes, we can.
Awesome.
How are you doing?
Loud and clear.
I'm doing very well, thank you. How are you guys?
We are good.
We're not only good, I'm actually super excited for your talk later today.
Okay. Oh, I best not disappoint then.
I'm sure you will not, because I've read the abstract and I've also seen what you're doing on GitHub, and I'm really impressed. I mean, first and foremost, I got to tell you, I'm a huge fan of .NET and Azure Functions. I myself am a software developer, have been a software developer for the past 20 years. And I'm a huge promoter of Azure Functions. But regretfully, when I talk to people about Azure Functions, they more often than not, they tell me they do this and that. And it's kind of easy stuff, right? They don't get in the good stuff. They don't get the juice, like durable functions and this and that. And when I came across your abstract, I was like, oh my God, you're doing Azure Functions for banking. And not only that, but for the payment system? That's crazy. I want to learn about that.
Yeah, I'll get into it during the talk, but it has been crazy. We've been at this for 18 months. It feels like a much longer time than that because of all the issues that we've encountered. But yeah, it's been crazy. That's a nice way of putting it. Maybe I should just leave it at that.
Crazy good, right?
Crazy good stuff. Over any questions.
That sounds really interesting. I really look forward to this. As Alex says, Function is one of those servers that is really really built for the cloud. I think it's really really scalable. You can just scale it up indefinitely, scale it down indefinitely, and especially when you bring in durable functions to do the whole state management and stuff like that. It's just really interesting. And I think that the functions are actually one of the servers that actually took all those advantages that the cloud brings us.
Yeah, totally. I mean, again, I'll get into it, but it's with all the issues and all the challenges that we've faced over the past 18 months, it's really allowed us to actually go to market quite quickly. Even the way that we've had to work with them, they're really, really easy, really intuitive to work with, and they're super customizable as well. So that's just given us a lot of flexibility when we're actually developing this application.
Awesome. Yeah, I'm really looking forward to hear a bit more about this. So you're from New Zealand, right?
Yes. Currently, living and working in Auckland, New Zealand. Sunny
Awesome.
Auckland. Yeah,
yes.
It was hot today.
You're in the summer now. I'm looking outside. It's very rainy, very dark here. So you're in a much better part of the world right now. With the whole pandemic, you are actually in a better part of the world because you can actually go out and meet people.
Yeah, so we've had a bit of a scare recently with a couple of cases, and with COVID, the government has gone for an elimination strategy, which has worked. But every time there's 1 or 2 cases, everyone does get on edge. So it's been like that over the past couple of days. But we've been really fortunate in just the way that it's been handled over here. I've got family living in the UK, and yeah, it's not great, unfortunately.
Yeah. Well, today we are not going to talk about the COVID pandemic. Today we are going to talk about technical stuff, starting with functions. So what I'm going to do, I will bring up your slides, and then you can kick off today as first speaker in this track. So I hope you enjoy your time, and I will put your screen on now, and there we go. So good luck and enjoy.
Cool, awesome. So hello everyone. Welcome to Azure Lowlands. Wherever you are in the world right now, I hope that you're staying safe and healthy during these rather crazy times. Thank you for joining me this morning or this evening, my time, for this session, building event-driven microservices in Azure for a bank. Now, in this session, what I'm going to be doing is I'm going to be talking about a recent project that I've been working on at my place of work, ASB Bank, and how we built a payment system in Azure using some pretty cool technologies such as Azure Functions, Cosmos DB, Event Hubs, etc., embracing all the cool buzzwords when it comes to using best practices like CI/CD, DevOps, etc., while fighting the good fight against our friends in risk and security who'd really rather that we didn't do anything at all, and for very good reason. This session will kind of be a theoretical session, and it's aimed more to developers and architects who are thinking about building applications in Azure, using these cool technologies and just thinking about how they can actually approach different situations. Because as we go through this talk, you'll know that we face some pretty big challenges being a bank and being in a country where we don't have any Azure data centers. Well, currently we don't have any Azure data centers within the country. So there were lots of challenges that we had to address and try and solve. So a little bit about me before we start. I'm a software engineer based in Auckland, New Zealand. I've been living and working here for coming up to 11 years now. I haven't quite lost my accent yet because I'm originally from the UK, but I consider myself at least half a Kiwi. I'm also a Microsoft Data Platform MVP. I was awarded that in April last year. I focus primarily on Cosmos DB, Azure Functions, Azure Synapse, code mainly in .NET, but I do dabble a little bit in Go and JavaScript when I need to. Also Event Hubs, Service Bus, etc. So I get to play around with a lot of cool Azure technologies, both inside and outside of work. So what we'll be discussing today, I'll just start off at a very high level and just tell you guys what my team is actually trying to build and what problems that we're trying to solve using Azure. And then I'll introduce a concept, what I like to refer to as duck architecture. And if that sounds a little bit weird now, just bear with me. I'll explain what I mean by that very shortly. Then I'll talk about the different cloud patterns and design patterns that we implemented during the development of our application. We'll talk about it at a theoretical level, and then we'll just dive down a little bit deeper into how we actually implemented that for our payments application. Then I'll talk about the CI/CD practices that we embraced and also actually deploying our Azure Functions within this rather unique environment that we had to build for ourselves to make sure that it's both secure and compliant to banking regulations and for our security requirements. And then towards the end, we'll have a Q&A session. If you have any questions, put them down. I think there is a chat here on StreamYard or Discord, and we'll address them at the end of the session. So essentially, around about 18 months ago, our boss comes to our team and essentially says, we've got the green light to build this fantastic new, super quick, super fast payment system in Azure. And essentially, what we have at the moment is an on-prem system, which is a third-party application that's been built and developed by a team in Christchurch. Essentially, the bank contracted this out. And we were told to bring this application in-house and build it into the cloud, and build it on the cloud. And this was one of the first in-house cloud applications built by the bank. And that's not me saying, oh, you know, we're this super cool, awesome team that gets to do that. This was pretty new stuff to us, not just for a team, but as an organization. So there were lots of challenges that we had to try and figure out without a playbook in place, which was a bit of a challenge to start with. This application is mainly targeted to business customers. So it's not like I have an application on my phone as a private customer that wasn't the application that we were building. These were large-scale transactions, so there was concerns about performance and also speed that we just needed to keep in mind. And this was a core banking capability. So we needed to not only figure out how we're going to build this to work for our purposes, but also how we're going to actually integrate this with other systems as well, used by other teams, such as our analytics teams, how they're actually going to use it for risk purposes, also FTP teams, because we had to process a lot of files, or take files from one location, process it and put it into another. So essentially we had to build this core banking capability that's not only new and greenfield, but also integrates with our existing infrastructure. And there were many challenges that we faced even before we did any whiteboarding, before any coding. These were the challenges that we had to face and trying to address right from the start. The number one problem was that there was no New Zealand-based data center. So right then and there, you have all these issues with data sovereignty and also monitoring of the network. There's also data encryption as well. So we had an issue with persisting data, just plain text within a cloud environment, since we couldn't really control our traffic, or inbound and outbound traffic. We needed to figure out a way on how do we actually encrypt our data properly that met the requirements for our security teams. We also needed to audit network traffic, so traffic coming in and coming out. We needed an ability to have fine-grained control over that, so we make sure that no bad actors can come in and actually compromise our systems. So those were three big challenges that we faced right from the off. Then we need to figure out how we're actually going to host our microservices that meet these compliance issues that we had, and also we are hosted in a secure way. Then we need to figure out how to deploy our services. Obviously, we couldn't just, go into Visual Studio, right-click, publish. That's not effective. That's slow. So we needed to figure out how we can meet all of our security requirements and deploy our services in such a way so when there are problems or when there are hot fixes that we need to deploy quickly to production, or if we need to deploy new features quickly, try and embrace some cadence to our production deployments, we could do that in a safe and secure way. And then, of course, integrating with on-prem environments. So let me introduce this idea of duck architecture. So essentially, this is the kind of a term that I've made up, and it's probably not going to stick. But essentially, duck architecture can be summarized as using shiny new technologies and buzzwords to cover up the pain of dealing with the inevitable risk, security, and compliance issues. And let's actually visualize this a little bit more. So here we've got a duck on the surface, nice and cool, calm, collected. We have a bunch of technologies. So these are all cutting edge technologies such as Azure Functions, Cosmos DB, we've got Terraform in there, a little bit of Docker, event hubs as well for message brokering, and then you've got all these cool practices that organizations want to embrace to make their software development processes more streamlined, such as DevOps, CI/CD, and then you've got some patterns to make sure that their applications are performant and resilient. So you've got event sourcing, CQRS, and everything on the top looks like it's calm. And if you're looking at it, say if you're if you're trying to interview at a company and you're looking at all these technologies listed, you might look at that and think, oh, that's really, really cool. They get to play with all this cool technology. And that's just the surface. Then underneath the surface, the duck is paddling like crazy just to try and stay afloat. And you're dealing with these kind of issues. So we've got to deal with security issues. We've got to deal with network controls, compliance, making sure that any applications that we're building are compliant. We've got risk issues, legal issues, and we've also got to encrypt our data. Because at the end of the day, you can build a solution with all these cool technologies, all these best practices, and throw all the buzzwords that you like at it. But at the end of the day, this is people's money. These are high-value business-to-business transactions. We are building a system that simply cannot fail. And if it does fail, we need to be able to have a way that we can remediate that in a way that doesn't cause any negligible impact to our customers. Because at the end of the day, our reputation as a bank to conduct business-to-business transactions is paramount. So essentially, at the top part might be like the job description, but then the actual job is on dealing with everything underneath the water with your security issues and compliance, encryption, risk, etc. So with that in mind, it's probably best to just give you guys an overall solution overview of what we've actually built and a little bit of a process of how payments and batches are processed through this application. So essentially, we'll have on-prem FTP folders where payment files are sent to that folder. Our customers will send that through, and eventually they'll send a bunch of files with the amount of payments that they want to process, how many batches, etc., and that will land into an on-prem FTP environment. We have a bunch of Docker applications running on-prem that will poll this file, poll this directory location, pick it up, process it, encrypt it, and then send it straight to blob storage. And then we'll be using something like Event Grid to actually trigger events once that blob is successfully uploaded, and then send that event to a function where that file will be validated within that function. Once everything's okay with the file, it'll be sent to Event Hub, and that Event Hub will trigger maybe a command or an event, which will get sent to a function. And this is where our business logic will be processed. We'll use Key Vault to decrypt and encrypt data as and when we need to. And then further down the line, we'll send commands and events to event hubs. They will get picked up by functions, and then some functions will actually interact with a data store, and the data store that we use in this case was Azure Cosmos DB. And there'll be a bunch of different processes and business validation that we'll need to do along the chain. But at the end of the process, a file which will send a payment instruction, which will create a payment instruction, will then be dropped into an on-prem a file back on-prem. So essentially, we just pick up this file on-prem, encrypt the file, send it through our payments engine, make sure it's validated, make sure it's processed properly, and once it's all processed, we drop it back into our on-prem environment. And all of this is hosted within an app service environment. Now, for those of you who may not know, an Azure App Service environment is a fully isolated and dedicated environment for running app services. It's a deployment of Azure App Service into a subnet within an Azure virtual network. An ASC is dedicated exclusively to a single subscription, and it can host up to 100 app service plan instances. And this ranges, the range can span 100 instances within a single app plan to 100 single instance app service plans and everything in between. This allows us to have fine-grained controls over our inbound and outbound traffic. At the time when we first started up, we attempted just to use simple consumption plan. That just didn't cut it in terms of security, and also there's a bit of a performance issue as well with cold starts as well. It takes a while for functions to respond, which caused a bit of an overhead when it came to processing times. An app service environment avoids that completely. There's high memory utilizations. You can have multiple ASCs within a single Azure region or across multiple regions. For us, we are fairly limited to the Azure regions that we can use. So we opt for the multiple ASCs within an Azure environment. And the great thing about ASCs is that network security groups can actually restrict inbound network communications to the subnet. And then service endpoints are used to allow our functions to communicate to other services. So we can use that to communicate with event hubs, Cosmos DB, storage accounts, etc., as and when we need to. Now, there are two ways to deploy an app service environment, either internal or external. So you can have a virtual IP on an external IP address, which is called an external ASC, or you can have a virtual IP address on an internal IP address, which is an internal ASC, because the internal endpoint is used by an internal load balancer. And this is the one that we've opted for. And then for monitoring and logging, so essentially what we've got all our functions will send telemetry events to a single app insights instance. And then we have Cosmos DB, storage accounts, etc., sending directly to log analytics. And because we have multiple different functions sending events to a single app at insights instance, we use a lot of application maps for dependency tracking. And this allows us to actually, within a certain time frame, allows us to actually monitor activity between functions. So if any exceptions happen, we can actually use that to see which calls failed. Was it a call to Cosmos DB? Was it a call to a key vault or a storage account? And we can actually pinpoint and have fine-grained insights into what actually failed. And then also we have automated alerts, notifications, and emails. So we use App Insights to generate a lot of alerts for us. So for if we have any problems with CPU, if event hubs are not triggering, if they're not sending messages, we'll hook that up to our emails, and then will just send us email alerts for that. So App Insights has been really beneficial for actually sorting that out for us. Now, just in terms of stack choices or choosing the different technologies, Azure Functions was really, really great for us. We were choosing, we had a choice between logic apps and function apps. And we went for function apps because they provide really easy integrations with other Azure services using through triggers and bindings, while allowing us to have a bit more customizable, to build a little bit more custom solutions and actually implement a little bit of custom code so we can actually do some business logic within our function applications, which with a little bit more flexibility than logic apps provided at the time. Originally, we went for pure triggers and bindings, but a couple of months down the line, we noticed that these weren't as performant as we would have liked. So one example that we have a function that interacts with our data store, and we were using just triggers and then Cosmos DB bindings. With each function within a function application, we found that using bindings, it actually instantiates its own client per function invocation. We didn't really want that. So we actually reverted to using dependency injection just for performance improvement, so we can actually share singleton objects as and when we needed to, rather than creating a connection each time. And that allowed us to be a little bit more flexible, and functions were really, really great for that. We chose Cosmos DB as our data store, and this allowed us to be really, really flexible with our data schema and application changes. As you can imagine, when you're building an application for the first time, you'll have to iterate quite a lot as you go on through the development lifecycle of your application. There's a lot of iteration, business requirements change, particularly at banks, especially with new greenfield projects where they're not quite sure what they can do. And Cosmos DB was fantastic to allow us to actually be a little bit more flexible with our data and change our application as we needed to. And the great thing about Cosmos DB, it's actually grown as a product a lot over the past 18 months. So when we originally started, it was still back in the days where you could only provision manual throughput, and regardless of whether you were using it or not, you had to set it at a hard limit. So we spent a lot of time in the very early days actually, twiddling around and figuring out how much request units, how much throughput that we needed to provision on our Cosmos DB databases and containers to actually process large files. And as it's evolved over time, implementing autoscale, it's really been it's really improved as a product, which is great as we because we really need it to improve as we onboard more and more customers. And then Event Hubs was really super simple to set up to get going, and allow for higher throughput of messages. Looking back now, it does lack some key features like built-in item potency checks. It doesn't do dead lettering, and that stuff moving forward would be really handy. As more and more teams have started to build applications on Azure, they've opted for service bus route, going down the service bus route. And I think if I was to take a guess over the next 6 months, I would imagine that we would also follow down the Event Hub's route, because you will find that there will be situations where you'll need to handle dead lettering, you'll need to do idempotency checks on messages, and it did seem at times that we were just over engineering for no good reason at all. So one of the advices that I would give, one piece of advice I would give to developers when assessing what kind of services in Azure that you want to use for, really have a think about what your data is, what edge cases you're going to be encountering, and then just make some educated decisions based on that. All right, let's move on to some of the cloud patterns that we implemented. So essentially what I'll do is I'll introduce there were 3 main patterns four patterns that we implemented that were really crucial to us to make sure that our application was scalable and successful. I'll introduce them as a concept, and then we'll just dive down a little bit deeper into how we actually implemented them for the use of our application. We were a little bit flexible, so there were times where there will be some patterns where we didn't implement it in the most pure way possible, if that makes sense. If it wasn't like to the letter in the book way of doing it, we were a little bit flexible in the way that we approached it, but hopefully you'll see how we implemented it. Okay, so we first start off with the command event pattern. So essentially, when say you've got a function and it's done something. So say it's validated the file. If we go back to our solution overview, our files come in, it's validated, it's all good. And now that service is going to say, all right, we're going to send a command to say, create a payment for this particular, this file creates a payment. I want you to create a payment for this particular payment. This command will be sent from a function into event hubs, and that event hub will then send that command to another function where that function will perform some transformation or task. If that transformation or task is successful, this will then trigger an event. So we have one event. We have a command coming in saying create payment. We go through this service. It says, okay, all right, sweet. We apply some logic to it. All right, now that the payment's ready, I want you to say that this payment has been created and send that. That same service will then send that event to another service via Event Hub. So essentially, we'll have a Event Hub namespace and event hubs within that namespace that processes commands, events, and then we might have an event. We will have an event hub to process any errors. So if anything goes wrong within that particular service, we'll send an error or exception event or a business error event, whatever the nature of that error is. We'll send it. Say that this create payment had an error, and then that error will get picked up by another service, which will create an exception event or a business error event, depending on what the error is. So here's just a way that we've implemented that. Say that we've validated our file, so we've created a command called create transaction. This will be sent from Event Hub. So the function will then, the function will then send it to the Event Hub. The Event Hub will then pick it up, then send that command to another function. And then that function's sole responsibility will be to receive that incoming command and then process it depending on the nature of that command. So that command might have the payload of the payment itself, when the payment was created, what the status was, etc. And then depending on that, if everything's all good, it will then create an event. Just an example here, event transaction created, which will then be sent further down the pipeline. So that's just how we've implemented the command event pattern. And then event sourcing. So the event sourcing pattern defines an approach to handling operations on data that's driven by a sequence of events. So which is each of which is then recorded within an append-only store. The events are persisted in an event store, which then acts as a system of record, which is kind of like the authority data source about the current state of that particular data. So if you take a look at take a payment, for example, payment might be in a state of created, might be declined, accepted, validated, approved, declined, whatever. The event store will hold that current state of data. The event store will then typically publish these events so that consumers can be notified and then handle them if needed. And this can be used to materialize domain objects. And the advantages of this pattern are that the events are immutable and can be stored using an append-only operations. And they're usually objects that describe that some action occurred. So if you think back to a payment state, you could say, okay, that this payment was created at such a time, and then this payment was approved at such a time, etc. These events will have meaning towards our domain experts. So we work quite closely with a payments operations team. And the way that they see events is through a UI. They can click on a particular payment and they can say, oh, this payment's in a certain state. And then depending on the nature of that state, if they need to, they can raise an alert or raise an instance with us to say, hey, can you guys have a look at this payment? It's in such and such a state. And that's where event sourcing can actually kick in. We can actually see what's actually happened to that payment as it's been processed through payments engine. And this can be used as an audit trail to really diagnose any issues with payments as and when we need to. And we can erase events, and event sourcing can raise events and tasks that can be performed by other functions. Now, again, the way that we've implemented this is not the most pure way of doing it. So essentially, we might have a function that will create a payment, and that event will then be persisted to your write store when we use Cosmos DB. And then once we've actually written it to the write store, we'll then send an event via event hubs. I know you can do this through the change feed in Cosmos DB. So if you were going to go purely down the Cosmos DB route, you could actually write something to a write optimized store and then use the change feed to listen to that write store container to raise an event to another function. But for us, we found that the change feed was a little bit slow. We needed the polling time to be a lot quicker than the change feed provided. So what we would do is we would write an event to the write store and just persist it there, and then send, once that database write operation was successful, we would then raise an event or a command and then send that to event hubs, and then that would be picked up by another function. And then depending on the state, depending on that event, if a new state has been added or created for that particular payment, that would then be persisted to the write store again. So it's not the purest way of event sourcing, but that's just the way that we did it, just to try and speed it up a little bit for our use case requirements. And then command and responsibility segregation. So this pattern separates read and update operations for a data store. So what CQRS will do, it will separate read and writes into different models using commands to update the data and then queries to read the data. And these commands really should be task-based rather than data-centric. So rather than say, it should be create payment, not say, not set payment status to created. There's just as an example. Commands may be placed on a queue for asynchronous processing rather than being processed synchronously. Try and get that out. And then queries performed never modify the database. So a query that returns a data object does not encapsulate any domain logic. This actually provides this pattern provides us a lot of benefits. So we can actually independently scale. So depending on the nature of our data store, this pattern allows us to scale our read and write workloads independently. And in combination with Azure Cosmos DB, if you set throughput at the container level, what you can do is you could have a container that's purely optimized for your write workloads, and you might provision quite a lot of throughput to that, depending on the amount of writes that you're going to be performing. And then if you have another container that's optimized for reads, and you know that people aren't going to be reading from that container, or the read operations against that container aren't going to be as frequent as write operations, you can actually fine tune the amount of throughput that you allocate to those containers to really suit your needs. And just try and separate those concerns out, so you're not worried about fighting for resources for both reads and writes on a single container. We also can benefit from optimized data schemas. So the read side can use a schema that's actually optimized for those queries, and then while the write side is then uses a schema that's just really optimized for updates. Again, one of the fantastic things about Cosmos DB is that actually fine-tuning your indexing is really, really straightforward. It's just updating a JSON file and just choosing which paths you want to include or exclude within your index. So for your write concerns, you might, if you're doing a lot of bulk writes, you might turn off indexing off altogether, or you might just index on just a single property. That's what we opted for, rather than turning off indexing entirely. And that can help optimize the performance of your write operations. And then for your read operations, you can actually build almost materialized views depending on the nature of the read operations. There's also security benefits to it, so it's easier to ensure that only the right domain entities are actually performing writes on particular data. And again, separation of concerns, so actually separating your read and write models is a little bit more maintainable, a lot more flexible, particularly if you're using something like Cosmos, a data store like Cosmos DB. We can actually fine-tune your throughput requirements depending on the nature of your operations. Most of the complex business logic will go into your write model, while reads are relatively simple. And actually separating those out, we found it a lot more maintainable. And also you can perform simpler queries as well. So in your read store, you might have a materialized view with the payload that you're expecting when you're querying. And this is really good, because then you're avoiding performing any really weird or complex joins that you might need to do when querying a certain set of data. So again, the way that we implemented this, so we'll have a function that will change the state of a payment, causing a change in state, and then persisting that to Azure Cosmos DB. This will then kick off another event where we actually have a separate collection for the history of a particular payment or a batch. So we have a UI, a very basic UI. Now, payments operation team can actually click on that particular payment, and then they get a description of that particular payment and the history of that particular payment as it's gone through the payments engine. So when it was created, if it needs approval, when it was approved, whether it was declined. And that's a really kind of like a really simple data model that we're actually returning back to the user. And then using CQRS, using that pattern has actually allowed us to actually just take what's really important for our users and the history of that payment, and then just change our data model slightly to really optimize those read operations. And then for resiliency, we implemented the retry pattern. So any application that communicates with services running in the cloud needs to really be sensitive to transient faults that can occur within that environment. And these include monetary loss of network connectivity, or if a service is down. We've had a couple of issues where Event Hub's service was unavailable. And so we needed to be resilient towards those types of changes, or the types of instances that occur. And we also need to be aware of any timeouts that can occur when a service is busy. Now, these faults are typically self-correcting, and if the action that triggered a fault is repeated after a suitable delay, it's likely to be successful. So when we were first developing with Cosmos DB, we implemented a retry pattern that was we were using exponential retries for our write operation. So we provision a certain amount of throughput, and we would be reaching reaching the limits of that throughput within our operations. So by implementing a retry pattern, we actually we used Poly, which is a really good C# library for implementing retry patterns. And through implementing that, we actually kind of backed off from aggressive writes to a certain container until there was enough request units available for us to successfully persist those writes to that data store. And in the cloud, transient faults aren't uncommon, and any application that's it should be designed to handle them elegantly, and it minimizes the effects that faults have on the business tasks that the applications are performing. So you can imagine with a payment system, if a payment fails due to a service not being available, that can have impact on our customers, and we don't want to have to go back to customers saying, hey, can you drop this payment in again, or can you reprocess this batch again, because that looks bad. So we need to have within our application, we need to actually be able to accommodate for that, and make sure that any faults that do happen that we may not even have control over, particularly with Azure services going down, we need to be able to minimize the effect that has on our business operations. If an application detects a failure and it tries to send a request to a remote service, you can either cancel the operation entirely, you can retry the operation, or you can retry after a delay. Initially, we went for just a pure retry, and then we've also done some stuff with retrying after a delay. So it really does depend on what the requirements are for your application. For long-lasting failures, consider circuit breaking. I think circuit breaking would be it's a far more optimal pattern for stuff that that if you retry that operation again, it's certain to fail. So there's no point in retrying until a particular service is back up or it's recovered. And Poly is also good for doing circuit breaking as well. And it's not for business logic failures. So within our payments engine, we do a lot of validation to make sure that particular types of payments are sent to the right function, so they're processed accordingly or in the appropriate manner, depending on the nature of the payment and depending on the file that comes into the payments engine. It's generally not advisable to do business logic or handling business logic failures with retry patterns. So what we've done is, say if a particular payment fails validation, we'll actually raise a business error event, send that to an event hub, and then that sends confirmations out to our customers saying, hey, there's something wrong with your file. You need to have there's a particular error of this error. Can you error with this file, can you please look into it and then try and reprocess the file again? That's a more suitable way of dealing with business logic failures. And just a word about some Azure SDKs. So some of them will have built-in retries. So depending on which technology that you're going to be using, I know that Key Vault has a really nice retry built in within its SDK that you can actually configure. Cosmos DB does, but I don't think you can configure that yet. Depending on what technology you're going to be using, make sure and depending on what language you're going to be using, have a look at the SDK, see how retries are handled, and make sure that you aren't over-engineering your applications just to retry the retry. One thing that we kind of did, we just built a retry helper just for everything right at the start of our development efforts, and then just applied it to every single operation that we were going to use for every single service that we were using for Azure. And looking back now, that was probably a lot of over engineering on our part. All right, now let's finish off with actually how we implemented CI/CD. So we embraced Terraform really, really early into the project, and Terraform has been fantastic. So For those of you who may not know, Terraform is a infrastructure as code tool that you can use to build cloud infrastructure. Being a bank, we needed to be able to adapt to different cloud providers. I'm a big fan of Azure and MVP, so don't get me wrong, I love Azure. I hope that we stay on Azure, but we needed to be in a position where, say, if our boss turns around and say, hey, an issue has come up, we need to use this certain cloud provider. We wanted to use a tool that was fairly flexible. And since we were the first team that was really approaching cloud development, we didn't want to learn a skill that kind of blocked us out from using other cloud providers. So Terraform just provided us that extensibility to actually, so once you've learned Terraform, we can apply that to any other cloud provider as and when we need it to. And this gave us a lot of flexibility over something like ARM templates. For ad hoc scripts, we also use a combination of Azure command line tools, PowerShell, and Bash. So depending on the nature of what we need to do, we do a little bit of scripting as well. And then for our code, we are a Microsoft shop as an organization. So we were very lucky to just be able to host our code on Azure repos, use pipelines for our builds and releases, use all the wonderful tools that DevOps provides. We also build a lot of internal packages as well to be consumed, not just by us, but by other teams throughout the bank as well. So if we developed a helper library, we could use Azure Artifacts to actually host our internal packages and then share it with other teams throughout the bank as well. The things to note here, because of security requirements, we weren't allowed to use cloud-hosted agents. We had to use on-prem build agents, and Azure DevOps is fantastic to be able to do that. We also needed policies on our pull request builds and deployments, and this is, I think, really one of the underrated and underappreciated things about tools like DevOps. So with our pull requests, you can set certain policies depending on what branch it is. How many approvers you need, what's the acceptance criteria before a pull request can even be raised. So essentially we use YAML to define our build pipelines. We'll have particular branches that will kick off a build once we push code into our repos. Depending on which branch we push it to, we kick off a build. And then once the build is validated, only then can a pull request can be active. If your build fails, your pull request doesn't become active, it can't be reviewed, and it can't be merged back into your main branch. So that's really been helpful to actually trying to ensure some quality around the code that we're building, code that we're pushing into our DevOps environment. And then we also have permissions around deployments as well. So there are a limited amount of people that can actually approve deployments into certain environments. So as a team, we'll say if we have 3 environments, we have a dev environment, a QA environment, and a prod environment. As a developer, I can push stuff to dev, I can push stuff to QA, but if I once everything's all working and I want to push it into prod, we actually use AD groups to actually try and lock that down. So once you're part of that AD group, you can actually then only approve deployments into production when it's appropriate. And we've set it up in such a way where you can't actually approve your own deployments as well. So if I'm a member of that group, I can't just write something in dev, push it all the way to production without any oversight. So that's actually allowed us to put some auditability behind our deployments as well, which has been really, really good. And then just locking down of subscriptions. So a security requirement for us was that we weren't allowed to access any resources in our production subscription without very good reason to it. So what we've done is we've locked that down. Essentially, we have this feature called break glass, where we're all part of a particular identity, a particular permission group, sorry. So once you're part of that group, you're able to lock down able to use break glass to go into production. So if an issue occurs, you essentially go into the names, PIM, the acronyms now escape me. But essentially, you go into there and you say, I need access to this subscription. You provide a reason why you need access into that particular subscription, how long you need access for, and then that triggers an email to everyone under the sun, your teammates, your boss, their boss, security. So everyone knows that you, at this particular time, have gone into production to do a certain thing. So I can't say, I'm going into production to create a $30 million payment to pay my account. I can't just pay myself $30 million, because if I did that, everyone would know, and then I'd be escorted quickly out of the building. And that's been really helpful to actually keep our production environment more secure. And it's also it's just helped us to keep it more secure. So I'm figuring out how I can actually share these slides with you all. I might just put them up on GitHub or just share them on my Twitter, but there's some really, really helpful resources here that if you're approaching, if you're thinking about developing applications for Azure, whether it's for a bank or for anything else, these are some really helpful resources that we used for our development. So looking at some cloud design patterns, there's a really nice set of documentation that Microsoft have provided. I know we all love reading documentation, but they've really given some good guidance around some good cloud design patterns. And it was there were times during the development of our application where we were looking at this thinking, we wish we had spent more time thinking about this to avoid any mistakes further along the chain. This would have helped us within our development efforts. So I'd really recommend you guys check that out. If you want to learn more about app service environments and how that dedicated and isolated environment can actually make your function deployments, your app service deployments more secure, I'd recommend checking that out. I think in the future, when functions provide support for private endpoints, we'll move off app service environment, but I'm not too sure about that yet. That's still very early stages for that. If you want to learn more about Azure DevOps, there's a link there to documentation. It's a really fantastic tool for actually enabling a DevOps culture for your development teams. And then I've added a link to Microsoft Fast Track. Now, this is a service provided by the Fast Track team, and they've been really super helpful with developing, with helping us providing guidance when developing this application. So we'll meet with them every week. We'll have a Teams meeting and we'll discuss any issues that we're facing, anything cool that's coming up. Maybe something's going into private preview and we want to have a look at it. We won't necessarily deploy that to production, but we'll see if that benefits our application in any way. And they've been super scalable for us. So it's not just our team, but other teams within the bank. They've also provided a lot of assistance to, and they've just been fantastic. So if you're an architect at a large enterprise and you think that you need a bit of help, your engineers need a little bit of help building it, reliable applications in Azure, I'd really recommend checking that out. Cool. Well, that's all I've got. Thank you so much for listening. It was a very theoretical session, I know. If there are any questions, I will check the chat. Otherwise, feel free to follow me on Twitter, just @WillValida. If you have any questions, just send us a tweet. I probably won't be monitoring the Discord because it's 9 o'clock and I've got to think about catching some sleep. But thank you so much for having me today. I've really, really enjoyed it.
That was a fantastic conversation. Thank you so much for the presentation, Will. You do have actually a number of questions, so really good questions coming in, both from YouTube and Twitter and Discord. There were also some comments. I'm going to start with the comments.
Okay.
There was a comment obviously related to your Duck architecture. And there was a reference saying that there was some expectation that you're going to effectively refer to a Duck typing architecture instead because of the many loose components, but it was not a case. Somebody mentioned that it is actually like a swan component because of the beauty of all the technologies you have implemented, and then all of the chaotic things happening underneath the hood. And Martin congratulated you for the straightforward explanation of CQRS, and he also added that CQRS should be given for any money flow implementation, which I fully agree with. Now, in regards to the question that you have received, there is a question. In your architecture, you have both Event Hub and Event Grid. What's the difference between them, and for what use cases should you use which one?
So Event Grid is kind of like a smart broker that just reacts to particular events that happen. So for us, we use it purely for our storage account. So we'll have that on-prem file that gets uploaded, and that will say, okay, the file's landed within that storage account. It's encrypted. It's ready to be processed. Go for it. So it's kind of the way that I think of Event Grid. It's a smart broker that reacts to particular events, where Event Hub is kind of like a dumb broker, and it's just really used for processing just telemetry events. It's a little bit more flexible, so you kind of like send events to it rather than relying on it to react to certain things. That's the kind of like the best way I can really put it. For what use case?
Straightforward way as well.
Sorry, what? There's a bit of a.
I was just saying it's also a very straightforward explanation. And thank you for that. Go ahead.
For what use case you'd use each one, it really does depend. I mean, if you're wanting something really super simple, so say if, again, adding a blob to blob storage, Event Grid's really great. It's really cheap. It processes. It's really straightforward to use. I use it for some of my personal projects as well, and I found it super simple to set up. Event Hubs, if you're needing higher throughput, you need to process a lot of messages very quickly, I would opt for Event Hubs.
Very good. Thank you so much. Actually, there was a comment about Event Hub saying that somebody tried it and it did have great throughput indeed, but they also ended up actually using Service Bus instead for being a more mature platform. I don't know if you want to comment on that or if you had similar experiences or not.
Yeah, I would agree with that quite a lot. I think eventually, I wouldn't be surprised if I go into the office next week and say, hey, we're going to move to Service Bus. It is more mature, it's more enterprise ready. And again, some of the dead lettering stuff that we've done, it kind of seems like an overkill, over engineering stuff, which, yeah, it's not ideal.
Yeah, fair point. What is the retention period that you use for Cosmos DB? For use case, did you have any use cases when the data gets corrupted or accidentally deleted, where retention period, specifically the TTL, might be effective?
So for our retention period, we've got to keep it to 7 years. That's a compliance issue. We haven't had any issues for when data gets corrupted or accidentally deleted. If you are experiencing those kind of issues, I would really opt for stronger levels of consistency. So either opting for Cosmos DB has 5 levels of consistency, so you could go for strong consistency or bounded staleness consistency. But that does come with some performance implications. So because it's a strong consistency, operations takes a little bit longer to process, and also there's a throughput as well. It takes, I think, twice as many RUs to perform a write and a read, as it would say, more relaxed consistency levels.
That's fair. Now, another question asks, actually, there's a comment, and there is also a question at the same time for you, following up that the payment processing with events seems to fit the Saga pattern quite well. And the question is whether you guys have considered using Saga Swings, for example, and Service Bus or mass transit.
We not particularly, no. I'm not sure why we didn't consider it, but yeah, I can just say that we didn't really consider it at the time.
Well, I guess there is always room for improvement, right?
Yeah, totally. So there will be times where we'll need to perform compensating transactions. And with again, because we haven't been so strict with the way that we've implemented these patterns, we've actually been doing a lot of development around what happens when we do need to compensate, say, if an account doesn't actually have enough money to process a transaction. How could we compensate for that? We found that actually by adding certain events for compensating transactions has worked for us. So it's kind of Saga light, I think. So again, yeah, not quite as strict as the book says, but we've been quite flexible in the way that we've implemented it.
But granted, in my experience, when the book says something, the reality says not exactly the opposite thing, but it goes along the lines, pretty much.
Yeah.
You read between the lines when you read the book, I guess.
Totally. Yeah.
My favorite question, the last one, is if security was so strict, did you guys consider using Azure Stack as an alternative?
I don't think we did. Yeah, the answer is no on that. I'm not too clued up on Azure Stack, so I need to investigate that a little bit more. So the answer is no. Yeah.
Okay, that's all I picked up. Elder, do you have any other questions which I might have completely and accidentally ignored?
So there's one more question that's actually quite interesting. So how do you maintain integrity in the event source? Like when a payload changes over time and becomes compatible with previous versions.
When it becomes what? Sorry?
So how do you maintain the integrity of your event source? Like when the payload changes over time and becomes incompatible with the previous version.
So we rely a lot on Cosmos DB for that. So we use strong consistency within our application. We haven't really experienced any issues with corrupt data. We haven't really encountered that. Yeah.
Okay. So I would like to say thank you. It was a really interesting session. So I know it's getting late for you. So thank you for being here at the late hour for you. And
well, thanks for having me. This has been great. I would love to come to Europe when it's all safe again. And yeah, that would be awesome. But you know, thanks for having me. I really enjoyed this.
Thank you, and have a great day.
Yeah, you too.
Thank you so much.
Yeah, you too.
So next up, we have Amy and Henk that are going to talk about, just let me check that I actually pronounced it right, the age of applied AI. So just, here you go.
Hey.
Well, hello.
Good morning.
Welcome to you both.
Thank you.
Thanks.
Thank you.
So I just tweeted about your session that I'm looking forward to seeing or listening actually how many times you're going to mention Skynet, because every time I talk to somebody about AI, especially obviously when they're not in the field, Skynet comes up as a conversation for some reason. Well, your audience is definitely much more advanced than these individuals I'm talking about, but nevertheless, Skynet is kind of a joke in AI, isn't it?
Absolutely.
Yeah. I don't want to ruin it for anyone, but I actually don't think we're going to mention it at all. But we'll see. We'll see.
Maybe once, just to keep it at a minimum.
So how are you doing today? Like, I'm really looking forward to this session. Like, AI is of course very big. So. But I know that you both have been working with AI for quite some time. So how do you see the whole AI progressing? Like if you look back like 5 years ago, when I know you were already talking about this, and where we are now, like how do you think that AI progressed over the years?
So Hank, you take this one first. Let me just, I think I have some echo, so I'm just going to try and sort a little bit of audio whilst we're live, because we love that.
Absolutely, yes. So it's evolved a lot over the past 5 years. maybe not as much in time of different algorithms and different things you can do with it, but more about how you can actually use AI as a developer from now. Like, I think 5 years ago, that was the first time I heard about cognitive services. And over the past years, a good example many people talk about, of course, is the custom vision service. And I think that is the main thing we achieved in the past 5 years, to make AI understandable and accessible for developers to actually use it in production scenarios. And it's like it moved from the research labs where we're trying to invent algorithms and things, and then now we're actually building things with it. And we're seeing more and more of those things come to life in actual projects.
Awesome. So I'm looking forward to hear more about this. So let's start your session. I will grab up your screen and we are really going to enjoy this.
I hope so. Hello everyone, and welcome to our talk, The Age of Applied AI. AI is going to take a huge impact in everybody's daily life, embedded in everything we do. And this talk is really about where we came from and emphasizing that each of us has a huge responsibility in terms how we make AI work for good and ethics of how AI will work for everyone. My name is Henk Boelman, Cloud Advocate at Microsoft, and I live in the Netherlands. And I'm really excited to take you on this journey through the AI landscape, where we will find out what AI actually is and learn what is possible now.
And hi everyone, my name's Amy Boyd. I am also a cloud advocate at Microsoft and I live in the UK. Along with what Henk said, we're going to dive into the past, the history of AI. We're going to talk a bit about what we can do today with AI, and then we're going to use the saying, just because we can doesn't mean we should, and apply that to responsible AI.
We have divided this talk in 5 chapters. In our first chapter, Amy will take us through the history of AI. Then we talk with Seth Juarez about what AI actually is, see what we can do with AI, and dive into the ethics part. Let's not waste any time. Amy, the stage is yours.
Okay, so I want to briefly talk to you about where it all started, the history of AI. We're going to give you a few different segments. I highly recommend going and researching a little bit more yourself. But we'll start in 1950. In 1950, there was a gentleman named Alan Turing, and he created the Turing test. When he did this, he speculated about the possibility of creating machines that think. This could be said to be the first time we've truly started to think about this idea of intelligent machines. And it wasn't long after that in 1956 we saw the Dartmouth Summer Research Project. Now, the Dartmouth Summer Research Project was led by John McCarthy, and he got himself and a lot of his reputable colleagues together, and they started and named the field of artificial intelligence. They used this quote to proceed on the basis of conjecture that every aspect of learning or any other feature of intelligence can in principle be so precisely described that a machine can be made to simulate it. And so this was the original definition of AI, and we know that AI has changed almost its expectations and its definitions over time. So let's take a look at a little bit further on in the AI cycle. So from around this time, 1956, all the way up to the mid-70s, this was where we saw the gold rush of AI. This was where research was being extremely well funded, optimism was through the roof, and everyone was really excited about what this new type of technology, this idea of intelligent machines, could start to do. Some of the good examples include things like Shaky, the robot, who was able to maneuver and make logical reasoning tasks. We also saw what you could call the first chatbot. called Eliza. And Eliza was able to converse with people, and people thought that they were talking to a human. We also had things like Block's World and all sorts of other different new AI ventures. But unfortunately, it didn't last too long. Through the mid-70s into the early 80s, we saw an AI winter. Now, in research, a winter means that funding stops being given, so ceases to exist. And unfortunately, optimism is lowered on what is actually possible. This can happen for many different reasons. Let's explore a couple of them. So these 4 symbols show some of the issues that might have come up during that AI winter. So one being compute power, the limited compute power that we had in the mid-70s to 80s. Then also looking at combinatorial explosion. So this idea of the amount of parameters or the amount of options that need training in an artificial intelligence agent. This was too much given the power, and also when we start to really optimize algorithms, we start to see better choices of combinatorial explosion. We then start looking at the data. We take advantage so much right now of how much data we have available, data we can create even. At the time, there was not as much digital data, and this did hinder the process of creating some powerful algorithms. And then finally, framing the problem. So thinking about the question that we're going to ask of the AI. Were we asking the right questions? Were they narrow enough? Because we know that AI can be good at, incredibly good at one thing. It was also during this AI winter and with these issues that we saw quite a lot of criticism of approaches. So we burst through with huge optimism, but sometimes we do have to critique each other's work so that we can continue to progress. At the time, there was criticisms on the Turing test by John Searle and his Chinese room theory, but there was also criticisms based on things like Eliza being the first chatbot and whether it was ethical what Eliza was doing in all the different forms that it was available. During this time and as we progress forward, Marvin Minsky was known for talking a lot about scruffy versus neat AI. So neat AI being this idea that you have lots of different options and trees and logical reasoning behind the applications of AI that you would build. Scruffy AI became something slightly different. It was this first idea that you have an object, they describe it as a small bird. If you have a bird, there's this whole world that lives around this bird, all the different things that you associate with birds or that bird would associate with life. And that was the idea that people started to build. They built them into something called scripts or frames, and interestingly enough, it's said that this type of technology actually led to some progressions in object-oriented programming. Into the 1980s, we were starting to get somewhere in production. Expert systems were becoming really popular because they became the focus of AI, given their huge business impact. People were saving millions, and they were finding it incredibly useful to their business processes. This was also the time, probably a little bit more behind the scenes in research, that there was the revival of something called connectionism. Now, myself and you, we might know connectionism actually by a better name now, which is the application of neural networks. So things like Hopfield net, backpropagation, and applying these different processes to neural networks was a real step forward and something that was being revisited. Just before the early 90s, AI hit another cold wind, let's call it maybe, over an AI winter, in the sense that these expert systems that were showing such value for large business were actually really struggling now to maintain them. The hardware was really specialized, and this was at a time where we were democratizing other technologies. So we were starting to say things like a personal computer on everyone's desk and all sorts of other things in the space as well, that actually it was all about giving it to everyone and not keeping it for certain people. During this time and in the 90s, we started to find that a lot of different AI approaches would come out of things with faces or things with human-like appearances. This was the promise of AI, the introduction of robotics. And we started to see everything that came out of our AI felt like it had to have a face, which was not always the case, and we know that now, that it doesn't necessarily have to have a face to be incredibly powerful. And during this time where we saw AI with a face, we also started to see all of those issues that we described in that first AI winter coming into fruition. We have much larger scale compute power, we have an excessive amount of data, we're getting better at framing the exact question that we want our AI to answer, and we have algorithms that are getting incredibly optimized for different approaches that you're going to use. And so all of these things meant we can keep pushing forward with AI projects. And so we kind of get to the now, and I have these pictures of jigsaw pieces because artificial intelligence started as a single area. Over time, it's broken down into different jigsaw pieces or different segments. That means different parts of the AI spectrum can be focused on in a certain way. It also means, if you ever heard it, if someone says, oh, someone's an expert in AI, they probably absolutely are. But one of the interesting things is, what specific parts of AI have they been working in? Because they all follow and all cross-collaborate across the different areas. Sometimes AI can feel like too much of a broad term, and so these jigsaw pieces have helped us really understand what's possible with AI. And so in this segment, I've taken you on a really whirlwind tour. I highly recommend going and researching the history of AI yourself. It's fascinating. So now we've talked about where it's come from, I'm thinking we're going to go and explore a little bit more about what it actually is, AI.
It is so fascinating to see that AI has been around already for so long. From the first moment the term AI became a thing, and now we are creating self-driving cars. But I want to take a step back and talk about what AI actually is. Let's call our colleague Seth Juarez and ask what his thoughts are. Hi Seth.
Seth, you're on mute.
All right. Can you hear me now? All right. Okay. Hello there. My name is Seth Juarez, and I'm so grateful that Hank and Amy have invited me here to talk about a couple of concepts that I think are a good overview for how you should think about AI and machine learning. And what better way to do that than to have my handy dandy blackboard. So if you look over here on my blackboard, there's usually a couple of terms that are used interchangeably, but they're not exactly the same. The first one's AI. The second one is machine learning, and the last one is deep learning. It turns out that these things are kind of the same, but not really. So let's start with AI in general. So AI actually includes all of these other things that are noted here. AI actually has as a sub thing of it machine learning and then deep learning as well. So let me draw this out. And then finally deep learning over here. Now, here's the thing about each of these, because I want to make sure we know the separation. AI is actually a really old concept from the 50s. And it turns out that the AI that has worked the best and probably seems like the most intelligent are the things that we do like for games, like a computer playing tic-tac-toe and chess. These things turned out to be search problems, but intelligent search problems. And there were some cool algorithms like A-star and Minimax, which were very good at doing these kinds of searches for games. And it turns out that the search space was fairly small. And so imagine a scenario where you could literally look at a move that your opponent was going to do, see all the moves that you could do, and then you could search for the best one. It turns out that the search space started to get large in certain classes of problems, like looking at an image and knowing what's in it. So machine learning is another way of doing AI, but instead of having a search space to crawl over, you instead give the machine examples of the right thing and it figures out what to do. There's some cool algorithms like decision trees, SVMs, k-means, naive Bayes, and of course, neural networks. These algorithms, basically you give it data and it produces this thing called a model. Now, deep learning and machine learning are fairly similar. Deep learning is basically a class of neural networks, but much deeper. Now, the depth of the neural network for it to be deep learning really depends upon the marketing person. But reality, it turns out that these classes of algorithms are very good at doing cool stuff with vision, with speech, and with text. Okay, so let's get into the process here, because I think for programmers, it's really easy, at least for me it was, to get confused about what's going on. And I'm going to talk now specifically about machine learning. So usually when we're writing something, we're writing a program, we have some sort of input, and then we write some sort of algorithm, right? And then the machine does some stuff, and then the out thing happens, whatever we want to put out. So for example, imagine a scenario where we're giving it a bunch of numbers, and we're supposed to find the biggest number, right? The algorithm just basically does a search, and then out comes the max number. Pretty simple. Now, the thing about machine learning, again, is that the search space is fairly difficult. I mean, how do you write a bunch of if, else, whatever statements or for loops to look at a picture and figure out what's in it? So what machine learning does is it swaps around what we traditionally see as the right way of doing things. So instead of having the algorithm here, we swap this over here. We put the output and the input in, magic happens, and out comes an algorithm. This is the basic part of supervised machine learning. Then this algorithm we can plug back in, and we're back to the way we did things before. And I think it's a pretty cool way to think about it. Now, to be super precise, and I want to make sure that we use the right terms, the thing that comes in is the data. The thing that comes out are what are called models. And so when you think of a machine learning model, think of it as a learned algorithm from the data that is able to make predictions or to solve the problems. And the things that go in here are specific classes of algorithms that produce models, like a neural network. And a neural network basically produces a bunch of numbers in a network such that when the data comes in, it is multiplied, other mathematical operations happen, and the output tells you how it wants to predict. Other machine learning algorithms like k-means don't really produce models, but they describe the data in a compact way. So it kind of could be thought of as a model. K-means, for example, will look at your data, and without any other information, it's able to group them in a precise way. Okay, so that is the summary, I think, of AI, machine learning, and deep learning. You can see here, they're all subsets of one another. When it comes to thinking about machine learning, we flip around the concepts of inputs and outputs and what actually generates the algorithm. And then for precision, when we're looking at the data science terms, the input and the output are the data that we give the system, and then the output are the models. Hopefully this is helpful. Thank you so much, Hank and Amy, for inviting me. We'll see you hopefully in a little bit.
Thanks so much, Seth. That was brilliant. So, Hank, even with Seth's brilliant AI demo, I think we still need to see it in action. It's time for a demo. Do you have anything that could illustrate how easy AI is?
I absolutely have. Let's dive straight into that. One of the great things that happened in the past years is that AI moved from the research labs into a space where developers can use the power of machine learning without having data science skills. At the moment, there are over 50 cloud-based services available that expose an AI model through a REST API. These services enable you to add cognitive features like object detection and speech recognition to your application. By using the provided SDKs in the program language of your choice, like C#, Python and Java, you can create applications that can see, hear, speak, understand, and even make decisions. And probably you've seen a lot of these talks in the past years about these services. If not, go to ak.ms/Age of AI, where we've created a guide to help you get started. Today, I want to show you a feature that not many know exists. Because some companies don't have the luxury to connect to the cloud all the time, or need control over their data. To solve that problem, Some cognitive services are made available in containers. Azure Cognitive Services in containers give developers the flexibility into where to deploy and host these services. They come in Docker containers and have the same API experience as when they were hosted in Azure, but give you the freedom to run them into your own infrastructure. Let's watch a small video about this capability.
Every time a technology has moved from the hands of the few to a wide variety of people, a whole new set of capabilities that we never even imagined suddenly come into existence and change the world.
Cognitive Services enables developers to take advantage of AI without being a data scientist.
Some enterprises don't have the luxury of being able to call out to the cloud all the time.
Now with Cognitive Services in containers, that opens up a whole new world of possibilities.
Containerization is really the act of packaging up an application that you can take and put on any machine.
Azure is the only cloud that enables customers to take cognitive services in containers and use them on their own terms, in their own control.
I can go from a development environment to a production environment fairly quickly and build on top of that and expand that.
For example, a remote oil rig may not have bandwidth to transfer all of its data back up to a cloud solution, but definitely has strong needs.
Let's say that you are a hospital and you have tens of thousands of handwritten documents and you need to start processing those. With OCR in containers, you can actually run the models directly over the documents without sending them to the cloud and get a digital version of all that information. If I was in retail and I wanted to process customer feedback about my products, I could run that through language detection and key phrase extraction. Being able to process my text with sentiment models helps me to understand if what's being said is positive, negative, or neutral. This is enabling an entire new set of applications and use cases for our customers to use AI that previously was not possible.
It's really exciting to see what other people are building on top. That's been amazing to watch, and it's really honestly humbling.
I hope this video gave you an idea about the capabilities and when you can use it. And to demonstrate how easy it is to use one of those services, I've created a small demo where we're going to take a text-to-speech container and deploy them in an Azure Container instance. In this demo, we're going to run a cognitive service speech container in an Azure Container instance and use the REST API to convert text into speech. I'm going to use the Azure command line interface to create all my resources in my Azure subscription. The command line interface, also called the Azure CLI, is a set of commands used to create and manage Azure resources. The Azure CLI is available across Azure services and is designed to get you working quickly with Azure, with an emphasis on automation. Everything in Azure always starts with creating a resource group. A resource group is a resource that holds related resources for an Azure solution. To create a resource group using the CLI, you must specify two parameters: the name of the group and the location where this group is deployed. The next resource we are going to create is the speech cognitive service. To create this resource, we need to specify a few parameters. Besides the name in the resource group, you need to specify the kind of cognitive service you want to create. For our demo, we are creating a speech service. When the speech service is successfully deployed, we can extract the properties we need for when we are going to run the container in the next step. The two properties we need are the endpoint URL and the API key. The speech service in the container is using these properties to connect to Azure every 15 minutes to send the billing information. One of the easiest ways to run a container is to use Azure Container instances. With one command in the Azure CLI, you can deploy a container and make it accessible for everyone. To create an ACI, it takes a few parameters. If you want your ACI to be accessible from the internet, you need to specify the parameter
DNS name label. Copy-paste the billing endpoint and the API key. The deployment of an ACI should take around 5 minutes. The easiest way to validate if the container is running is to use a browser and open the container homepage. To do this, you need to retrieve the URL for the container first. This of course can be done using the Azure CLI. Navigate to the URL on port 5000, and if everything went well, you should see this page. To test our service, we need to create a post request. There are many ways to do a post request, but I'm using a program called Postman for this. In the request, we can specify the voice we want and the text we want to have converted to speech. Let's give it a try.
Hello world.
Nice, that worked. In this demo, I've showed you how you can run your own instance of the Speech API in your own infrastructure, giving you full control over the deployment and where your data is stored.
To learn more about cognitive services in containers, visit ak.ms/Age of AI. I think this really shows how far we have come and how easy you can leverage the power of machine learning in your application. But with great power comes great responsibility.
You're absolutely right, Henk. And in this chapter, I wanted to talk a little bit more about responsible AI and some potential approaches we could take to it moving forwards. So let me ask you a few questions first. And when I ask you, would you trust an AI too? And then something on the end, I want you to really think about your immediate reaction to that question. So, would you trust an AI to recommend you a product or service? Okay, well, I use online shopping a lot, and so one of the things I find is those recommendations are often quite useful. They're quite targeted. They help me find something that I might like in a whole spectrum of different products. And so yeah, I would currently trust an AI to recommend a product or service. Okay, so the next question, would you trust an AI to help keep you safe online? This one's an interesting one, right? This one is, there are experts in their fields. They're probably much more of an expert than I am about different viruses that happen online. And so for something to be able to maybe flag things or tell me, when something's not quite right, or maybe act on it as well, I think I'm quite comfortable with that, given that I am not an expert. And so to hand that off to something that would be, it is something I would feel okay with. What about you? Have a think about it. So let's take a step up into the next section. So, would you trust an AI to assist your driving? This one's an interesting one, right? Until very recently, I would have been like, oh, I don't really know. But if something can help me know when there's going to be hazards, or if something can help me maybe like reverse into a parking spot or parallel park or something like that, then yeah, I'm more than happy for it to, as long as I have some kind of override capability, I feel fairly comfortable with that. So what about driving you? Would you trust an AI to drive you? This one is an interesting one. I'd say, oh, maybe, but then I think, oh, well, there's lots of car manufacturers out there that are creating autonomous vehicles, and we see them making their way through policies in various different parts of the world. And so I'm kind of like, yes, maybe sort of thing. I'm a lot closer to maybe yes than I am to anything else, but it's still an interesting one, right? It's still not something that I have personally tried. But I'm gonna go with a yes today with this one. Let's speed this up and take a slightly different direction. So would you trust an AI to monitor your health? I'm not wearing it today, but I do have a fitness device. It gives me lots of interesting data and it can give me great insights. So yeah, I would be fine with it monitoring my health. Okay, but would I trust an AI to dispense medication? Okay, this one's a little bit different, right? So this one is, you maybe start to see my pessimism here, but dispensing medication, it's obviously very critical if you need that medication. And so there is that immediate question that comes to mind for me, which is, what happens if it goes wrong? How am I alerted? There's a lot more for me to unpack there before I'm able to answer that one. And that's okay. That's okay to have questions about it. So this one is where we're going to go into a little bit of a case study. So would you trust an AI to help you choose a babysitter? So someone who's going to care for your child, your nieces and nephews, your family members, someone that you care for. Would you trust an AI to choose that person? Well, let me take you on a little journey where we can break down whether we would or whether we wouldn't, and what extra questions we might want to ask of, would we trust an AI to help us choose a babysitter? Okay, so we have an example family here, and they are looking to choose a babysitter for their child, and there's lots of people in their area that might be interested in doing something like this. And company X here, as an example, would go ahead, and the idea is they would evaluate based on these people's social media accounts whether they should be recommended for the job. Okay, so, and then we can see that there's lots of different things that they can actually measure each person by. So they take their social media account and they maybe look at things like, do they have disrespectful attitude? Is there any explicit content? What are some of their flags posts, etc.? And this is how they would bring together a score that would help you choose a babysitter. Okay, so before we evaluate our final decision on whether we would let company X choose as a babysitter, I want to talk to you a little bit about values and morals and what ethics, the word ethics, can break down into. Now, this is the word ethics not based on data, not based on AI, but just the definition of ethics in general. So you can see two different kind of sides: values based on the well-being of others, and values based on our own well-being. And under each of these categories, there's different things such as non-suffering, the ability for us to have autonomy, equality, virtue, so what are our core values, as well as trust and trust in others. So if these are all the different values that we have when we have ethics for humans, what can we do when we have ethics for AI? Well, that's where I'd like to introduce you to FATE: fairness, accountability, transparency, and ethics. FATE is actually a part of the organisation at Microsoft. You can look them up online, and they do a lot of research around this type of AI. One of the fascinating pieces when I first saw this framework by Michael Robson at Microsoft was the way that he broke each of these categories down into really core questions that we can ask ourselves of any AI situation. And so if we take an example of a few, please feel free to take a look at these in more detail afterwards. You can think about, is anyone being treated differently? Well, yes, I guess if you think of the situation with the social media account, the first people I think of is, what if someone in the older generation who doesn't use social media so much, does that discriminate them from not getting a good score, a bad score, any score at all in this system? That would be something I'd like to know more about. Is the training data just based on a certain type of age group? You could almost build on that previous conversation and say, well, who was it trained on? What kind of different people, what kind of outcomes were expected? So that's kind of in that fairness category. If we move on to accountability, there's this idea of, can we give feedback or challenge the results and the mechanism for that recommendation? Is that ultimately a human accountable for that final decision, or does it actually automate that part of it? If we move on to transparency, there's this idea that, is it clear in this process to everyone involved that an AI is being used? Is it well described and understandable? Do we know its shortfalls is always an interesting one. Are we actually using it for an appropriate use? And then finally, ethical. Is there any social implications? Is anyone discriminated against when using this system? Could there be any unexpected behaviour or human monitoring that could disadvantage people? There's so many different ways you could dive into this framework and use it to analyse your different AI solutions, just like we can with Company X. This framework shows that every person has a role in building responsible AI and that this should be built in right from the first day. We've seen lots of different aspects of AI solutions so far in this session, but in the next chapter, let's talk a little bit more about whether you should build or buy an AI solution.
As we have seen in the previous chapters, there's a lot of things that you have to take in account when you're creating a machine learning model. So when you're starting with an AI project, it is always good to ask yourself the question, am I going to build an AI component or will I buy it?
And so if you think about the 80-20 rule, 80% of the problems that you might want to solve with AI can probably be solved with a solution that's already available in the industry. So a really good example of that is the Azure Cognitive Services. Let's take a look at a system where I take an invoice, analyse it, extract values, and then use them in an application. So here we are in the Azure portal, and the first thing we want to do is create a cognitive service that is the forms recognizer. To create anything in Azure, you go up to the menu and click create a resource. To find forms recognizer, you can simply search for forms and forms recognizer will come up. Click create and fill in some simple details in order to create this instance. Here's one we created earlier. Here's the icon for it. If we click into this resource, the main thing we're going to need to use are the keys and the endpoints in order to train and test our Forms Recognizer API. So what does the code look like when we start to train, retrieve training results, analyze a new form and get those results? Well, here's 4 simple curl commands that can get you started. So we need to start by training the model. To train the model, we're going to pass 5 example forms to the Forms Recognizer API, along with a content type, a subscription key, and then the link to the actual documents that I want to train on. I have 5 forms that look a little bit like this. They all have a similar format, but what we want to do is extract all of this specific information per invoice. Once I've trained my models, I can retrieve and review the training results. But one of the things that we definitely want to do is test our training, and that's where we can analyze a new form. We send it to exactly the same API, but this time we have the model ID and we pass that in from the previous calls. We pass it the content type, the subscription key, and then this time, instead of a link to the training documents, I want to send it to one single invoice to test. Once that's sent, to actually get the full results, you call the results API with the output of the analyzed form. So let's see that in action. We can see there's a large JSON response, and I can format that and view it by using Alt, Shift and F. And we can see that this call succeeded. It now has these key value pairs like name and address, etc. And as we continue down, we can see postcode, company, city, and so this has broken out all the information we need from our forms. Now I've trained the Forms Recognizer API, I want to build it into some form of automation. Here I'm going to use Azure Functions. I have some sample code that allows me to call my Forms Recognizer API endpoint using HTTP requests. I have those fields that we recognize from our form, And I've also added in some of the details such as URL endpoint, API key, and the specific model ID that I want it to recognize from. You can use the Azure option on the left in Visual Studio Code to publish this straight to an Azure function. Our Azure function is sitting inside the Azure portal, and when you go to the code and test option, you can actually test this in the portal to see if it works. So we've created a post method and we've provided it our test invoice, just like we did with the curl commands, plus a SAS token that allows us to access it. In the terminal, we can see that this executed successfully, and in the HTTP response, we can see all of those key value pairs now nicely aligned from our JSON response from Forms Recognizer.
That looked great, but there was still a good amount of code to put together. Can you create an application that can leverage AI with no code at all?
Yeah, absolutely. So AI technologies, just like all other technologies, are making their way down the democratization scale. And so you'll start finding there's software as a solution offerings to the things that you're trying to solve. So packaging them into easy to use AI and putting it in everyone's hands. Let's take a look at exactly the same scenario, but this time we're going to use the Microsoft Power Platform and AI Builder. Here I am in the Power Automate Studio. This is part of our Microsoft Power Platform, a software as a service offering for creating flows, apps, and also something I want to show you called AI Builder. So if I scroll down here and click on Build Model, AI Builder allows me to create these tailored AI models and add them to my processes as well as my applications. So we can see there's lots of different types of AI, and we can also just go to some straight away, some pre-built AI. However, we're going to go on forms processing in order to train it to recognize our Tailwind Traders invoices. I'm going to give this model a name. And click Create. I'm going to tell it some of the fields that I want to extract from this invoice. So I'm going to extract name, invoice number, and total. You can also add tables, like for example that we've got in our invoice. I'm going to click Next. Now I need to provide it my 5 training documents. I add them to a collection, and I'm going to upload them from local storage. They've uploaded successfully, and I can see a sample here. I'm now going to get them to analyze the document. This will identify structure, detect fields, and extract values and pairs. So it's analysed my form, and as you'll notice, it's picked out where all of the text is. Now we need to select these fields so it can pair up the key value pairs. So for name, I'm going to highlight the name just here. For invoice number, I'm going to highlight the invoice number. And for total, I'm going to select the total. I've completed one document. I just need to do this on 5 other documents. You'll notice in the document, it's actually automatically recognised these fields for me. So that was nice and quick and easy. I'm going to click Next. We can now see my model summary, where the data's come from, and the details as well as the number of images that I've used to train. So I'm now going to train this model. It's going to learn about my forms so that I can submit new forms to it. We can see that my model has been trained. We can see a sample here. We can see the selected fields. Let's do a quick test to see what it does. We're analysing a form we've not seen before. And we can see that it's picked out the name, the invoice number, and the total. in order to build it into, say, an automation or an application, we actually need to publish this model. Now our model is published, we can use this model, and I'm actually going to create a new app that inserts this specific forms recognizer component on the canvas. So if I click new app, we can see we've landed in an app, and it's actually brought in this analyze forms processor widget into just a very basic app. So the first thing I'm going to do is test it out. To test out an app, I can click on the play button. I can click on the analyze button, choose an invoice, and we can see it's found the name, the invoice number, and the total. From here, I can start to personalize this app to look more like the Tailwind Traders application that their finance team will use.
So in this chapter, we've seen the scale of building versus buying AI solutions. There's always trade-offs no matter what option that you choose, but knowing what is available to you is the first important step you need to take when building AI solutions.
This brings us to the end of our session. We've covered a lot of ground, from the history of AI, found out what AI is, and seen some great examples on how you can use AI services in your applications. I hope you enjoyed it.
If you want to continue your learning journey, go to aka.ms/age-of-AI to find out more. Thanks so much.
So first of all, that was an amazing production. Thank you.
Definitely wasn't pre-recorded, and look, we're even wearing the same stuff, right?
Pre-recorded not, it was still mind-blowing if you ask me. The capabilities that you can do these days with AI are almost out of this world, right? But there were some comments in relation to companies abusing the term AI. And regretfully, you've definitely seen this as well. Would you like to add something to that, or maybe comment on top of that?
I'm happy to kind of take this one a little bit. So I think one of the best ways to probably look at it as well is that AI has like changed significantly over time. When we look at that history of AI, we're going all the way back to the 1950s, and what was deemed AI then, like, this sounds really bad, but we would probably laugh at now. Do you know what I mean? And we'd be like, what? That's just, you know, any programmer can do that. We can probably create that with a Power App. Do you know what I mean? Like, I think we've moved on. And so, I mean, I say this to Henk all the time, like when we're on calls, I'll be like my expectation of technology in general, my expectation of customer service, my expectation of people understanding me from all different businesses, I am just a number at the end of the day to them, but I expect to have that personalization now. And so I think as we go through and we get better and better at including AI in products, I think we are going to look back and kind of go, oh, that's not AI, you don't get to call it AI, and all of that kind of stuff. But realistically, if we focus more on what's useful, sorry, I've just lost an AirPod there. And kind of think about kind of that side of AI where we go, actually, this is useful for me, and that's why I use it. I think that's probably the best. I know that's very optimistic view, but definitely consider where we've come from, because that might explain why AI is such a large umbrella.
Yeah, very much so. I fully agree with you, Amy. And I believe that we find ourselves in a position where we are eager to use and consume AI, right? So it's probably just the companies abusing the term because, well, for marketing purposes, probably first and foremost, because you both know, Henk, yourself, Elders and myself and everyone else probably watching us are eager to, well, have Roombas around the house and whatnot, to automatically map our house and determine when's the best time to actually start vacuuming. And even when you think about self-driving cars, there was a fantastic comment regarding self-driving cars. We are ready to get into a self-driving car, but what about the rest of the traffic, right? How do the other humans react, behave, and even anticipate a machine moving or maybe just shifting lanes, right?
Yeah, the self-driving car one was an interesting one. Just all those questions in general. Thank you for those who took part in the poll and kind of voted as well. We were able to see it in the back scenes here. But the fascinating thing there was always kind of like all these questions are things we suddenly get used to them. Interestingly, some people didn't feel good about recommending a product or service. So I thought that one was quite funny because I was like, oh, that one's a no-brainer. Like I'm literally who they design it for. Like they recommend something and I'm like, yeah, I'll have it. Yeah, I'll have it. So that's my problem. But also kind of on that other side for the driving one, my husband, for example, he's like, but I actually quite enjoy driving. Like I don't want to have a car that drives me, whereas I'm the complete opposite. Like if something can park for me, I'm like, go ahead, do it. So I think it really matters on the person and just the comfort level as well. But that framework for asking questions as to whether we feel good about that is really important. And also for those who are building it.
Very much so. I agree with you totally. Actually, there was a comment from Glenn earlier who was saying that somehow AI always recommends him to buy Lego stuff. Wonder why that is.
That must be the same.
There is a term I came across, which is responsible AI. Oh yeah, totally, Elder. So there is this term, responsible AI. Do you want to elaborate maybe on that a bit?
Sure, yeah, happy to. So responsible AI, there's loads of great resources out there. Number one, like take this presentation as a 101, a starter for you to go and explore more. Like go Google it, go do that, go find out more for yourself. But responsible AI has become a really, really important term within AI because I think it doesn't matter how many things we create, we all see the media and the news when things aren't going quite right. There is also then an element of that's it's not necessarily okay, like to put that out into the public, but realistically, if we're learning from it, that's the key. And so I would say responsible AI is all about sharing our experiences, sharing our different knowledge so that we can get this kind of messaging across the AI space that it just becomes second nature to think about actually how is someone going to use this product in the real world? If I use it, actually is someone in another part of the world able to use it, or is that going to kind of discriminate against someone? Asking these questions early reminds me of building security into solutions. So the idea of if we design it in last, right, it's more expensive and it's not as good. I feel like it's the same kind of idea here with the responsible AI.
Yeah, I fully agree. Now, I do have a question because you have mentioned this over Discord. How do people get started? How can they learn more about things, about AI, and implement AI in their application straightforward, like immediately if they can?
Oh, Henk, you take this one because you created all of our links for us.
Yes. So the best way to get started after this presentation is to go to ak.ms/Age of AI. Where we have created all these learning resources for you. So I can imagine everyone that watched is in like a different state of when he or she is going to build AI solutions. Do you still need more inspiration to find out what is actually possible? There are links for if you want to learn how to actually do that, like training courses on Microsoft Learn, like also the Cloud Skill Challenge that is running to actually have some education and get your certification. And then there are links to our Microsoft Docs, our documentation on how to actually implement it and play around with code. How you can build it yourself. So we split up our links on that page in 3 sections. And then finally it closes off with some links to get a little bit more inspiration about the general thing of AI, like the AI show it set is there, there's Learn TV. So we have a lot of resources in Microsoft to get started, but it all depends on where you are in your learning journey.
And if I may, I would still add 2 of them, which just came to my mind. Number 1, I remember reading on Discord something about a challenge, not a cloud skill challenge, but a challenge specifically designed for Azure Lowlands. Is that correct?
It is a cloud skill challenge actually designed for Azure Lowlands. It runs until Wednesday. And everyone who completes it, we will pick out the names. We will shuffle the names, and then we will pick out 3 winners that will actually get a Microsoft backpack.
Is that an AI backpack?
No, it's just a plain.
Don't answer that question. That's a silly one.
There are lots
and
of weird
the second
AI
place,
things
however, and this is a movement, a community movement that you both are engaged in, is the global AI community. Why don't you tell us a bit about that as well?
Perfect. Yes. So Willem Mijns from the MVP community and a lot of other AI MVPs are running the global AI community. We had I think there was a boot camp 15 days ago, but because of the pandemic, it was not that big. But I heard they've planned a lot of events for this coming year. So if you want to learn more, everything is on globalai.community.
That's brilliant. I'm looking forward for the next events, actually.
So with that, I would like to say thank you so much for this awesome session. I learned a lot about the whole history and where we are going with AI. So thank you for being here today. I hope you enjoy the rest of the day.
Thank you.
So we are going to switch up next to Karel de Winter and Wim Matthijssen. So let's bring them into the stream. There we go. Awesome. Let's move.
Hello, everyone.
Hi.
Hey there.
Thank you for being here.
How's it going?
Fine.
Fine,
Ready
thanks.
ready to start our session. But we don't have a cool green screen in the back, so it's just my office room. It was a great. The previous session was quite great, I must say. Quite impressive.
So you are going to talk today about the 7 habits every Azure admin must have. So what is your session going to be about? Can you give a little bit of introduction?
Yes, 7 is less because we have a lot of topics to cover, and we started out with 7. But I think if we do a session of 50 habits, I think we still get there. So it's probably a session that can go on all day. But to keep it in an hour in 45 minutes, we stopped it at 7. And we change them from time to time. So we already delivered this session sometimes, but we're always switching topics and other habits. And everything is evolving these days. So those habits also we change and switch to other habits.
Yeah, so it does sound like...
In the session abstract, you have mentioned that these are 7 habits for...
Go ahead.
Sorry about that. You've mentioned that these are 7 habits for new Azure admins, but one thing that I've learned throughout the years, I've been using Azure for the past 10 years, I'm still learning new stuff every day from other people's habits. I'm really looking forward for hearing and listening during your session on what your top 7 habits are.
Yeah, there are a lot, so it changes every time, and it's like you said, you start off somewhere in Azure. Some companies start off. They're just deploying resources, and it seems everybody does it in another way, but is there a specific good way? No, it's just a way that you are used to do it, and then how you can quickly do those things, and then how to get started, and learn by doing it, and learn new tips from other people, and there are a lot of blogs around these days, and videos and conferences, and every time you learn something new, and I think every time we can put some things in new habit. So it's always learning, like they say.
Very much so.
Definitely. So I want to let you start your track, but before we start, I want to quickly call out to everyone at home, like join Discord, join us in the conversations going on there, say hi to our sponsors. If you have any questions, place them either in the chat on the streaming service you're using, or also place them on Discord. And with that, I'm going to hand over the session. So let me just...
Thank you.
And then I will start sharing my screen, I think. That's your screen, I think, Carl.
It's correct.
There is. It's flickering, I think. There's some blur in it. Let me share my slides. Okay, let me go back some. I think my slides are showing now, Carl?
Yeah.
Okay. So hello everyone, and welcome to our session at Azure Lowlands. Our session is titled 7 Habits Every Azure Admin Must Have, and it's a new version from 2021. First of all, we want to thank the organizers and everyone involved for setting up this event and for allowing us to deliver this talk. So we also want to thank all sponsors, because without them it would be quite impossible to set up an event like this. So on the agenda today, first we'll briefly talk about the responsibilities that the new Azure or Cloud Administrator role entails, a new IT role you now see a lot within companies. Then we will talk about our 7 habits every one of those Azure admins, in our opinion, should have. Between those habits, we also have some demos. And at the end of the session, we'll also go through the key takeaways to really focus on the things you should remember about our session. And I think completely at the end, we have a Q&A where we would love to answer any of your questions. So let's get started with a short introduction. My name is Wim Matthijssen. I live in Belgium and I work as a cloud architect. As a Microsoft certified trainer, I also deliver all kinds of Azure workshops and trainings. Community-wise, I'm a founding board member of a Belgian user group called MC2MC. Like you can see on the slide, I also have my own blog, https://wimmatthijssen.com, where I blog a lot about my daily experience with Azure and all related Microsoft hybrid cloud services. And like most IT professionals these days, I'm also on Twitter and LinkedIn. So if you ever want to reach out or just want to say hi, you can always contact me through my Twitter handle or through LinkedIn. I think that's me in a nutshell. I will now let Carl introduce himself.
Yeah, thank you. So hi, everyone. For me, very short, my name is Karel de Winter. I'm a cloud solution architect working for Dexmark. It's a Belgian company. I'm also a Microsoft certified trainer, and I'm a member of the Tech9 user group. So that's another Belgian user group. We have a lot of user groups in Belgium. So it's a very, very kind community. And if you want to reach out to me, the best ways are Twitter, LinkedIn, or you can read also my blogs on the site here on the slide.
So probably some of you took their first steps in IT working as a support or system engineer or a sysadmin for a company who owned their own on-premise data center and infrastructure. As an on-premise sysadmin, you were responsible for almost everything in the data center. You not only needed to keep all servers up to date and do all the new server and application installations, but you probably also needed to do all the cabling and racking of the servers and troubleshoot almost every IT-related problem. But in this modern hybrid cloud world, where cloud is becoming more important for almost every business, I think, the sysadmin role is going to transform in something else. It will kind of evolve into a cloud admin role, or in case of Azure, in an Azure admin role or an Azure administrator role. And for a lot of people, we hear this sounds like they're going to lose their job or their role is going to be less important. But in fact, it's more a case of how more things will change, the more they stay the same. In their changed role, they still will be responsible for building, managing, protecting, automating, and optimizing this new hybrid cloud environment. Just like they did before when they only worked on premises, because yeah, the cloud doesn't run itself. Depending on which cloud model, cloud service model you run your workloads, is it IaaS, is it PaaS, serverless, or SaaS? There will always be a shared responsibility where Microsoft will manage everything until a certain point, but you as an Azure admin also have some responsibility. This can be managing your IaaS VMs by foreseeing it from Windows updates, antivirus, or backup, or only managing the databases and databases, for example, when you're running Azure SQL databases. So let us go ahead now with some habits that those new Azure admins, in our opinion, must have. And I think, Carl, you can start with the first one.
Yeah, so the first one is the Azure toolkits. If you want to manage and protect your Azure environment, what tools do you need? And what if you don't, for example, have a PC to log into the portal and fix issues? Well, let me show you. So if you're working with Azure, you should have some kind of toolkits to manage Azure. And first of all, maybe a quick question, a question I always ask, and you can respond on YouTube or in the comments. Did someone ever build a test environment with very expensive VMs or a very expensive service and just woke up in the middle of the night to realize, oh, damn, that environment is still running. I have to shut down those VMs or just stop the service? Well, I have to raise my hand because I did once. And I will tell you how I fixed that with the tools here on the slides. So the first you all know is the portal. So you have the Azure portal where you can manage all your services, but you also have a portal app that you can install on your PC. So with the portal app, you can just connect to the Azure environment without the need for a browser, and it looks completely the same as you are working on the Azure portal. If you are working just with Azure Active Directory and you don't want to have configuration of the other Azure services, you can just access the Azure Active Directory Admin Center. That's a specific portal just to manage Azure AD. And if you want to test out new preview features, you can use the preview portal. But quick tip here, don't use it in production because with preview features, you don't get support from Microsoft, and that's a big problem. And for me, the very important part, the most important one is the mobile app. So the mobile app saved me that night. So I could just run the app and then kill the services or delete the VM. And it saved me a lot of money. So just install the app. Maybe it will save you money also one day. Okay, so as you can see, these are the tools what Rambo should use or will use if he was an Azure admin. So first of all, we have the Cloud Shell. The Cloud Shell is very powerful. You can run Azure CLI commands. You can run Azure PowerShell, but also Docker commands. You can, from that environment, from that cloud environment, you can manage and configure your whole Azure environment. We also have the Storage Explorer and the AZ Copy if you want to migrate data from your own or your hybrid environment to a storage account. You can use those tools. There is also the Windows Admin Center, and now there is a preview that you can access the Windows Admin Center from the Azure portal to have your hybrid configuration. A tool that I use very often is Visual Studio Code, so you can write your R templates or even your bicep files, and I think the next session will be about bicep, so they are definitely going to use that tool. And some other tool I use a lot is the Windows Terminal, where you can run Azure CLI, but also PowerShell and even the Cloud Shell in it. Quick something about Azure Lighthouse. Maybe you don't know about Azure Lighthouse, but what if you have multiple environments or multiple subscriptions and you want to use them or configure them in from one management perspective, while Azure Lighthouse brings you the capabilities of managing multiple subscriptions across multiple tenants. So it's actually based on delegating access to other users, and Azure Lighthouse helps you to manage other environments. Whether you are an MSP or you're a large enterprise, you can also use that to manage multiple environments. Okay, so Wim, let's talk about the next habit.
Yep. So for our next habit, the second one, we will talk about remaining future-proof by trying to think beyond IaaS, because where we're going, we don't need VMs anymore. So when moving on-premises resources to Azure, the first thing you need to think about in the assessment phase is choosing the right cloud migration approach to really make your cloud journey a success. You not only need to check if your business is ready to move to the cloud, to Azure, but you also need to validate if your IT people, the people who will manage the environment when it's migrated, have the right skills to support such an Azure environment. Next to that, the 5 Rs can help you to see how an on-premise workload or application can be migrated to Azure. You have rehost, or like they say, lift and shift, where you simply pick up an on-premise server, is it physical or a VM, and just place it in Azure. You can also refactor or re-architect, where you're going to rethink your workload before moving it to Azure to make it, for example, more high available or scalable. You can also revise or re-platform your workload, where you migrate your on-premise workloads to a PaaS service, for example. And then finally, you also have rebuild, or you can rebuild or rewrite your application. Or you can even replace it by a complete SaaS application. So what we see a lot in companies, that depending on who initiates the move, is it IT or is it business related, mostly different types of one of the 5 Rs will be used. When IT mostly initiates it, and when it's a timeline-driven migration, we see a lot of lift and shift as a first step. And when the trigger mostly comes from business itself, you see more refactor, re-architect, or rebuild migration scenarios. Luckily, there are some resources that can help you choosing the right migration approach. First of all, you have the Microsoft Cloud Adoption Framework, or CAF. It's a collection of documentation that provides you with implementation best practices and tools. If you're architecting your new workloads, the Azure Architect Center is also a good resource. Here you can find all kinds of implementation examples which can guide you in making a good design. Of course, you can also use Azure Migrate. That's an Azure service which can help you in discovering, assessing, and migrating your on-premise workloads. But Carl is going to talk a little bit deeper about that one in the next topic. And if you're not sure how to get started with your cloud migration, you can always check out the Azure Migration Program. Here you can find the right help by asking for guidance, or you can contact a migration partner. And a thing we also want to mention is that there is also a Microsoft Learn course available, which you can follow these days. It will help you to get familiar with Azure landing architecture at enterprise scale, and the critical design areas to build and manage your Azure environment. So when making your design, you also need to start thinking, like we said, beyond IaaS VMs, and try to use a more cloud optimized strategy. So you can look into container instances, AKS, app service, service fabric, and Azure functions, or other Azure compute options, instead of just deploying or lift and shift VMs. The flow charts on the slide, which can also be found in Microsoft Azure Architect Center, for example, can help you to pick the right candidate for your compute service. And when your first approach was lift and shift, you should always try to not make it the end state. For example, you can switch from an IaaS file server to Azure Files, or from an IaaS domain controller, you can start using Azure Domain Services. To replace your IaaS DNS servers, you can look into Azure DNS or Azure DNS private zones. And for people, for example, still working with print servers on-prem, you can now use Universal Print to replace them, which is currently in public preview. So I think it was this for the second topic. So Carl, you can go ahead with the third one.
Yeah, so let's dive a little bit deeper in how you should think about migrating things to Azure. So why do we need a migration strategy? Why is it so important to think ahead and look at all those possible solutions that you can use in Azure? So, well, because migrating to the cloud all depends on the application landscape you have. And if you go to the next slide, I will show you. So you have to look at the current application you want to move and see if you can rehost, refactor, rebuild, like Wim said. But if we look at the possible solutions that we see that are much used these days, you have services like Azure Web Apps, so to migrate, for example, your IIS server to a PaaS service, and then you don't have to manage the underlying service anymore, and you have the auto scale by default. Even if your application can be containerized, then Azure has a very simple and quick solution to host your containers. So for that, you can use the Azure Container Instances, and the container image you can then store in Azure Container Registry, and that's like the Docker Hub, but on Azure. And if your application exists on different microservices or multi-container layout, or different components, and you want the auto scaling and monitoring and the health checks and all those advanced features, then you can use Azure Kubernetes Service. So that's a complete Kubernetes solution on Azure, but you only have to worry about how many node pools do you need, how many and how big they need to be, and so on. So the complete Kubernetes cluster manager and all the Kubernetes management services that is handled by Microsoft. So you don't have to worry. You just have to worry about your containers. And another solution is if your application is containerized and you want to have the advantages of a web app, you can also run the container in a web app, and then you can use the scaling from the web apps there. And in preview now, you can also use Docker Compose, or if you have a multi-container layout, you can run that also in Azure Web App. One thing I want to talk about is the Azure Resource Graph. So with the Resource Graph, you can explore, query. One slide. Which tools we can use to all those different things. So like Wim said, we have Azure Migrate. We also have Azure Migrate Program. The program is an assistant by Microsoft, but the tools we can use is the Azure Database Migration Service. So that's a service in Azure that connects to your on-premises database and then can do the move of your data. We have the Data Migration Assistant to move your SQL Server data to an Azure service. And we also have the App Service Migration Assistant. So if you want to move your IIS server to an Azure Web App, the App Service Migration tool is very interesting. You just can install that tool, and it is going to migrate your data for you. So now I'm going to talk about the resource graph. So what if you want to analyze a current Azure environment that's very big? Well, for that, you can use the resource graph, and with that, you can explore, query, and do some assessment of your Azure environment. But something else, you can also, for example, measure the impact when applying Azure policies with the resource graph. So it's a very powerful tool. And here you can see some example queries. But in fact, let me just share my screen and have a look at just how it looks in the Azure portal. So if we can switch screens to my shared screen now, then we can see the Resource Graph Explorer. Yeah, so I'm here. I've opened the Resource Graph Explorer. I already have some queries predefined. And if I run the query, so this is a query that I can see all the resources by name. And some new feature here is you can format the results. So you have a complete list of all the types in your Azure environment by name. Another query is that we can filter all those resources by type. So you have a unique list of the resources and the types. So only the types you have in your Azure environment. And some other cool thing is, for example, if you want to know how many resources do I have in which regions, you can just quickly run a query, and you can see it's very fast, it's very efficient. You can also export those results if you want, and you can use that for an assessment of or for a migration, if you will. Okay, Wim, back to you.
Okay. So the slide is back showing, I think.
Yes.
So our next habit is Azure Cloud Spend to remain informed and in control of your cloud costs. Yeah, that's a slide. This one, I need this one. Choosing the right subscription type is an important step in your design process because they all have different rates, offers, and benefits. The ones mostly seen in companies are enterprise or Microsoft customer agreements these days, or CSP subscriptions. When you're using one of those, the prices for your Azure resources will be lower than when you're just using pay-as-you-go subscriptions. Also, be aware of your other software licenses, like those for SQL, for example. Further, know that when you, for example, have an AA or an MCA agreement, you can set up an enterprise dev test subscription, where you get special rates for some services like VMs and SQL databases. You should also know that there are some services that are always free for use, some with specific limitations. And for testing purposes, you should definitely take a look at Dev Test Labs and the Azure Marketplace Test Drive. For people who don't know, Azure Dev Test Lab do not have any additional cost to use the service. You simply pay for the VMs used. And test drives are ready-to-go environments that allow you to experience a product for free without needing an Azure subscription. So, for example, you can test out any firewall that you want to deploy in your environment or other resources. So definitely go check those out. A good way to lower IaaS VM cost is by using reserved instances, RIs, where you make a reservation of resources and capacity for either 1 or 3 years. You can also combine this with hybrid use benefit, in which you will use your existing Windows or SQL licenses with software assurance. Keep that one in mind for your Azure VMs or SQL servers running in Azure. And I think a combination of both can, like Microsoft says, save you up to 82% of your cost. Important to know is that you can not only use reservations for VMs these days, but also for SQL or for premium SSD managed disks, from P30s up to P80 disks, and also for a lot of other Azure resources, like you can see on the slide. Of course, there are still a lot of other ways to keep your costs down in Azure. First of all, always estimate your cost in advance before you start deploying or making a design. For example, you can use the Azure pricing calculator and the total cost of ownership or a TCO calculator. The last one is a tool to estimate your cost savings, which you can realize by migrating your on-premise workloads to Azure. When you're working on a high level or low level design, also keep an eye on design decisions which can impact your cost. For example, a resource can cost less when deployed to a different region, or when you design to use GRS, it's more expensive than using LRS. Of course, you can also delete all unused Azure resources, like, for example, unassociated public IP addresses or unused storage accounts or other stuff. And when, for example, you're still running IaaS VMs and they don't need to run 24/7, try to start and stop them during the non-working hours. These days, you can use auto shutdown directly from the VM blade in the portal for this, or you can use the start-stop solution through Azure Automation. There is also Azure also has a built-in free tool named Azure Cost Management, which really can help you to monitor and manage your costs across all your clouds. In this, even for AWS, you can use it to do analysis and define cost alerts to inform you when your consumption reaches a given threshold. Next to Azure Cost Management, to be able to control your cost, you can also use Azure Policy. This to set up specific policies. You can keep a form of cost controls and guardrail your environment. For example, you can set up a policy which only allows you to deploy certain VMs SKUs in your environment, or for example, restricts the creation of public IPs, or you can specify that resources can only be deployed in certain regions. But let me quickly demo it. Let me close this one. Okay, so my Azure screen is showing. Let me go, for example, to Azure Policy. Just go to the global search bar, type in policy. It's taking time. You can see I have already some policy in place. I also specify them at different scopes. So one is at my tenant scope, and the other one is at specific management groups. So you can split it up until the level of specific resources even. For example, I have one that's on my dev environment, on my dev subscription, that allows specific SKUs for virtual machines. If I open that one, for example, and if I click on Edit Assignment and look at the parameters, you can see I can select all VM types, SKUs that can be used. And for this one, I only selected the D series. I can also, for example, go to cost management. Just go to your sidebar. You can also directly work with it from the API, for example, if you want. Open cost management. For example, you can do any cost analysis. Then you can split up, see what every resource, see the pricing for specific subscriptions. You can even create budgets where you say that for a specific resource group, the amount that can be spent would be around 200 euros, for example. You can see I have a budget in place for this one. And a nice feature is the Azure Advisor recommendations, which can give you advice on specific cost-related resources you're running. So for example, if you're running high-end VMs and they're not using all necessary specs, it will advise you, for example, to right size or shut down the VM. So let me go back to the slide deck. And then I think, Carl, you can go ahead with number 5.
Yeah. So the next one is service health. So very important for an Azure admin is, you have to know when things are going wrong. And believe me, both Wim and I know that things can go wrong in Azure. So you have to be aware of that. And for that, you can use free services. It's very important to know these free services because they are very powerful. So the first one is Service Health. And that's a personalized view of the health of your Azure services. It's a free service, like I said, and it can notify you of issues that are impacting your environment. And it can also notify you what's the health of your environment. You have 4 different service health events that you can have. So you have the service issue, which informs you about your own Azure services. You can see when planned maintenance is going on, for example, on your VMs. You have the health advisors, but also the security advisory. So those are very important services you can know. And also good to know is that Service Health is integrating with Azure Monitor. And on that service, you can have alerts via email, text messages, or even webhook notifications. So the next one is Azure Advisor, also a free service, also very important to know. And that will provide you with the personalized recommendations, but also best practices of your various subscriptions and your various resources in Azure. And those recommendations can also be customized so that you not only have recommendations from all the subscriptions, but a specific set of subscriptions, specific set of resource groups. For example, production and a test environment, you can only set recommendations on the production environment. But you can have recommendations for different types also, like VMs, application gateways, app services, SQL services. Those are all recommendations you can have. But not only for services, but like I said, also for cost, security, reliability, performance is one, but also operational excellence. So the overall view you can have, and how it works. So you can go back one slide. So it works by analyzing the underlying data, and it gets that from Azure Monitor. And now you can also use Advisor alerts to get you notified when Advisor triggers alerts. And last thing, something new is the Azure Advisor score. So it's a score that's calculated between 0 and 100% from each of the category. So 100% means it's all okay, and all resources are tracked by Advisor, and those follow the best practices. A score of 0 means that none of the resources follow the recommendations and the best practices. So indeed, go to the next slide, please. Advisor is your personalized cloud consultant, if you will. And it's free, so it's very important to know about. So if you go here, then you see it's a good practice to create service health and also Advisor alerts. So we know that many Azure admins don't know these services, so they will help you get informed about all the service health events, but also the Advisor recommendations that you want to be informed about. And this, you can even know about issues without opening the portal. So it's a big win. So later on, I will show you service health, but now we want to talk about Security Center. So that's your first thing to do when you need the security overview of your complete Azure environment. It will also give you recommendations on how specific resources can improve security and improve those configurations. And a lot has changed lately. So as you all know, maybe Security Center is offered in free and a standard edition. On the next slide, we can see that Security Center is still offered in 2 modes, but with another name. So you have Security Center free tier, or the Azure Defender off, and you have the Azure Defender on. And the on is, it's the paid edition. So Security Center without Azure Defender, it's enabled for free. It's enabled on all your subscriptions. When you just visit the Security Center dashboard for the first time, you can just enable it. And in the free, it includes the continuous assessment and also the security recommendations. And you get also the secure score for free. It's also very important. And when you enable Azure Defender, so the paid version, you extend those capabilities, and it will detect and also protect the workloads against threats. And it also provides built-in protection, for example, for your hybrid workloads. A new addition is the workflow automation, which allows you to automate. So you can automatically react and trigger workflows based on certain conditions. For example, like if you have an incident response or when security recommendations are generated. So let's go back to service health, and just I'm going to share my screen and show you how it works in the portal. If you can see my screen, then you should see, service health. So we have the service issues, those are global, and we can also see the advisories. Like I see at the moment now, there is one advisory for Azure Active Directory that has been certificate changes. We can also look at the health history if you want to see, which incidents have been triggered, what has Microsoft done about it. You can read about all the different updates on it. So this is Microsoft support that is delivering the explanation about. But what if you want to look at your own resources? Then you can use the resource health. For example, if I go to a subscription where I have 2 VMs, and I'm going to select the resource type, which is the VM, then we can see that I have 2 issues on my VMs. So for example, if I open one, it states me that the VM is unavailable. That's correct, because I have stopped them or in Azure deallocated it. But it's a user authorization. So for that, I have to do nothing because I am aware that I have stopped the VM. Okay, back to you, Wim.
So for our 6th habit, we're going to look into secure hybrid connecting to remain secured when connecting to your Azure environment. So like probably most of you know, the easiest way, but the least secure one to connect to an Azure VM is by using a public IP address. It's PIP. In this way, you connect to an IaaS VM through RDP on port 338 or SSH on port 22. depending if the VM is a Windows or a Linux VM. This kind of way of connecting to your Azure VMs is good for studying purposes or when you need to do a quick test. But yeah, you should never use it to connect to your VMs in a production environment, because by using this way to connect to your VMs, one or more both management ports will be widely opened on the internet. And in this way, your VM can easily be attacked with brute force attacks, port scans, and even zero-D exploits. So in a production environment, you need to connect to your Azure resources through a hybrid connection with high security, like a point-to-site VPN, a site-to-site VPN, or an express route. A resource we still see a lot being used in a production environment is a jump box or jump post or even jump server, like some people like to name it. A jump box is a server. You can see it as a controlled entry point in your Azure environment, which is used to access the other devices in a separated security zone or in one of the spoke VNets if you're working with a hub-spoke model. When you use a jump box, it's best to enable just-in-time VM access or JIT for it, so you can control access and reduce the attack surface to this jump box. JIT is available when you use the Azure Defender On tier, like Carl mentioned before, of Azure Security Center. Well, how does it work? First of all, a user needs to request access to a VM. Then Security Center checks if it has that specific user RBAC roles for that VM. If so, the request is approved, and then Security Center automatically configures the NHG to allow inbound traffic to, for example, one or both of the management ports. And this for a requested amount of time. When that set time window is passed, Azure Security Center will automatically restore the NHG back to its previous state. These days, you can also use Azure Bastion to securely connect to your Azure VMs. Azure Bastion is a PaaS service that you provision inside your virtual network, and it provides you secure and seamless RDP SSH connectivity to your virtual machines, and this directly from the Azure portal over SSL. How does it work? Bastion lives in its own subnet, the Azure Bastion subnet in your VNet, which exposes only port 443 SSL from the internet. Through your Bastion host, you connect with RDP 3389 or SSH 22 on the private IP address of the VM. And in this way, your VM itself doesn't need a PIP anymore. But let me quickly demo it. So I have some VMs running in my environment. Some are stopped, some are running. I also deployed a specific Bastion host, a production Bastion host. These days, you only need to deploy one Bastion host for all your peered VNets. Some months ago, you still had to deploy a Bastion host in every VNet where you want to manage your VMs. So let me go to my VM, for example, this one. You just go to the connect button, and you can see you have RDP and SSH. It's a Windows VM, so I could do RDP. I had a public IP, but now I also have the option to select Bastion. You just type in your super secret username and password. I hope I will type it correctly. And now you just click on connect, and normally an extra tab will open, and you will be connected. You need to allow it, and you can see you have an RDP connection open to your VM directly from the browser. You can work with it, and as a Bastion admin, for example, you can go to it. You can go to the sessions. You can see if it's popping up. There is now a session active, and as an admin, you can just delete it, and this one will be locked up, so it's gone again. Let me go back to the slides. Okay, where are we? Over here. It's okay. So our final habit, the seventh one. As our last habit, we're looking into how you can secure cloud identities and foresee a good cloud identity and management strategy. Why securing your Azure identity is that important these days? Well, because these days there are all kind of Azure threats where attackers may use existing techniques like social engineering, where an attacker, for example, tries to manipulate someone to give up confidential information, or you have these days ransomware, a kind of malware which encrypts a company's files or data, after which then an attacker demands a ransom to the company to restore access to the data. But there are also some new techniques attackers or hackers use, like acquiring Azure tenant keys from GitHub, or where an attacker tries to get into an Azure VM by use of brute force or RDP SSH password spray attacks, like I already mentioned in the previous topic. And for example, when you're running a web server in Azure IaaS and that specific server is breached, attackers can use it to install crypto mining malware and use that for cryptocurrency mining. So that's a thing you really don't want to have. On this slide, you can see some examples of identity breaches. For example, you can see the top 20 most popular passwords used by employees, which you can simply look up by opening a browser and look to them with Bing or Google. A nice website listed on this slide is haveibeenpwned.com, where you can check if you have an account that has been compromised in a data breach. You simply go to the website and you just type in an email address you want to validate, and then the site in the back checks if that specific account is breached. So as an Azure administrator these days, you should really try to follow a zero trust model, because in most companies these days, you not only have to support access to data and services from inside the corporate firewall, but also from outside it. And by applying a zero trust model, you never assume trust, but instead you're gonna continually validate trust. You will rely on verifiable user and device trust claims and will grant access to only resources based on those. In this way, a trust is no longer assumed just based on the location inside of your organization's perimeter, but also from the outside. And this because most of your users these days, even in this COVID period, will access apps and data from the internet, like, for example, your Azure workloads. There are some resources and tools that can help you protecting your identities. First of all, you have, probably everyone knows this one, role-based access control, which can help you to control who can access, edit and modify or delete Azure resources, and you should work with it with the least privileged access model. You can also use Azure AD Privileged Identity Management, or PIM, which is a service that enables on-demand, just-in-time administrative access to any of your Microsoft Online services. PIM is available when you have an Azure AD Premium P2 license, an EMS E5 license, Microsoft 365 Education E5 license. Another tool you can also use is Azure AD Conditional Access. Conditional access is an Azure Active Directory tool that you can use to manage and control access to all your corporate resources. If they're running on-prem or in Azure, it really doesn't matter. To use conditional access, you need to have, I think, an Azure AD Premium P1 license or a Microsoft 365, I think it was Business Premium license. And last but not least, hopefully everyone is using that one. You can enable MFA, which you can now enable for free. You can see manage identity security for your Azure environment can be a big task. Luckily, you can now simply enable Azure AD security defaults, which makes it easier to help protect from identity-related attacks with pre-configured security settings, which are recommended by Microsoft. Like there are, for example, like you can see on the slide, requiring all users to register for MFA or blocking legacy authentication protocols. The only thing you should be aware of, if you're already using conditional access and have any conditional access policy enabled in your environment, security defaults won't be available to you. So before closing off, we just want to give you some key takeaways. 4 things you should really remember about our session of today. So first of all, try to think beyond the IaaS. Because now it's really time to modernize your workload. So when moving to Azure, try to think beyond IaaS. You should always keep an eye on your cloud spend, because at the end of the month, someone has to pay the Azure bill. Use all free built-in Azure services and tools like Carl mentioned, Azure Advisor, Azure Service Health, Azure Cost Management, and the Azure Security Center, the free tier then. And this to better manage and protect your Azure environments. And last but not least, know that identity these days is the new security perimeter, and that you should really try to secure all your cloud identities. So, and that's it for our session. So, yeah, if someone has a question, just shout, I would say.
Wait until I unmute. It was a good session. Thank you so much. Great tips there. We do have some questions and some curiosities and some observations and some comments. They're all positive. They're all good. And thank you so much for your session one more time. We do have a question on YouTube, which is whether just-in-time works with Azure Firewall as well, or is it just simply network security groups?
No, it works with Azure Firewall as well. So you can enable it, and Security Center will then check, okay, has the user the required access via RBAC, and then he is going to change the NSGs and change the firewall settings, and then you can use JIT to work with Azure Firewall for sure. Yeah.
A thing you should keep in mind is if you're using Azure Firewall and you also want to use Azure Bastion, the Azure Bastion host lives in its own Azure Bastion subnet, but you should not have a direct route from your Azure Firewall to that specific subnet, otherwise Bastion host will not work. That's a thing you should keep in mind.
When you do these changes, is there any way in which you test them before they get applied? And this actually goes particularly to the security configurations that you do, like conditional access or the security defaults?
We mostly test it on specific environments, because it can really have a great impact on how people work, or people still able to work and do their stuff. So you should really test it out on specific batch of peoples in your environment. So don't push it out to the whole company at once. Try it, see if it's enough to use, and just test it. Most companies these days have a specific test environment, and maybe some test users they can. Yeah, mostly people test everything out on the IT people in the company, and just see if they can work with it, and then you can go ahead and release it to the rest of the people working in your company.
That's a fantastic insight. And when you say environment, are you referring to like a specialized Azure Active Directory tenant, or are you referring to something else?
It depends. It's some people have test subscriptions where they can test things out, or some even have tenants for specific testing purposes. It all depends if it's how bigger the company, how more test environments they mostly have, and they mostly have also a pre-production and stuff like that. So they have different phases. But if you're a smaller company, it's sometimes quite difficult. Most of the time they test it on 5 people, or they just apply something and they see if it works or not. Not everyone is thinking has the money to buy 7 Azure subscriptions and to play resources in any of those. So it really depends of how big the company is.
So specific for conditional access, there has been some additional features where you can test conditional access and first, so like a what if situation, so you can see, okay, what will the conditional access policy do with my environment? So that's a very nice addition that they have done.
So what if effectively before you actually apply it, double check it, make sure that you dog food yourself, right? And you don't shoot yourself in the foot, right?
Yeah, correct.
Brilliant. Out of the 7 tips, or maybe even beyond the 7 tips, what was the real lifesaver tip or tool that you guys have used?
Like Carl said, for example, the mobile app. already saved me sometimes. When you're on the road and a company, you deployed something and something went wrong and everything was down, and yeah, it could stop or even stop things. Yeah, and also in my idea, you use a tool you're most familiar with and easy to work with, and it really depends for everyone, I think. But yeah, the mobile app was a saver for me one time.
Yeah, maybe it's not the tool, but you have to have a cloud strategy. That's very important, because moving to the cloud just because you want to, or just because it's a hype, it's not a good solution. You have to have a strategy. You have to know what you are doing. You have to look at your application, at your application landscape. So why you want to move to the cloud? Is it because you want to get rid of all the hardware, or if you just want to have all the possibilities and the advantages, so like the automatic scaling in the cloud, then it's a good point to go to the cloud. But you have to have a strategy. That's, for me, it's the most important one.
And in fact, there's a cloud adoption framework that you guys have mentioned at the beginning. I was looking that up, and that is actually beyond the fact that it's almost, if you download it as a PDF, an almost over 1,000 pages book, right? It definitely feels overwhelming. There's a fantastic set of references and resources that one should go about. Do you have any references to your companies, or maybe Microsoft has any references that you want to talk about in terms of security, in terms of maintenance, reliability?
Yeah. So the cloud adoption framework, you can print to PDF in the Azure, so in the docs, and it's more than 7,000 pages, I think. So it's definitely very, very big. But there are very good tips, and Microsoft is providing well-architected frameworks. They provide you with, if you are a small company, then you can start small, but keep in mind, like, have different subscriptions, have management groups, so you can apply Airbag to a higher level, so you have the inheritance to all your resources. And if you want to have multiple environments, you can just copy that one landing zone, like they call it, and you have different environments for different applications, or, for example, for a service provider that is delivering an application in your Azure tenant. So the cloud adoption framework is definitely the first step you have to look at, but it's very big, and you have to digest it first to get grip of, okay, what can we do with it now?
And you can really combine it with the Azure Architect Center. If you're really designing and you want to see some examples of how things work with each other, or how you can implement things, you should really take a look at those also, because they're almost step by step, and you even have example ARM templates if you want to use them, and then you can start using them and building from a starting point. You can build up your own environment.
A lot of things here to talk about and to learn. Where can people get started if they're completely new to this thing and they don't want to get started in the wrong way with Azure?
I say Microsoft Learn these days. I think you just go to it, you log into it, and you can start with the simple things, and it's well explained. And try it out. Start with a test Azure subscription. You have the free ones these days. You can use it for 30 days, but you can already work with all the free services, like I already mentioned. So you can try out those. Just go to it. And I think there's so many conferences these days, and a lot of people are making YouTube blogs, and a lot of user groups do all kind of stuff. And there's a lot to learn, but there are a lot of places these days where you can find help. And if you have a question, just shout, and probably there are a lot of people that want to help you with your issue.
Are you two guys on YouTube as well, or can people reach out to you in any other way?
My user group, Twitter mostly. And my user group has a YouTube channel. If we do an event ourselves, we also post it on our YouTube channel. So there are a lot of things over there. So
maybe we should start a YouTube channel, Wim.
Yeah, maybe. Yeah.
That's a pro tip for you, right?
But I need a green bag then, that I can do some cooler stuff in the back.
Yeah.
So now, a thing we also want to mention is what we see a lot, because we work as consultants. We see a lot of companies starting with Azure, and the thing is, we see a lot of companies just starting clicking around, deploying stuff, don't drop those when they're not used anymore, and at the end of the month they get a bill and it's, oh, Azure is that expensive, but most of the time it's not that well managed. So it's the cloud spend and keep an eye on our cloud cost is also a big important thing you should keep in mind, and you should really take a look at it, not every month, but yeah, try to make a controlled way around it so we can keep everything in control with Azure policy and stuff like that. So
Very much so. That is actually a type of an attack at the end of the day, isn't it? Denial of wallet, where people abuse your services because they know that you're maybe on Azure or another cloud platform, and you're going to pay for their abusion. So you want to pay out for that. And that was one of the key takeaways in your slide deck. I really appreciate that. Good stuff.
So also to you, like, thank you so much for being here today. I really enjoyed your session. So I saw some very cool things here. So thank you for that. So I would say enjoy the rest of your day. Thank you for being here, and till next time.
Thank you. You're welcome. Bye.
So for everyone that enjoyed the session, this session, so we had a cancellation of a speaker yesterday, but we found Mike Martin willing to step in. And so if you want to know more about these kind of tools and similar tools, Mike Martin has a session on the tools yet with Microsoft Azure Tools. So it's at 2:45 Amsterdam time. So if you enjoyed this, also have a look at that session. And I'm especially calling this out because, like I said, it only happened last night. So I want to make sure you actually know about the session and you can go there. Before we go to the next session, I quickly want to shout out again, like, join us on Discord if you are not there yet. There's a lot of discussion going on. There's a lot of questions going on. A lot of people are there. You can thank the sponsors there. So yeah, if you're not there yet, just go to bit.ly Azure Lowlands Discord and you should arrive there. So join in the discussion there. And now we are going to add Freek and Esther. We are going to talk about ARM and Bicep.
Yep.
So welcome.
Hey there, how's it going?
Good.
Doing good, yeah.
So I do have a question, Ansible or Terraform?
What's that?
Terraform.
What about you, Freek? Do you agree with that?
Let's try to answer that question after the session.
Because we have a new kid in town.
We have a new kid in town, Bicep.
Yeah.
What a cool name.
It is, yeah. It's well, there's a reason why it's in quotes still. So you probably imagine that it's a project name for now, but it's a definitely cool name, and it sort of also describes what it actually does. Literally empowering your ARM templates is what we're going to see in our session, hopefully today. So yeah.
The heavy lifting, I think, of Azure. I remember back in the days when we did IT, we have the heavy lifters, the IT pros who were doing the bare metal stuff. And at some point, this studio used to be a technical room, and they would see tech people, IT pros carrying servers and whatnot. Well, it no longer is the case because we're in the cloud now. But now we have muscles and biceps, and we pull ARM and Azure in different ways. And I'm really looking forward to learning about that.
Yeah. Yeah, so are we. So
yeah, we are excited about ARM, but also very excited about Project Bicep.
Yeah, so I have a love-hate relationship with ARM myself. Like, I really, once you get through the initial stages, then it's actually quite a nice language, and I've gone through it like quite early on, so I've been working with it for most of the time that's been available now. But I have some colleagues that are like, well, it's just a lot of JSON and it's hard to read. So I have been looking at Bicep as well, and it does really look like a nice language to actually solve this problem, especially for people that are more beginning on the Azure ARM language, because ARM does have a bit of a learning curve, basically.
Yeah.
Correct. And I don't want to get all the spoilers out yet, but I will share some of my learning experiences with ARM. Yes. So just hang in there, folks. 5 more minutes, and then we get you up to speed with ARM and the do's and the don'ts, so to speak.
Yeah. So how long have you been working with Azure now, you two?
Wow, it's been a lot of years. I think since the early days of the early Azure portal. If some of you still remember that, the classic portal, trying to provision VMs was, I think, one of the first things I did. But in terms of ARM, I've been working with that for about 3 years now, developing ARM code. Just enjoy doing it for for different deployments and different types of deployments doing infrastructure as code. And I know Esther is doing a lot of it as well, especially the last couple of years, I think.
Yeah, I still consider myself a newbie, but that's mainly because with end user computing, you still have a lot of customers that are used to having their solutions provided from an on-premises environment. So for me, Azure has mostly been my own little playground. And this last year, it just skyrocketed. And I've seen a lot of migration speeding up to cloud and to Azure particularly.
Okay.
Have you already used Bicep for anything in your own projects, maybe as a hobby or even professionally? Granted, it is still in preview, right? It's project Bicep.
Yes.
Yeah,
correct.
Yeah, I'll cover that why that is. So the Bicep language itself is into preview, but as we'll see, and without spoiling it, what we're going to show you, but in the end, it's still going to be about ARM templates. So it's going to be an abstraction layer on top of it, which is the reason why the project Bicep itself is in preview, but anything that you create with it is in production because it's going to be ARM in the end. So right now we're at Auto 3 version and close to first production use for Bicep. There's going to be some small changes that we'll cover in this deck as well towards that first project or production release. But I've been using it to generate ARM code for production deployments already. So yeah.
Awesome.
I know suspense is building up. I'm ready to learn. Edward, what about you?
Yes, I'm ready. So I will hand you the stage, and I'm really looking forward to this session.
Thank you.
Right. Thank you. So you should be able to see our deck. And again, thank you for joining us. And to the organizers, thank you for having us today. We've been able to see some of the previous sessions. There's a lot of great content going on. So happy to contribute to that today. And so we'll talk about ARM templates, JSON templates, and like you said, Project Biceps in the next 45 minutes. Quick introduction to myself. My name is Freek Bersel. I'm from the Netherlands. I primarily work with application and desktop delivery technologies, so not so much ARM and Bicep. So think about RDS, VDI, remote app, Windows Virtual Desktop. But I also enjoy doing stuff with automation, infrastructure as code, and ARM templates, and doing that a lot in Azure. I've been a Microsoft MVP, and well, excited to be here to share some knowledge with you today. So with me is Esther. You want to introduce yourself as well?
Yeah, sure. My name's Esther Bartel. I've had over 20 years of consultancy experience, mostly end-user computing, and basically more Citrix solutions than Microsoft solutions. For the last couple of years, I've been diving with great fun into automated deployments, both on-premises and in Azure. So yeah, I've already had a lot of fun with ARM templates, JSON, even REST API calls. I'm also one of the founding members of the CUGC Women in Tech mentorship program. So just making sure that we get the women more visual in the community and helping them in their career choices. And so feel free to reach out to me for that. But I guess right now we're just going to geek out a little and get started with Azure automation and all the ARM fun.
Yeah, absolutely. So let me share the agenda we have for you today. First of all, thank you to our sponsors who are making this event possible today. A lot of them have dedicated sections in the Discord area. If you're interested to talk to them, feel free to do so. And thank you for him for sponsoring this event. So the agenda of the next 40 minutes, I think, right now is going to be a short introduction into automation. Azure is going to cover that. And then we're going to transition into Azure Resource Manager and JSON templates. So we'll take a look at some of that ARM code, JSON code, what it can do, what it cannot do, where some of the challenges are with that. And then we'll transition into Project Bicep. So we'll do a really brief introduction into what it is. And for the most part, that section will be live demos. So hopefully the demo gods are with us today. So we're going to show you some cool stuff that you can do with Project Bicep to really empower your ARM code, your JSON code, and automation to Azure in general. So with that, Esther, I'll hand it over to you to start the introduction.
Yeah, perfect. Thanks a lot. So to make sure that we're all on the same page, we figured we best start with the Azure Resource Manager and making sure that everyone is aware of it being the great force behind Azure and behind Azure automation. So if we're looking at this familiar slide for a lot of automation enthusiasts probably, you'll notice that the Azure Resource Manager is in the center or the heart of all communications that we have either through the Azure portal, the CLI or PowerShell commandlets, the SDKs or the REST API calls. They all communicate directly with the Azure Resource Manager, and which uses different resource providers like the compute resource providers, networking, storage to actually control and configure our Azure infrastructure, the edge infrastructure, and even on-premises infrastructures. So that's just to give you a quick overview of what we are focusing on today. Not that I want to steal away all the fame and glory of Project Bicep, but we wanted to make sure that you are aware of where it all started. So to get an understanding of Azure automation, once again, we're talking about ARM. And the cool part about using automation with Azure Resource Manager is that you can provide specific templates based on JSON formatting to specify the configurations of your resources within Azure. So this is just to give you a quick getting started with ARM templates. So it has a very clear formatting. Once again, it uses JSON, but it has also these different cool sections. First of all, you have your parameters, which focuses on the input values for your template. And these can be variable, so you can definitely reuse your templates for multiple deployments. The variables are used within your template to make it easier to address resources by using short lines for that. Functions, again, used in template to help you build your own custom functions that you can quickly use within. Resources, that's the main part. That's the cool part, because that controls your Azure resources. And it will specify with the specific configurations how the Azure Resource Manager is going to create those within Azure. And to make sure that you can get some output back from the Azure Resource Manager, you can specify what information it needs to return after it has configured your environment. So if we're zooming in on those different sections and some formatting for that, well, first of all, let me say, if you do not understand all these different templates and are feeling a bit overwhelmed, don't be scared. I kind of felt the same way when I started to use ARM templates. And it felt like, well, some of us already mentioned that before, that it has kind of a steep learning curve. Because if you look at this, it's not fully intuitive. So it does take a little learning and discovering on how to use that. So that also means that you can end up with some trial and errors creating your own custom templates. To make life a bit easier, there's this awesome quick start documentation on Microsoft Documentations that basically helps you to build your first custom templates. So what you do is you go into the Azure portal and you go through the entire process of creating your resources through the marketplace or with all the different tabs and information that you normally provide in the manual process. But instead of hitting that create button after your information is validated and you pass the validation, there is also a small link at the bottom saying download a template for automation. And this link brings you to a download page, which offers you the opportunity to download. Let me just quickly turn off the laser pointer because it is a bit annoying. It will quickly help you to download your template file. And not just a template file, but also a parameters file that easily holds all the information that you previously provided in all the select boxes and text boxes and tabs. So this allows you to already have that first pre-filled template to get started with automating your ARM deployments. One of the other cool things is that there is a very extensive reference guide provided by Microsoft that allows you to zoom in on all the different resources and resource definitions. It even gives you sample code that you can quickly copy and paste into your ARM template. And it, of course, also specifies all the properties that you can define and what values that you can provide for them. So this should definitely help you get started with customizing some of those settings in your ARM templates. Like I did in this example, making sure that I added the DNS server information for my WVD deployment. As mentioned during the introduction, there's also a great learning path on Microsoft Learn that takes you through all the different steps of learning to build your own ARM templates and using those ARM templates, even including some advanced options. And last but not least, there's also a huge library with almost 1,000 pre-built templates for you to use and reuse. And you can easily deploy them in Azure by clicking on the button. And the other cool part is that it not only specifies the parameters that you need to provide, but it also shares how you can use your ARM template in an automated deployment with, for instance, PowerShell. And that, of course, was one of my first starting points within Azure, because I just love PowerShell as my scripting language. So it's very easy. You just use a reference to your ARM template. You can also use a reference to your parameter file and then use the new AZ resource group deployment commandlet to specify the resource group where you want your ARM deployment to get started. And then, of course, specifying a template file, parameter file, and some secure string passwords. And then you're good to, well, almost. In my case, preparing a cool demo video didn't turn out so well. So my first response basically was to reach out to Freek, because he's basically my WVD ninja, to help me with some troubleshooting. Because if you look at the originator of this error, it states that it's probably using some linked template that is throwing some error. And don't get me wrong, troubleshooting ARM is still very traditional, or no, I was going to say, I'm lost for the word, intuitive. Thank you, Ver. So what happens is it does give you clear error messages on what is going wrong. But still, that means that if you really want to go into troubleshooting your ARM template, there are some challenges that you have to overcome. First of all, there's a lot of lines of code to scroll through. And even with the not too intuitive and a bit more complex JSON formatting, and the external dependencies on linked templates that could be changed without you even realizing it until you get that error, it means, for at least for me, it felt like I didn't get the best time for value, so to speak. So once again, I reached out to Freek if there is maybe a better solution for all these, well, not too optimal experiences that I was having troubleshooting. And I could explain you all on how Freek told me all about Project Bicep, But I guess this is the moment where I hand you back to Freek and let him share the story himself.
Yeah, thank you for that introduction. That was fun to watch. I was trying to count the number of brackets and quotes you have in these templates, which is insane. That's something that we're going to make much more readable with Project Bicep. So let's transition to that. And so if you are not or less familiar with Project Bicep, it is what is it? And let's cover that first. So let me share my screen again. It should be visible now. So what is Project Bicep really? Project Bicep is a domain-specific language, or a DSL, which means that it allows you to deploy resources, in this case in the Azure portal. That's the specific language that it is for, in order to do that in a declarative way. So in that sense, it's exactly what ARM does, right? What Esther just explained. You don't go into the Azure portal, but you use a template to describe and define what you want to create declaratively. So how is it different from ARM? It's just to emphasize that it's not going to replace ARM in any way. Azure Resource Manager and JSON templates and ARM templates will still exist. What Project Bicep does is it allows you to drastically simplify the authoring experience and the coding and the programming experience. It provides for a much cleaner syntax, as we'll see in a couple of demo examples in just a second. And it also allows you to do much better ways to deal with modules and to deal with reusing your code. So basically, Project Bicep is literally a transparent layer on top of ARM, allowing you to have a better authoring experience, not in any way replacing ARM. So how does that work? Taking a look at the diagram in the right-hand side, we have, again, the big blue bar, the Azure Resource Manager engine. And of course, if you're familiar with this is our main entry into creating resources based on resource providers, like virtual machines and storage accounts and all of that, but also things like Arc and Kubernetes and GitHub and all of those components. That remains exactly the same. So on top of that, we have our ARM templates, the ones that Esther just showed you, the JSON templates that define what I want to create in which order and allow the Azure Resource Manager engine to do that. Again, that remains exactly the same. So Project Bicep is going to be the layer on top of it, allowing you to not have to deal with ARM templates, but deal with Bicep templates or Bicep code instead. So what you do is you create a Bicep file, and take a look at some of the examples, which, by the way, literally has the extension .bicep for now, and you transpile that into an ARM template. And from that moment on, you just have just another ARM template, just another JSON template that you can feed into the Azure Resource Manager engine. So you can still use the ways you are doing that right now, whether that is PowerShell, like Esther does most of the time, or whether it's GitHub, or just uploading the template to the Azure portal, or using the marketplace, or whatever. That remains exactly the same. So what we're doing with Bicep, we're creating a layer on top of it to make the authoring experience much better. So much better to read, much better to author, but still you can leverage all of that knowledge about ARM templates, because in the end, we are still using and leveraging ARM templates. It has a lot of options to do different modules. So it has options to have separate modules for separate pieces of code and reuse that as part of your Bicep project. And the entire thing is fully open source. So all of it is available on GitHub. If you visit aka.ms/Bicep, you'll be directed to the GitHub location where all of the source code, all of the community effort is also shared, because a lot of the community members, including myself, are contributing to this aka.ms GitHub page in terms of Bicep examples. There's a big playground in there. You can actually interactively play with it as well. So be sure to check that out. We'll also share the link at the end of this session. So how do you get started then? If you are familiar with ARM templates and if you've been doing JSON templates, how do you transition to start leveraging Project Bicep? There's 2 easy steps to get going. The first step is installing the CLI, which is needed to be able to do that transpiling from a .bicep file into a .json file. So there's a couple of commands here to just have that installed for you. I did not come up with these commands. These are just available on the GitHub page, and we'll go share that location in a second as well. And then the second step is installing the VS Code extension. If you're using VS Code, I can really encourage you to do that, especially for this bicep stuff, because it brings you a lot of IntelliSense, autocomplete, and tab completion and stuff like that to help you get an even better experience in there. So although it's optional, we can really recommend you to start installing it in your VS Code environment.
Yeah, and it was very easy to follow the steps. So I was up and running in a couple of seconds.
Yeah, it's just literally just running these commandlets and you're done. And there's also a great tutorial on a GitHub page by Microsoft guiding you through the steps, just step by step. So yeah, it's just these 2 steps and you're good to go. So without further ado, let's just kick off a live demo to see some of this stuff in action and provide you with a couple of examples and ideas on how you can empower your JSON code with Project Bicep. So switching to my VS Code, I have already went ahead and installed with the same steps the Bicep extension. If I run a Bicep version, you can see that this is the current version of the CLI, which is installed in my local machine. Optionally, you can also go to the extensions, just search for Bicep and get it from the marketplace right there as well. So let's get started. And so let's first create a new .bicep file, which is called main.bicep, which is an empty file, but it's actually a valid bicep file, although it doesn't contain anything. So let's go ahead and transpile this into a JSON file. So we do is call or enter bicep build, and then the name of the file, in this case, the bicep file. This allows us to transpile it into a JSON file. So now a JSON file has been created. Obviously, it took a second because there's nothing in there. But as you can see, we already have the empty skeleton of a JSON file right here. So I could feed this JSON file into the Azure portal. It obviously doesn't do anything, but it's a valid JSON file that was transpiled by the Bicep engine.
It shouldn't throw any errors either. So that's the good news.
Yeah, exactly. So let's go ahead and enter our first and create our first resource here by declaring what we want to create in the Azure portal. So what we do is we type resource and we give it a name. Let's in this case just create a storage account. We type a storage account and we search for the right one we want to create. So in this case, that's going to be this one. And we'll do an equals and a couple of brackets. So the first thing you'll notice is that there's a single string needed for the declaration of the object type that I'm creating, as well as the API version, whereas in ARM code, this was already 2 separate properties you need to define. So if I do the tab completion thing, I can take a look at what I need to specify for creating this resource account. So at least just give it a name. Let's call it Lowlands for now. And I know that I need to also specify the kind of storage account, which is in this case blob storage. And let me also define the location where we're going to deploy this. And just because it's easier to type, let's do East US. And the final property is the SKU. And we know that this is a it's an array of multiple properties. So at least we need to give it a name. And in this case, let's do a premium LRS. And that's it. So within a matter of seconds, with all the IntelliSense going on, I have created a first object, a storage account, ready to be able to deploy in the Azure portal. So let's do a bicep build again, and let's take a look at the end result. Let's do a side comparison. You can see that the left-hand side has the bicep code, 8 lines of code versus already 17 in terms of the actual JSON code. So a lot of the authoring experience, like the tab completion and the IntelliSense, that's also available for ARM. But what ARM does not have, to give you an example, is that Bicep also allows me to refer to properties of an object that I have been referencing here or creating here before. So for example, if I would create an output here, module, an output, and let's call it STG out, and it's going to be a string. Equals, and I can now reference the STG, so the name of the storage account declaration here, and take a look at what I want to add here. So let's go into the properties, let's go into the primary endpoints, and let's get the blob there. So just by typing the name of the resource that I'm going to create here, I can get all of the properties in there as well and reference them from this new object. So again, let's save this and let's build it. And on the left-hand side, you see what has been added here in terms of the output. So notice the difference in the way we are very easily able to declare this the blob that we want to have here versus I need to have a reference version, I need to have a resource ID function, and all of the voodoo magic that comes behind that. Right?
I'm so happy we're not doing the battle, and I have to type all that ARM in there.
Yeah, you probably lost by now. So it's
definitely.
It provides you a lot of complexity, and also if you just take a brief look at the differences in declaring things, this is much easier to read than all of the brackets and the columns and the semicolons that are going on the right hand side.
Yeah, you already have me all excited.
That's great. So let's take a look at another example. So I have prepared a VNet here, which is a vnet.bicep, which contains the declaration of a VNet with a couple of subnets. Just to give you a bigger example, in this case, I'll also have a couple of parameters that I'm declaring with a couple of default values, but also take a look at the easy way of how to concatenate static values with other parameters as well, comparing that to JSON. So let's go ahead and build this example number 3. And let's do a side-to-side comparison again. So again, you'll see, the way to be able to do that concatenation in JSON versus the very easy way to do that in Bicep. And again, we went from 38 lines of code towards 61 already. And also, what you notice is when you're declaring parameters, this is just a single line. So it includes param, the name, the type, as well as the default value, and just compare that to what you have to do in order to get that same thing in JSON. So let's take a look at a more advanced scenario where we're creating multiple objects at the same time, or declaring multiple objects to be created. So this is a typical virtual machine example, a common object to be created in the Azure portal. And in this case, I'm declaring multiple objects. So I'm creating a VNet, I'm creating a network adapter, and I'm creating a virtual machine. So the reason I'm showing you this is that since we have multiple resources being created and declared at the same time, the Azure Resource Manager engine needs to know which object to create first, right? So the ARM engine doesn't know that by just taking a look at the object. So in JSON, what you had to do is specify a depends on section, making sure that the ARM engine knew that the virtual machine cannot be created before the network adapter exists, or the network adapter cannot be created before the VNet is there, so you can point to the exact subnet. So let's go ahead and build this example number 4 into a JSON and see some of the differences and focus on that depends on section for a bit. So we have, again, a lot of code going on the right-hand side. We already noticed that before, but let's take a look at that depends on section. So if we scroll to the NIC, so the network adapter, right here. So this defines the network adapter. And as you can see, I did not specify anything allowing the ARM engine to know that there's a depends on section needed for this object. So what ARM did, what the transpile action did, is because I'm referencing a property of another object here, so I'm referencing the ID of the VNet, and the VNet is the one that I specified right here, it actually knows to add a depends on section implicitly. So as you can see on the right-hand side, it did already add that depends on section for us. So it's referencing getting the resource ID, pointing to Microsoft Network Virtual Networks, and then the name of the VNet. So it did that only because I was referencing a property here, referencing to a property of another object that was previously declared. So similarly, we have the same thing for the virtual machine. So if I create the virtual machine, I need to specify the network ID in this case. So let's take a look at the virtual machine. And again, we have a depends on section being added here implicitly as well. If you do want to add those explicitly, you can still do so. So you can go into the bicep code and say depends on and add your own explicit depends on section, but you probably don't have to since we're most of the time referencing to properties of other objects as well. So just to give you an idea of what that does in terms of depends on sections. So again, let's step up our game and talk about the modularity and the module approach. So for that case, I have a much bigger bicep file containing a lot of objects and a lot of parameters, as you can see. So notice that I have also have parameters that have the secure option enabled. So these are secure properties that do not have a default value right now because I'm passing them using the parameter file. But also I have a lot of parameters here going on that specify a default value just for the sake of the demo to have it easier to deploy. So notice that I am doing a couple of things here. So I'm, besides a huge list of parameters, obviously, we're going into the creation of the declaration of the resources here. So in this case, I'm creating also the resource groups in where I'm going to deploy this. So in this case, I am not deploying a single bicep file transpiled into a single JSON file and then deploying that into a single resource group. I'm now contacting multiple resource groups and creating multiple objects across all of those resource groups. So the resource groups themselves are also being created by bicep. So I'm declaring the resource group right here with the name. So I have a resource group for my networking, for my template images, for my backplane, for Windows Virtual Desktop. So you probably guessed what this template is about to do. For my host servers, for my monitoring, for my file services, and also for my key vault. So all of these resource groups are going to be created in the Azure portal. So in order to do that, the first thing you'll have to do is change this, the target scope. So by default, you probably, in most scenarios, like the previous example, you have a single JSON file deploying a couple of objects into a single resource group. By changing this target scope into subscription, I can then deploy to different resource groups at the same time. So as you can see, if we scroll back to the resource group, we actually define where it's going to be created. So similarly to these objects, I also have the module that we're going to take a look at right now. So in this bicep file, I have a combination of resources that I'm going to create, but I'm also referencing other bicep files that contain other resources for me to deploy. So as you can see, I have the module keyword here. I provided a name and I specify which bicep file contains that module. So this is just another bicep file. So there's absolutely no difference between a bicep file containing a module or a bicep file just containing resources. Any bicep file can also be a module and can be referenced from another bicep file the way we're doing it right here. So then we need to specify the scope. So since we have multiple resource groups, I specify the object that I created before the resource group, for in this case, the backplane of my Windows Virtual Desktop environment, including the name. And then I specify the parameters that I'm going to pass towards this module. So these are parameters that I collected in this bicep file as the parameters, and we're passing them on to this module. So similarly, I have a module to create the backplane module for my acceptance environment for Windows Virtual Desktop. I have a separate bicep module that creates my networking components. I have a separate one that does my monitoring, my log analytics workspaces, my shared image gallery, if you're familiar with that, with all of the components, and so on and so on. So let's take a look at one of those module example files to take a look at what's in there. So let's again take, let's take network as the example. So I deliberately named those 6 and 6.1 and 6.2. That's not mandatory. That's just to give you an idea which file actually calls which file to sort of get the hierarchy in order. So as you can see, this is just another bicep file, just containing parameters with the types and a couple of variables where I'm doing similar concatenation stuff and creating resources. So in this case, we have the same example, creating a VNet with a couple of subnets as part of the resource that we're going to create in this bicep file. So this is just another bicep file, but in this case, we're calling it from the main.bicep. In the same thing, I'm also creating other objects. So I'm also creating a role definition to give my my identity the correct permissions to be able to read the virtual network in this case. I'm creating some role assignments, adding those, and I'm adding some peer-to-peer configurations in order to have this subnet or this VNet be peered to, in this case, my AD VNet to get AD communication going. So this is one example, and as you can see on the left-hand side, I have all of these bicep modules that do all of these separate things. So let's take a look at another example, for example, the shared image gallery. So this is a relatively new component, including the Azure Image Builder that is a part of this as well. So what I define here is that I create a role definition, an image gallery, and a role assignment, and an image definition. So this prepares me to create my Windows Virtual Desktop, in this case, template images to be able to deploy those to my Windows Virtual Desktop environment. So all of these are also going to be created. So let's try to take this main.bicep and transpile that into a JSON code and see what happens. I'm not able to type really well today. So let's go ahead and do that. So it's the 6 example, 6.main.bicep. And again, it's take a second to complete. And let's actually open that JSON file up. Now, as you can see on the right-hand side, this has just become a JSON file of over 2,000 lines, which is interesting because our bicep file was just a little bit over 300. So why is that? When I do the transpiling of a single bicep file that calls other bicep files because there are modules in there, it also transpiles all of those subfiles that are needed, right? So this single JSON file contains all of the objects, all of the parameters, and all of the resources that were created in all of my bicep modules, which is the reason why it has become so huge. So this is now ready to be able to deploy to the Azure portal. Let's actually go ahead and do that to see what is going to happen. So I have a couple of demos we just prepared, right? So we created the VM example here, which in this case allows me to run, again, use PowerShell to do a new AZ resource group deployment. I specify the resource group name and the JSON file, so not the bicep file, but the JSON file that was transpiled, and I specify the deployment name. So let's go ahead and do that. So again, this is our first example, which deploys those virtual machines. It allows me to provide a couple of parameters for this template. And once I do that, let's switch to the Azure portal. We have that resource group right here, which is currently empty. But if we take a look at the deployment section, it is now deploying our code. So it has already deployed the VNet and the network adapter, and right now it's deploying the virtual machine. So this was our first example where we created that virtual machine bicep file, which contains the VM, the network adapter, and the network adapter and the VNet. So here are those components and are ready in the Azure portal. So we're going back to the resource group. If we hit refresh here, here's that virtual machine that was created in just a couple of seconds. So let's now go ahead and do that huge main deployment of the main.json, which is probably the more interesting one. So again, because we are deploying now into multiple resource groups, we need not to use the AZ resource group deployment, but rather the AZ deployment, which allows us to specify the template file, the template, in this case, parameter file also, and the deployment name. So we do not have to specify a resource group because we are creating those resource groups as part of the deployment. So let's go ahead and do that. And let's see what actually is going to happen. So right now, the JSON file is being fed to the Azure Resource Manager engine, also including the parameter file, which allows me to override a couple of values that were not inside the template or that I wanted to overwrite. And I get a warning about a role assignment. Let's see what happens. It's a live demo, so let's take a look. If I do hit refresh, go ahead, Esther.
No, I was just going to say, at least I'm not the only one getting some errors.
Yeah.
Fingers crossed.
So let's see. of course, this was properly tested before. Well, at least we see some results. So let's just forget about that error there. We have something to debug, which is fun for this afternoon. But a lot of resource groups have been created by this deployment. So I have my backplane components, my WVD hosts, my file services, key vault, and all of that. If I go into one of these, I can see that these objects have been created. So if you're familiar with Windows Virtual Desktop, we have a host pool, an application group, and a workspace here, and all these objects are also tied together. If I go into the file services section, we have 2 storage accounts being created. There's one storage account here, which contains a couple of containers for my Azure Image Builder process, my scripts, and my software. And I have a separate one that stores my profiles, for in this case, my Windows Virtual Desktop environment. So these have all been created by Bicep. We have our networking resource group, which is created, which contains the VNet that we specified, including the 2 subnets for our production and for our acceptance environment. What do we have more? We have the template image resource group, which contains those objects that are needed for my Azure Image Builder process to be able to define an image and deploy virtual machines based on an image that I specified. So I have my shared image gallery, my image definition, and all of those components. And I have a virtual machine template that also deploys, which allows me to test my software before going into production with this WVD environment. So just to give you an idea of how powerful this actually was, and it probably finished by now or should be finished. So there's one little error about, let's scroll back. Something about a role assignment, which is probably changed in, well, just before doing this demo. But as you can see, this was a live demo, and it did actually create all of those resources for you just with a single Bicep file, which was transpiled into that 2,000 line of code. So hopefully that was a fun demo to watch. The last thing I want to show you is the decompile option. So let's take a look at example number 7. So now we are not starting with a Bicep file, we're starting with a JSON file. And we have already a first a version of the decompile option available, which allows us to, it's not my typing day today, to decompile this JSON file back to a Bicep file. So if you have existing, I should of course do decompile. If you have an existing JSON template that you just want to see what it looks like in Bicep, this is the way to do it. And right now there's a warning because the decompile is now at a best effort process. But here is that Bicep file that it just decompiled from the existing JSON file. So that helps you to have existing JSON files also be transpiled back to original Bicep files.
So basically what you're saying is I can still use the quick start guide to build, to quickly get my custom ARM template, and then do the decompile to make sure that I continue in Bicep just because it's more intuitive and it will prevent me from making some, what I like to call rookie mistakes in ARM, in the ARM template definitions.
Yeah, that's a great use case. And also, if you are, if you have been doing a lot of JSON and ARM templates in the past, and you have a lot of knowledge and just want to see and get a head start on what that Bicep code looks like, just take one of your JSON files, decompile it, and just reverse engineer of how that works. It's really helpful. Yeah, for sure.
So this gives me a way to quickly become the ARM template hero that I am striving to be. That's good. Awesome.
All right.
So of course, Bicep is still a project. So is there any light on what the roadmap is and how fast we can expect it to go GA?
Yeah, that's a great question. So let me switch back to the slide deck, which should now be visible.
Yes, we can see.
So this is the roadmap that is well, all of the evolutions of Bicep since August last year. So we started with an alpha 0.1 version, became 0.2, and we're now looking forward to 0.3 version. So right now we are at 3.28. But right now already there's 90% feature parity with traditional ARM templates, which is pretty impressive if you know that they started back in August. Of course, there are still some things missing, and the most interesting one, and the one that probably everyone is waiting for, is doing the loops functionality inside the bicep file. That's just a very common thing to be used in ARM templates to create multiple objects by just doing it in a loop. That's coming in O3 somewhere later this month or early March. And other things like the final version of the decompiler and production usage will be from that moment on. And also we have, just to share with you, a couple of things that are going to change. And I think that, Esther, you wanted to talk about those breaking changes.
Oh, no, I think you wanted me to talk about the breaking changes. No, I have to admit that for me, Bicep still is very much a backlog item, which is very high prioritized right now. But yeah, I'm just in awe with how fast they are incorporating the feedback that we from the MVP program provide them, which is our fortunate position to be in. And it's just awesome to see them already giving us feedback on all the, like you say, the breaking changes that they already planned and that they're working on and probably already have in beta testing themselves.
Yeah.
So as you mentioned, go ahead, Fred.
They're very transparent into these changes as well, because these are just these are available on GitHub for everyone to see. But just to give you two examples of stuff that's going to change from the 0.2 to 0.3, minor changes, but it will affect your existing Bicep files. So we started this session by saying, is it production, or is it ready for production use, or is it still into preview? Yes, the Bicep code itself is into preview, but all of the ARM code that you generate with it is just valid ARM code and ready for production use. So make sure that and these are two examples of things that are going to change while we transition to the 0.3 version. So with that, the last thing I want to share with you is a call to action. So if you're interested in getting started with Project Bicep, go and visit this URL, aka.ms/bicep. It contains a lot of documentation, a lot of guidelines and wizards and steps that take you through some of the tutorials that we just saw in this demo as well. Take you through all of the declaration and the syntax and how to get started. It also has a examples section where people from the community, including myself and others, are contributing with Bicep files to give you a head start on creating your Bicep deployments as well. And it has a live playground where you can actually play with Bicep code right from within your browser. So be sure to check that out. So taking a look at the clock, I think it's, pretty well timed, I would say. It's just past the hour. So yeah, I want to thank you for joining this session. I hope it was valuable to you. If you have additional questions, we'll be here, I think, for a couple of minutes, and after that into the Discord to answer any additional questions. And also feel free to reach out to either of us, Twitter, email. Both of our GitHub accounts are in here as well. With that, any last words, Esther?
All I see in Discord is a lot of cheers and a lot of excitement about the loops coming to Bicep. So it seems that we already are empowering the community to adapt to Bicep and become those ARM heroes that we all strive for. So enjoy getting into Bicep. And hope to see any of your feedback and cool demos in the near future.
Yep, great. So passing it back to the organizers.
You're on mute, Alex.
Oh my God, my second coffee hasn't kicked in.
No problems.
Which is another way of saying how impressed I was by your session. I was blown away, really. This was really good stuff. Now, there are some questions coming from your audience. And the first one is there any risk in investing in Bicep right now? Because there is a learning curve, obviously not as steep as in JSON, but with ARM. But do you see a risk in maybe having to learn ARM and Bicep at the same time, or should you only learn Bicep if you're a complete newcomer right now? Should you wait for it to be G8 and have a 1.0 version at some point?
Yeah, that's a great question. So I think that, well, I've been through the learning curve of learning ARM, and so has Esther. If you compare that to the learning curve of Bicep, it is a much, much better, a much less steeper learning curve to actually get started with that. So I would actually really encourage everyone to start taking a look at Bicep right now, not wait for the 0.1 version, auto production version to come out. Because, well, now is the time to get started and get yourself acquainted with the syntax and with the way you declare things. And probably if you have created your first Bicep file, you will be impressed by how easy it is compared to doing the same thing in JSON. And taking a look at further in the future, what probably is going to happen, we're just estimating and assuming this, but right now we are feeding a JSON file into the ARM engine. So we still have to do that transpile option from a Bicep file into a JSON file and then feeding it to the engine. But what if you would be able to just provide that Bicep file directly into the ARM engine? We could definitely see that happen and have Microsoft do that transpile option for us as well. And by then, you probably do not have to worry about all the JSON code because you will not see it, because you will just be passing Bicep files to the ARM engine.
Yeah, we're not expecting Bicep to fully replace ARM. So ARM will be there because it is the heart of Azure and automation for sure. But I think Bicep will definitely help you to more easily transition to an automated deployment and a DevOps strategy, which I do notice a lot of companies switching to right now.
Which is another way of saying that if you already know ARM, you should not feel overwhelmed by the fact that Bicep is the new kid in town, right? Because the entire mindset and technology is based on ARM anyway.
Yep.
Well, if you are an ARM hero, feel free to reach out to me and help me with some troubleshooting.
Doesn't matter, right? Would you prefer Twitter or email? We do have another question, actually, which is, does Bicep have a remote state functionality like Terraform has?
That's definitely an interesting question. We got a lot of questions also on other presentations and things that we share. Is how is it different from anything that's, for example, that Terraform is? So Bicep doesn't have a state like Terraform has. So in terms of Bicep, Azure is the state, which means that you also have day zero support when new resource types or new API versions are coming out. You can directly use them into the Bicep code because there's no state file that's needed. So you can directly talk to the Azure engine and get the current state from there. So that's the difference between Terraform. But other than that, it's not Microsoft's intention to replace Terraform or to have people move away from Terraform and start to Bicep. They are also working on getting the Terraform experience better and making sure that you have that option as well. It's just for you to have another option to be able to do infrastructure as code and declaring your objects in these files.
Yeah, it's just providing different levels to step into automation and DevOps.
That's great to know. That's a very good insight. Thank you so much for that. How difficult do you expect it's going to be for people to get started with Bicep? And then for this, I'm referring to the experience that some people have and have already talked about on Discord, that they're currently only using the Azure portal. And that when they wanted to have an ARM template, they would go to the export template functionality. Do you expect something like this to exist for Bicep as well?
Maybe, yeah, I could see it happen that once you have the ability to feed Bicep files directly into the ARM engine, you will also have the option to download, like Esther showed, not the ARM code, but also optionally the Bicep code and get started from there. I could definitely see that happen in the future, yeah.
Yeah, maybe not directly in the Azure portal, but I am expecting them to integrate Bicep directly compiling and build functionality into Azure DevOps, for instance, or maybe even GitHub Actions. So that's more the area where I think the integration will definitely take place.
Yep. And what you also see is that if you visit some of the docs pages where Microsoft shares some of our sample code, they already have different tabs there at some pages where you are able to download example ARM code, but also already example bicep code. So just indicating how serious they are with this new step.
So gone will be the days when we program in JSON, and if we forget a square bracket, our entire deployment is completely wasted. I'm looking forward to that.
Yeah, we might have to have different conversations once we are once again allowed to meet in person and have those drinks at the bar again.
I'm looking forward for those days as well, really, Esther.
So can I just say thank you so much for the session? Like, I really enjoyed this. I think you showed how powerful Bicep is going to be. I really think this is a good step forward because of course, we all know like Bicep is hard. ARM is a bit hard to get started with. It is like a bit of a border for people to actually do it. So I think Bicep will make it sure that we can actually bring a lot more people into this. So thank you so much for showing this today. I will say goodbye to you. So thank you for being here. I hope you enjoyed it. I really enjoyed having your session. So enjoy the rest of your day.
Thank you. And it was great having us. So thank you for that. And enjoy the rest of the sessions. Have fun, all.
Thank you.
Yeah, thank you so much.
Bye-bye.
So we are going to do a 30-minute lunch break. So we're back in at 1:45. So at that time, I will be joined by Eddie. But before that, I want to say thank you, Alex. You were a great co-host. Thank you so much for being here today. Hopefully next time we can do this in person again. But for now, you can actually enjoy your son's birthday.
Thank you so much, Elder. First and foremost, thank you so much for the audience for following us, and thank you, Elder, for having me. It was a pleasure to be here. But to be honest, I'm really looking forward for some cake, sitting down on my couch and just watching and following the next couple of sessions. Thank you so much again.
Thank you. And so everyone, enjoy your break, have a bit of lunch, and we'll be back in about 35 minutes. Thank you all. So welcome back, everyone. So I hope you enjoyed some lunch. I hope you're all powered up again for the rest of the day. So before I introduce our next speaker, I want to introduce my new co-host. So Eddie, welcome. Thank you for being here today.
Thank you, Eldred. I'm super excited for all the great sessions that's coming up. So happy to be here. Thank you.
Thank you. So can you introduce yourself really quick?
Absolutely. Hi, I'm Adi Pollack. I'm a senior cloud advocate at Microsoft. I'm focused on data, data on Azure and data on Microsoft technologies, mostly share tutorials and information and best practices on how to build big data architectures. And it connects really well with our next session that's coming up pretty soon. We're going to talk about best practices. Super excited.
Awesome. So let me introduce Heini. Heini, welcome.
Thank you. Good to be here. Very excited for this one.
Hi, Heini. Good to have you.
Yeah, great to meet you.
Same as well. So you mentioned you have a background in mathematics. So how is that connects to, I mean, I have kind of an idea of how mathematics is super relevant for big data, but what's your angle on it?
I think for most part, for me, what math has brought to me in regards to kind of looking at architectures and things like that, it's mainly actually problem solving, not the mathematics itself, because that's what math is all about. It's kind of finding the relevant information and knowing how to use that together and put that together into a solution. But of course, if we go into machine learning and data science, that is like heavily based on math, like really a deep stuff of math. So really it all also ties into that part. But today we're mostly going to focus on the architecture side of things.
Wow, that's great. Yeah, the stochastic and different challenges that comes with huge data when you can't really calculate everything exactly the way it is, and there's some randomness things going on is super exciting. So which technologies are you going to cover today in your session?
So in today's session, we're kind of going to look at the whole landscape of data services in Azure, and we're going to do it by looking at a reference architecture that Microsoft has provided and kind of look at that from the angle of what if your data isn't actually big? So can you actually use that reference architecture right away, or do you have to kind of tweak it or alter it in some kind of way?
Yeah, that's a big question. A lot of people ask me, like, when do you know it's the right time to use big data tools? I mean, what is the right size of data when you're actually doing the shift from, running a microservice into running on big data architecture? And many of the times it's not like you can give them a specific size, say, hey, once you reach this terabyte, then you go to the big data tools.
Yeah.
So exciting.
We're definitely going to discuss that.
This is super exciting. I'm looking forward to learn from you so much. Eldard, what is your take on big data architectures?
Yeah, so I think it's really interesting. Like, I come from a company where we don't really do that big data. Like, most of our clients are like gigabytes, maybe a couple of 100 gigabytes at most. That really big data, I do find it very interesting. So I actually want to hear a lot more about this. So I'm really looking forward to this session, because it's just such a different world. You have to think in such different concepts instead of just, I have this data here and I can just query it and it will just give me back my response. Also, you have to think about how I'm going to query over 100s of shards of data and how am I actually doing all this, bringing this all together. And so it's really interesting, I think.
Exactly.
Yeah, so many. Exactly. So many challenges. So how many years have you been working with Azure and Microsoft products, Heini?
I've been working with Azure for the past 4 or 5 years about now. So I kind of feel like I came in at the right moment when the classic things were kind of fading to the background and that classic portal was mostly gone or starting to go away. So kind of been there all through when we've been working on the ARM side. And yeah, I think on the data side, these years have been really exciting. And even this last year with Synapse going generally available, it's kind of it has been really exciting, I have to say.
Awesome. So with that, I would say we are really looking forward to this. So I will start your session, and we are definitely going to listen a lot to what you have to say. So good luck, and we will enjoy this.
Thank you.
Thank you.
All right. Welcome, everybody, on my behalf as well. As you kind of heard from our kind of pre-chat, we are going to be talking about adapting big data architecture patterns for real-world scenarios. So even for me, as I've been working for the past years, most of the customers that I work with don't quite have that big data scenarios in their kind of data in regards to the amount of data. So what that got me thinking about is like, how do you work in that scenario? There's so much hype and technologies around big data. For example, Azure Data Lake, it's said that it's optimized for big data and analytics scenarios, and there's Synapse coming in, which is also optimized for those situations. So how should we look at these different products and the different patterns that there are available for big data and take them into our data scenario and use them in the best possible way? So I just want to start by thanking all the organizers for putting together such a great event. It's great to be a part of this, and it's so nice to do it when everything is so well organized, and there have been such great speakers already previously today. But without further ado, let's get to the session today. So let's start with big data. Since we're going to be looking at big data architectural patterns, we need to understand what is meant by big data, because those patterns are based on that assumption that there is big data available. So what is that makes big data big? You might have heard big data defined with either 3 Vs or 5 Vs. And I'm just going to share the 5 Vs because I kind of want to emphasize which ones of those are the most important when we consider whether we go for those big data tools or patterns that we want to use in our environment. So when we talk about big data, the first one that comes to mind, of course, is volume, that it is actually big data. And of course, depending on the source where you might read about big data, this volume might be defined differently. But in most cases, it's not just gigabytes. It could be terabytes or even petabytes that is meant by big data. And that might already get you thinking, well, I might not have big data in regards to the size of it. So does any of this big data stuff even affect me? The second V of big data is velocity. And what velocity means is that there is data coming in at a bigger speed than before. So it's not just that we have big amounts of data, but we have more continuous streams of data coming from different sources. The third V is variety, and this means, of course, different kinds of data, not just relational data that we might be kind of traditional, more used to working with, but we might have photos, videos, all kinds of streams, etc. All these different types of data that we want to work with. Then the fourth point here is veracity. And what veracity means is that we need to be able to trust our data. So really, if we cannot trust our data, whatever we pull out from that data, we cannot then also trust those results. So if our data doesn't have veracity, it's very difficult to even work with our data at all. And as the fifth V, we have value, which means that this data that we have should have some kind of value for us. As a business, it has to have some kind of meaning to us for us to be even able to work with. And so actually, if we think about these 5 Vs, it is not so much essential whether we have big data or not. We need to see whether we can actually pull some kind of insights from that data. Even if we have massive data, it doesn't really matter if we cannot find any kind of new insights from it. So what if we, instead of big data, for example, have some medium data? We don't have the volume that is meant with big data, But we do have the velocity, variety, veracity, and value in it. But on the other hand, what if our data is just small? What do we do in that scenario? So how we will approach this kind of problem here is that we're first going to be looking at the Azure reference architecture for data platforms. After that, we will be looking at what do you do with this reference architecture if you don't have all the Vs, not all the 5 Vs. And then as the last point, we will be looking at how can you make it your own and adapt it to your specific scenario? What are the steps that you need to go through? So I'm Heini Ilmarinen. I actually don't work as a solution architect at Atea Finland anymore. I work as a DevOps consultant at Polar Squad. I'm a Microsoft certified trainer, and you might notice that I really love architecture. It's kind of my favorite topics to talk about, and especially if there's a data spin to it. And as said, I used to be a mathematician. That's my background, and that's kind of a part of me that doesn't really go away. So, and you might notice that I doodle a bit even in my slides as well. But let's get started with the Azure reference architecture. What we're going to be basing today's session on is this reference architecture that we have the link there at the bottom if you are able to see that. And this is one of the reference architectures that Microsoft has provided for data platforms. There's many, many more on that side as well, but we will be kind of using this as our base in this session. So to really understand what kind of portions of this big data architecture data platform we could be using, we need to know what is each portion in this meant for. And by doing that, then we're able to understand which ones of these we really want to use as well. So if we start with our data sources, in most cases, we will have some kind of relational databases. That is what most of our traditional applications are based on. That's where they write their data. We might have different kinds of data stores and data warehouses and things like that that we want to use. But more and more, we might also have these semi-structured data sources, which means things like XML, JSON, whether it's some kind of APIs that are generating data or whether it's coming from some external APIs, etc. We have many, many formats that we're gathering. And not even just having that semi-structured data, but we might also have things like photos, videos, just kind of PDFs, so documents that aren't in any kind of structured format, etc. And even more, we might have these streams of data, which might be coming from, of course, IoT devices comes to mind first, but they might be coming from things like applications that are constantly creating data as well. So it's not just IoT devices on their own. There can be many kinds of streams made. So for example, if you were to be getting data from Twitter constantly, that would be kind of like a stream because it is constantly creating data for us. So everything else in this architecture is based on the assumption that there is big data. It is based on the assumption that there is volume. There is terabytes of data or even more available for us. It is based on the assumption that there is a large velocity of data coming in. It is coming in constantly and at increasing speeds. It is also based on the assumption that there is variety. Even just looking at the types of data sources that we have in this picture is kind of describing that there are many kinds of data sources that we're using. But it is also assuming that there is veracity, so that the data is trustworthy. And if it's not, we have to do something about it to make it trustworthy. And it is also assuming that there is value in our data. We shouldn't be really going into any data project with data that doesn't have value. So just keeping in mind as we go along, these are what we're assuming about our data as we have these different parts in the solution. So as we go along, we start with the first portion, which means that we have to have some kind of way to load and ingest data to our data platform within Azure. And what is used in this reference architecture is Data Factory. And so data factory is used in those scenarios where we are pulling more batch type data in. It's not really optimized for the scenarios where we're doing streaming data. So we would use it for these data sources where we have more batch-like processing on that data. But since we also have in this picture the streaming data, we need also some kind of way to pull in the streaming data as well. And so what is used here is event hubs. But for example, if we were using IoT devices, we could also be using IoT hub, etc. So remember that with most of these pieces, we have many options what we could have in there. And we'll be kind of returning to that, like how can we adapt this? How can we change this up if needed? As the second stage, as we're pulling data in, we're loading it, we're ingesting it, we want to store that data somewhere. So we need some kind of storage layer. And in the reference architecture, where we're putting all our data is a data lake. And that is where we're pulling in our batch data coming through Data Factory. But we are also pulling in the streaming data coming through event hubs. So we want to have all our data gathered someplace in its raw format so that we can do, for example, cleaning of the data, we can do just exploration of the data and looking at, can we find, for example, some kind of correlations between the streaming data and the batch data as well. It allows us to work with all of our data from one place. But data lake is kind of this place where you could just dump your data, but you don't quite want to do that. You want to have some structure there as well. But it is not really a relational database. And if you have needs to be able to have modeling on your data, then we're going to need some kind of other kind of data store as well. And what we would be using here is Synapse Analytics. And what this means from Synapse Analytics, this means that old data warehousing side. And we're going to come back to Synapse Analytics in more detail in a little bit and how the entirety of Synapse Analytics fits in. But right now, we're just looking at the portion that is the previously called data warehouse portion of Synapse Analytics, where we can do the multi-parallel processing workloads, etc. So really, this is for example, creating your schematic models, or if you need to do some massive processing on your data that requires that parallelism capabilities. And this especially comes true when you are working with bigger and bigger data. As the next part, though, once we have stored the data somewhere, we then need to, in most cases, also process it in some way. And the one component that is used here in this reference architecture is Databricks. And Databricks is a Spark-based kind of analytics platform that we can use. And we can use it to work directly with data in our data lake. But we can also use it to work with our data within Azure Synapse. And so we can be both reading the data, doing some processing on it, and then writing it back. And what this processing could entail is, of course, cleaning the data, making some checks on the data that it's valid, or replacing some null values, for example. But this can also be things like transformations on the data, or doing aggregations, or anything like that. So there's multiple kind of processing that we might be needing to do on our data. And if we want to take that one step further, then we can combine also Azure machine learning or cognitive services to the mix as well. And take, for example, that process data there and do algorithms and modeling on our data to even go more to the predictive side of things. But now we've been kind of working with the data that is already stored in the data lake or Synapse Analytics, but we might also want to do some immediate processing on the streaming data that comes in. We don't just want to wait for it to be put into the data lake and do some bigger processing on it. We want to immediately be able to, for example, notice any deviations in the data, etc. So what we could use here is stream analytics. And with stream analytics, we can look at the stream of data coming in and, for example, look at a specific window of the data coming in and even analyzing that on the go. So we're able to gain some insights to our data right away as it's coming in as a stream. Then after we've been doing the processing, we get to the next stage, which is the serving. So with serving, it is taking the data to a place where we then are having it for our consumers to use. So one of the most common scenarios when you were creating data platforms is of course just visualizing the data. And the logical progression from there is to use Power BI. So in this reference architecture, we have Power BI Premium in place. So we can use data from Synapse Analytics and create dashboards within Power BI Premium and then have those published to our end users. But on the other hand, we can also have Power BI dashboards for our streaming data. And of course, it is a reference architecture for those big data scenarios. It is, again, Power BI Premium. And we can just create that dashboard directly from the stream coming from Stream Analytics. Of course, there's differences on what kind of dashboards we can create for data coming in from this kind of more static data store than coming from a stream. But with a stream, we can get certain things visible right away that we might need. But the only use case might not be just visualization, but we might also need an application use the data. And since we've been doing some transformations on our Databricks, we can then take some data from there and put it into Cosmos DB and have our Cosmos DB pull the data from Databricks. And then we can have an application use that data from Cosmos DB. And then as the last bit here on the right, we of course have the actual consumers. So the users that are using, for example, the dashboards from our Power BI reports or the applications that is reading data from Cosmos DB, for example. So by going through this entire scenario, we are kind of able to get this full picture of what is each of these components for. And as we understand the use of each of these components, then we're able to see, do we need each of these capabilities? Or can we take something out? Or can we replace something with another service, etc.? It gives us that capability to make decisions based on what we need. As you might have noticed, we've been kind of having Synapse in the picture here, but we haven't looked at the whole capabilities of Synapse Analytics yet. And so I want to show you how it fits into this big picture and where you would fit that in, the entire feature set of Synapse Analytics. So if you've been following the data platform side of Azure quite a bit, you probably have heard about Azure Synapse Analytics. And it was first that the old data warehouse got renamed to Azure Synapse Analytics. And then there was Azure Synapse Analytics Workspace, which was in preview. But now they've all been packaged into one service that entails all the new capabilities, plus also the old data warehouse side. So how does that fit in this reference architecture? Where would its place be? So we bring Azure Synapse Analytics into the picture. And if we look at this picture, it actually kind of overlaps all this area that entails Data Factory, the data lake section, and also, of course, the Synapse Analytics portion as it used to be called. And we can kind of overlap it with Databricks, but I'll explain what that means, that it's kind of, there's some capabilities that are similar, but it's not the same as Azure Databricks. So that's why I didn't contain that in the box. But the components aren't quite called the same within Synapse Analytics. So when you're creating Azure Synapse Analytics, you are required to have an Azure Data Lake. So yes, that you have within Synapse Analytics. But then as we look at this, the different components that are contained, what is called this massively parallel processing SQL within Azure Synapse Analytics is called now dedicated SQL pools. So you are able to define a capacity that you need for doing those massively parallel processing needs that you might have, for creating your models, for your data, for having those distributions of data so that your queries are as fast as possible. The thing about dedicated SQL pools, though, is that it is not optimized for the situations where you have many users reading the data. It is more optimized for doing that processing and then having just a few processes reading your data. And depending on your data size, it will vary whether you will actually benefit from being able to parallelize those queries that you want to run against your data. So dedicated SQL pools, just to confirm that everyone remembers this, is the same as the old Azure Data Warehouse. So same service, but in a different package. The second part that we have within Synapse Analytics that we might know from before is the portion that looks like Data Factory. But what it's called within Synapse Analytics is pipelines. And it doesn't actually have the Data Factory icon on the Synapse Analytics side. It's just a pipeline over there. So we have the pipelines, we have the data lake, and we have the dedicated SQL pool. But in addition to that, we also have something else in the mix that is not kind of anything existing in Azure at this point before Synapse Analytics. And one part of this is the serverless SQL pools. So this is a T-SQL engine that you are able to have within Synapse Analytics that you are able to use, for example, querying your data lake directly and doing queries on that flat data right away without having to have a relational database at all even. And then the other portion of Synapse Analytics that we have in the analytics engine side is Spark pools. And as you might remember, Databricks is also Spark-based, and this is also Spark pools. But remember, Databricks is kind of a packaged service that has the entire cluster management of Spark clusters, etc., kind of massaged into the service, etc. So the Apache Spark pools within Synapse Analytics are slightly different. So you could choose to go with one or the other, or even use both at the same time and let them complement each other. And so what the benefit of Azure Synapse Analytics here is that it brings together so many of the different capabilities that we might have previously needed to take separately from Azure. So really you get this management benefit and monitoring benefit, and you also have one user interface that you can use for managing everything. But also you do have these services outside of Synapse Analytics that you might want to also have in your data platform still to complement the features of Synapse Analytics at this point. So we've looked at the reference architecture both as it is, and then looked at how the whole feature set of Synapse Analytics fits into the picture and how you could kind of replace part of this data platform solution using Synapse Analytics. But I also want to look at the situation. What if you don't have all of these? So if we look at all the 5 V's, volume, velocity, variety, veracity, and value, you might not have all of these. And for example, most of the customers that I've worked with, they don't quite have the volume in the sense of what is meant with the definition of big data. They don't have terabytes of data. They might have gigabytes or hundreds of gigabytes or something like that, but not necessarily massive volumes. And the other aspect that is oftentimes missing is also the velocity. They might have, for example, some IoT devices in place, but those systems might be so closed that the only way to communicate with those is by doing batch processing on that data, just moving the data around in batches. So that is one of the most common scenarios that I come across. So I want to look at how you would take this reference architecture and adapt it to this kind of scenario. So if we look at the entire set to begin with, we can start to kind of strip it down to the parts that are needed when we don't have velocity and the volume. So let's assume that we don't have the velocity in the sense of we don't have any streams. So that means that we can start working with the top part of our reference architecture and just taking the streams out, which means that we don't need the event hub at all for our scenario. It also means that we don't need the stream analytics service either. And that means that we're not going to have a dashboard created out of our streaming data set either. So it already comes quite a lot simpler than it looked like in the beginning. Then, as the other portion that we might have in the picture is that we don't quite have the volume. And how that will affect us is that, for example, if our queries are simple because we have such smaller amounts of data, it might, for example, need that we cannot leverage the massively parallel processing capabilities that we have within Synapse Analytics. And it could mean that it would make more sense to put our data in a regular Azure SQL rather than Synapse Analytics, and then do the modeling within Power BI itself. And I also changed the Power BI to just regular Power BI instead of Premium, because you can get quite far with just using Power BI. And as long as you have the knowledge that you can trust your data, and as long as you know that you have data that has value, then even if you replace some of the components with other ones, you are able to gain those benefits from having all these functionalities within your platform, even though you are using a different service. But for example, Azure SQL can do the processing that you need for your data amounts that is needed. You might not need the full capabilities of Synapse Analytics. Then, as the other portion here that kind of sticks to the eye right away is the Cosmos DB. So Cosmos DB is often kind of told in the marketing slides that it is this globally distributed database that you can have really high SLAs and so on. So for example, if you don't have those needs for global availability and so on, you could also change that to a regular SQL database as well. So just as you can have the SQL API within Cosmos DB, you could change that up with Azure SQL and have your application work with that database. Of course, the database that you would use depends a lot on the application that you have and what kind of database it is built to work with. But just for an example, we're just replacing Cosmos DB with Azure SQL. So here was just one example of how we can simplify this reference architecture to our scenarios. But the question might be that this isn't your scenario. So then the question states, how do you make it your own? How do you take this reference architecture and really just turn it into something that you can use in your own environment? How do you go about that? So how you start is that you pick your functionalities. So as we've now walked through the entire reference architecture, you know what is each of these components for. You know what each of these components' purpose is. So you're able to go through this architecture and just pick and choose which of the functionalities you would need from this architecture. So, for example, you might not be entirely sure about what the quality of your data is, and you want to first verify that before you want to go into things like machine learning. And you want to make sure that you have all the bases kind of firm and you have your basic data transformations in place, etc. So you could take out Azure Machine Learning in the first place. It doesn't mean that you cannot take it back in the future, but in the first phase, you might choose to take out the machine learning portion of the reference architecture. And in a lot of cases, this might be a smart way to go anyways, even if you're thinking about going for the machine learning scenarios as well. But you might first just want to make sure your data is moving right. You have been able to verify the quality of it. You've been able to verify that your data is actually truthful and will be valuable for your machine learning scenarios. So you might just take this first step anyways. The other part that I took out in this scenario is the application side. So if you don't have an application that needs to use the data from there, you don't need to have that in the reference architecture either. So you just go through the reference architecture, you pick and choose which functionalities do you need. Do you need streaming? Do you need batch processing? Do you need machine learning, etc.? You just go through each of these parts. As the second step of what you want to do next is that you want to go through this reference architecture and scale or replace any of the services. So just as we walked through the previous example where we were replacing, for example, Synapse Analytics with Azure SQL, you can of course do that. But there are many other places in this reference architecture where you could be using something else. So for example, the streaming data, if you have just IoT devices and you are building from scratch, you could have an IoT hub instead of the event hub. On the data factory side, if you already have a tool on premises that you're using for all your integrations and you have skills for that, you have knowledge for that, you have the monitoring in place for that, then that means that don't change something that you know. It would be a big process to change that for everything. So use your integration tool that you have in place, but you can just integrate that to take your data into Azure Data Lake. And kind of through going through piece by piece, you get to evaluate which pieces you need from this reference architecture. And just as we were looking at how Synapse Analytics, the entirety of it fits into the picture, you could choose to replace Data Factory, Data Lake, Synapse Analytics, and even Databricks with the entire Synapse Analytics feature set that we have available. So you could replace all those 4 services with Synapse Analytics entirely. So that would make this scenario a whole lot more simple for us in regards to how many services we have here. And one of the most commonly asked questions that I get is that, well, when would you go with having these separate pieces? And when would you go with Azure Synapse Analytics? So I think what we need to remember there is that Synapse Analytics, it is generally available now, but it has been around for quite a short time. So it means that it is constantly evolving. There are new features coming in all the time. And the thing is that we can just use the pieces from Synapse Analytics that we need as well. We don't need to use all of it. And now it's getting interesting because my lights are going out here. I'm not sure if you can see that, but it's okay. You still see those slides. Excuse me. So you can use the pieces from Synapse Analytics that you choose to. You can use the pipelines, you can use the data lake, you can use the on-demand SQL or the serverless SQL pools, which will allow you to, for example, do exploration of your data within your data lake much more easily than, for example, in this scenario that is drawn out here. So you can go, I think, with either one, with the separate pieces or with Synapse Analytics. But if you're kind of looking towards the future, I think it is smart to go with Synapse Analytics because you get all the basic functionalities of pipelines and the data lake. You can still link a Azure SQL to it as well and have your data moved there if you don't want to use the dedicated SQL pools portion or the old data warehouse if you don't need it. So you can still link it with other Azure services as well. So you're not just stuck with the capabilities of Synapse Analytics either. But you get, for example, I think my favorite part actually of Synapse Analytics is the serverless SQL pools because it makes that data exploration phase so much faster. So if you want to leverage that, then I would say definitely go for Synapse Analytics. And the other part of that is just linking the different services together is a lot easier in Synapse Analytics. The other part that we need to be looking at when we're kind of going through this reference architecture and replacing and scaling services is that we can also bring our other services in. So if we, for example, have an API strategy and we want to publish some APIs, then what we could do, into this reference architecture is bring in also API management. And then we could have, for example, Azure Functions reading and writing the data from our data lake or from our SQL to have that data available from the APIs that we have defined within API management. So you're not just restricted to what you have available in the reference architecture, but you can also expand it to contain any other needs that you might have in your architecture as well. So always remember that you have that capability of also expanding the capabilities. And the most important thing in regards to this phase, you of course want to scale the services to whatever is the scale that you need. Of course, some of them are just you get the capacity as you use it. For example, you don't have to think about scaling your data lake. etc. But for example, with the Synapse Analytics or the dedicated SQL pools portion, with that one, you can start and stop it as you need. You don't need to have it running all the time. You can just do that heavy lifting within Synapse Analytics and then write the data elsewhere and have it used from another data store. So you have so many options of how you can take this architecture and adapt it to your scenario and to the amount of data that you might have. And then as the kind of the last step, when you are taking this reference architecture and you are first have gone through and picked your functionalities, you have replaced any services that you might have need for, you scale them to the right size, and you might even add any additional services that you might need. The last point that we need to do is implement like you actually do have big data. And what I mean by that is that when we have this entire architecture at our hands, there is a lot of design and into each of these services. So for example, with your data lake, don't just randomly dump all your data in. Think about the folder structure, think about how you organize your data. And when you're deciding that strategy of how you organize your data into folders, etc., in your data lake, think like you have massive amounts of data. Because I can guarantee that the amounts of data that you will have will grow. Even if you don't have big data quite yet, it will grow. And you want to make sure that you've kind of had that mindset from the very beginning. And then, for example, with Synapse Analytics or the dedicated SQL pools, there we can use partitioning and design our partitioning strategy so that our querying will be as fast as possible. And so, for example, if we're creating a star schema for our report, then we want to make sure that each of those tables that we have has the right partitioning type chosen for that table. And by that way, we can then ensure that the queries that we run against those tables in our dedicated SQL pools, we're able to run those queries as fast as possible. And why shouldn't you be considering this already when you have even kind of not big data yet? Because fast queries is always a good thing. So as long as you have data that has value to it and you want to have it perform well, take these kind of the best practices around partitioning and structuring your data into consideration right from the beginning. Because then it will be very easy to build out as you have more and more data, but it would actually be quite difficult to go back and just change everything because you have just been kind of taking the fastest way and just putting your data in the easy way. And kind of if you take this mindset of I already have big data, then you ensure that you're kind of having that structure and clarity to your data platform from the very loading and ingestion portion all the way to when you're serving it. So think about having big amounts of data when you're setting up your data factory pipelines. Think about it when you're structuring your data lake. Think about it when you're designing your models in your Synapse Analytics dedicated SQL pools. Think about it when you're creating your Databricks notebooks. Think about it when you're creating your Power BI dashboards and workspaces and thinking about access control and things like that. Always think like you have big data. So what we've been going through in this session is we walked through the Azure reference architecture and went through all the different bits and pieces and what their function is. Then we went through and looked at one example of what if you don't have all the 5 Vs. And in our case, what we looked at is kind of, I think, at least the most common scenario that I've come across. You don't have the volume, and you might not also have the velocity either. And then we looked at 3 steps that you would take to make it your own, to make the reference architecture your own. So what you want to do is you want to pick the functionalities you need, then do any tweaking of the services or changing them around or scaling, etc., to ensure that you have the right scale and the right size and the right services that you need for your amounts of data. But then as the last thing to really think that you do have big data when you go through each of those services and decide how you're going to configure each of them. So what I hope you to take away from this session is that to remember that whatever amount of data you might have today, you actually have the right amount of data already. Because it doesn't matter whether you have massive amounts of data, it doesn't matter whether you have massive velocities of data, you can still really benefit from the different patterns that we have for big data, because they will also work for smaller data even. They're not just restricted to the field of just having terabytes, petabytes of data. You can already have that mindset. And somebody with really big data might even think you're kind of easier off because you don't get the complexities that come with big data, because there you cannot get away with not considering everything in regards of having massive amounts of data. So you're kind of well off in that case if you don't quite have big data yet. And the most important thing is to figure out, how can you draw insights from your data? How can you gain something from your data that you have not known yet, for example? How can you bring visibility to your data so that your users actually know what is happening? And even through those simple first steps of just bringing your data visible to the users, you are able to gain a lot of benefit and a lot of success for your organization. So really kind of take this away from this session. Remember, you have the right amount of data, and what you just need to do is to find the ways to draw insights from that. And by using the reference architecture, we can just take the bits and pieces that you need to have that data platform set up so that you can gain the most insights even from medium-sized data or even from small-sized data. So thank you very much for joining. If you have any questions, I will, of course, take them here at the end, but also you can shoot me any questions on Twitter as well. Thank you so much. So.
Fantastic. Thank you, Ahini. It was wonderful.
Thank you. Do we have any questions?
Yes, we do. Are you ready?
Yes, I am. That's my favorite part.
Awesome. So people are asking, Cosmos DB has SQL-like syntax to query. So can we replace SQL Server with Cosmos DB?
Yes, that is a good question. So the syntax is SQL-like. So that's good to remember. It's just SQL-like. So you will need to do some tweaking with it. So it's not exactly compatible, right? Like just pull out the SQL and put in Cosmos DB. With the other kind of APIs that are available in Cosmos DB, like the MongoDB API, that is kind of compatible with a regular MongoDB. So with the other ones, you can get away with just replacing things. But with the SQL, you do need to do some tweaking actually for the application.
Cool. Thank you. Another question, and also comments. People really liked your doodling. They said it's really helpful and make everything super clear. They also said they're going to use that for different in-depth sessions they do at work. And they're curious to know, which tools are you using to build them?
Oh, yeah. I can actually, I can show you, because I happen to be using my drawing board. This was my second screen today. So it's a Wacom 1 drawing board. And I just draw, it comes with a pen. And I draw them directly on PowerPoint. So you could actually be drawing them on any device that you can have a pen for. So for me, I just use the Wacom because it's a little flatter and it's a little more sticky because the laptop screen is a little slippery. I've done some of the drawing on my laptop directly as well, but it's a little, takes a few more tries to get it right. I have to do a little tweaking and erasing and do it again. And then actually within PowerPoint, there's just this kind of replay animation for any drawn object. So you just choose what you've drawn, and then you find from the animations for those objects, you have this replay option. So it's directly built into PowerPoint. I figured this out this last fall. And I was so excited when I found it. I was like, this is amazing.
Yeah, all the great features built into PowerPoint. I was also recently, I discovered a few awesome features. I was like, what?
Yeah, it's
Yeah,
pretty
yeah.
neat. Very simple
Yeah.
and straightforward. If you do a whole ton of drawings, though, into one presentation, it can get a little slow on the navigating around PowerPoint side, but it's holding up quite well.
Cool. All right, we have another questions about the architecture reference. People are asking where they should go to learn more about that and the different services, to make the solution their own and fit their needs.
So actually, the site where this reference architecture is on, I can pop the link into the chat in just a moment. So there is a lot of information on that page on the different services, and there's also some of the options of which you could replace them with, also presented on that same page. So it's the Azure Architecture Center where this reference architecture is also found. It's actually a really good resource for all kinds of architecture problems that you might be thinking about. Just go poking around and you can find so much information in regards to the different components used on those. So I can highly recommend that, and I can have that link available to you in the different channels that we have here.
Yes, please do. Eldert, do you have questions?
Not a really question. I just want to say it was a very clear session. So I really enjoyed, like you explained, like this is not my thing that I'm normally working on, but I could actually follow everything. It will make very much sense to me. And I see in the chat that I'm not the only one that's saying this. Like people really found very explaining. So thank you for that.
Perfect.
I actually have one question. So you talked about Synapse. Do you think like Azure Synapse is now being placed kind of like the Holy Grail? Like if you look at Microsoft sessions, Azure Synapse all start popping everywhere. Do you think it will actually be like this Holy Grail that we are looking for? Do you think it will actually accomplish what Microsoft is looking to accomplish with this?
Well, as I said, it's pretty new, so it's not quite in the place yet where everything works perfectly in all the scenarios yet, but I do definitely think it's going that way. So I'm kind of very excitedly following how it's progressing, because there's so many great features coming in all the time, and it's getting better and better, and I really hope so. I hope it will become that, and I think there's already certain steps that really have made it one of those things that bring kind of the void between relational data and kind of all the other types of data so much closer, where you have similar tools that you can work with both. So that's kind of, I think, the really value of what is brought with Synapse Analytics. You're able to kind of use SQL query to query your CSV files. It's just like right there the same way. So it makes that so much easier. And I think those capabilities will keep growing all the time. And Microsoft is definitely putting a lot into it. So whenever they've been doing that, I've seen that things have taken like huge leaps. So
definitely makes sense to me.
Yeah.
Yeah, Microsoft is putting a lot. I can tell from the Microsoft side, a lot of people are working it, and a lot of people are, really care about all this great input. So if you have any feedback or some features that you want to see there, then I'm calling, not only you, Heidi, but everyone that listens today to come and, send us an email and let us know. We really want to make it a great product.
Yeah. And the one thing also that people ask is like, should they be worried about working with the separate services currently, like Data Factory and Data Lake and things like that? But the one thing I even forgot to mention during my session is that because the pipelines within Synapse Analytics and Data Factory, they're kind of based on the same code base. So you have the same features in both, and they're kind of evolving hand in hand. And you already have, for both of those, you have the Git configuration. So really, if you connect it with Git, you are able to kind of pull all your pipelines and things from your Data Factory and pull them over to the Synapse pipeline side. So I think there will be definitely in the future an easy way to kind of transfer between the two. So I don't think you should be too concerned about what you're using right now. Just keep building things that really make the most value out of your data, and at least how it looks like to me, it will be kind of easy to transfer from like data factory and data lake to Synapse Analytics in the future.
Yeah, absolutely. All right.
So with that, I would like to say thank you for your session. Like, I really enjoyed it, and I'm looking at the comments. Everyone really enjoyed it. So great job on that.
Perfect.
So one call out. So I know you have been doing some work with AI42 lately. So I would actually recommend people to also look at that, because I've been watching your sessions. It was way over my head with all the stuff you were explaining, but I do find it really interesting. So
yeah, we're with AI42. They're doing this kind of progression of lectures from math to machine learning tools and to data science and so forth. So I've been running the math sessions for them, and I think we have 3 more coming up. So if you're interested, definitely go find AI42 and take a look at the math sessions. I kind of took a little leap back to my roots and did a few sessions around math, and there's more doodles available there as well.
So thank you so much. I hope you enjoy the rest of your day, and I hope to see you around soon.
Yes, thank you so much for having me. It's been great.
Thank you.
Thanks, Hahini.
Thank you.
So before we go to the session, I just want to say thank you everyone, of course, for being here today. I just want to throw some quick reminders. Like, if you're not on Discord yet, please head over there. There's a lot of discussion going on there. People are discussing the sessions. People are discussing just how they are enjoying the day. I saw a whole thread coming by about what people were having for lunch and things like that. So please join in. So of course, Discord is actually important if you want to join the raffle. So everyone that has registered is actually joining the raffle. So keep in mind, we are doing the raffle at 4:35. So you have to be on Discord if you actually want to claim your prize. So that's for all the people who registered. If you did not register, still go to Discord, because we also have a second raffle for the people that are just active on Discord. So just join in the conversation, and you can still win a prize there as well. Also, I still want to call out, like, visit the sponsors. The sponsors are making these kind of events possible. So please have a look at them. Just say hi, just ask what they're doing, see how they're doing, and just let them know that you are actually thankful for having these events. Because like I said, without the sponsors, we cannot do these events. They really make this possible. With that, I want to introduce Erik Lieben. So Erik, welcome.
Hi, Erik.
You are still on mute, but that's the catchphrase of 2020 and 2021.
I was testing out if my slides would work, so going back to the first slide again. Hi, how are you doing?
Good. How about you?
I'm fine. I'm happy to be presenting.
Yes. So I know that you are quite active in the community as well. So I know you run a couple of user groups, I even think, and you do a lot for the community.
Yeah, the .NET Amsterdam meetup. I run that one, but it's been a little bit silent because we mostly did in-person meetups. But this is a great way to also see how that remote thing or virtual thing is working, or if that's something that's fun to do. So let's see what happens.
Awesome. So you are going to talk about event sourcing with Azure Function Storage and Event Grid, and doing it for pennies. Like, I'm a big serverless fan. Like, basically, whenever I set up architecture, the first thing I'm going for is, can we do this serverless? It will be a really interesting session, because I think serverless is actually like what the cloud should be.
Yeah, it scales by itself. Everything goes as you give it basically a function, and Microsoft takes care of the rest of it. They do the scaling for you. They do everything for you, and you don't need to worry about all those things. You don't need to manage virtual machines anymore, or things on the machine itself. You can just give them your function, and they will run it for you at the moment, which is reasonable or feasible for you, which is great, because you can just listen to events that occur and based upon that, start up your function, which is the most fun thing in the whole Azure thing that I discovered in the past years.
How many years have you been working with serverless?
Actually, the things I'm presenting, we started, I think, at a factory where I work, with building some of these things and using some of these techniques 2 years ago or so, for a new part of our system. And we've been sure we had some struggles because you learn a lot of new things, but we also had a great amount of fun building those.
That's cool. And your session is going to be about how to do event sourcing with serverless for pennies. So that means you managed to reduce the cost of the infrastructure?
Well, normally you would, for example, have a SQL database which has a certain amount of running costs. And if you use Azure Storage, which is basically serverless storage, you can store things on there, and then the cost for storing those is very cheap. So if you find a way to use stable storage, to instead of using a SQL database that's always on, sure, they have serverless a serverless SQL database nowadays, but then you can run it very cheaply because storage is basically cents that you pay to store your files or your data, instead of having a more expensive way to store data.
Yeah, I know a lot of people who use microservices architecture, running their own services on, and managing hundreds of VMs and machines. So how, moving that to a serverless area, a serverless world, what does it mean in terms of the knowledge that people need to know?
Well, I think you need to get used to, because the first samples I saw for Azure Functions itself was basically this file. You upload something, you upload the file, blob storage, it triggers an Azure function that resizes that image for you, and then you have your resized image, which was great, but we didn't do much with images. So it was a little bit difficult to say, okay, this is what this is. And a little bit later, I discovered, okay, you can actually do this based up on messages you receive or things that occur. And this allows you, if you get into that mindset of more or less an event-driven application, which basically responds and wakes up when something occurs, then it makes it easier to think in that way, basically. But you need to play around with it, make your running hours basically to walk against issues and discover new things before you even start moving things, I think.
Yes. I think what I've seen is people struggle with understanding that, hey, it's all about writing code. I mean, there is this scope inside the serverless that you, as a developer, fully control. And there's a lot of things you can do there inside that. It's just like, well, it's not like managing your servers, because you don't need to think about that part. But in terms of logic, it's open for you to do what you need to do. So this is one of the challenges I saw, and kind of reflects, what you mentioned, because there aren't going to be examples for everything, but as developers, we need to keep to understand how it works and to kind of stay flexible in our mindset, saying, hey, it's just code. We are going to tell the computer what to do instead the computer going to tell us what to do.
Yeah, and the great thing is you can host those Azure functions everywhere. So you can use the consumption plan, which is cheap and has basically shared resources. You can use a premium functions plan, which is, it's more expensive. It allows you to manage basically more or less the resources you have. So if you do a lot, if you have a lot of activity, then that might be cheaper. But you can also run your Azure functions on different on a VM, for example, internally within your organization, if that's the need you have. So you can start using this model and build small parts, and in that way slowly move towards this new model. So you don't also need to do this like basically turn over the switch and go with it, which is also amazing.
Yeah, it just makes it easier for you to test everything that you do on your environment, which is, it's crucial for when you're developing your code. I also noticed you can automate a lot of things with serverless as well. So, for example, I gave a session very, very long time ago when we used to have conferences in live about how you can use Azure Serverless to Azure Functions to change the different tiers that you work with Cosmos DB. So based on monitoring the system, you can automate this kind of processes and reduce the cost, because you don't always need the highest tiers and so on. And it's nice to have a serverless approach and basically right in there everything that you need to do and automate it using it. So a lot of fun. So what are you in your session today, you're going to combine both Azure Functions and Azure Storage and Azure Event Grid. How are you combining them?
What I did was we're basically going to go into this whole event sourcing thing. What is it? How does it work? Because it's a new way of thinking about how you store your data. And then we're going to take a look at some of the. I've did some experiments as well, and at building a custom Azure Functions binding, which allows you to do this very easily within Azure Functions. So so that you don't need to basically do all the work to do this, but you simply, if you would use, for example, a blob input trigger, you would get access to your event store in the same way, and basically are allowed to get your object in the latest state and start doing things with it. So I will cover a little bit less all those systems, but they are in there. And I actually have a few first slides to simply go over them to give you a short introduction of what is Azure Functions, which we already discussed a lot about. What is Azure Storage? What's in there, and what is Event Grid? Because Event Grid is this whole eventing thing, or this whole thing around it, which allows you to basically patch up everything and route everything in the way you want. Because every Azure resource is sending things to Event Grid, and you can basically subscribe your Azure Functions to that to respond to everything, like you said, with scaling up and down Azure function plans.
Sounds really interesting. So I would say, actually, let's go into this. So I will start your session. Good luck, and really looking forward to this.
Thank you.
Absolutely.
Okay, so let's first go over the agenda quickly. I'm going to quickly give you a very quick introduction, because we covered a lot of it already about me and why this session. And then we're going to go into event sourcing, what it is and what all the parts of it include, and how you would do things in an event source system. And then we will take a look at some code samples of how you could do this with an Azure function. So I work as a factory, which we just covered, and we used these same techniques in the past 2 years in a project. We didn't do it exactly as the current code samples, because a lot have changed, and this is the way I would do it today. This is some of the places you can find me at. Twitter, you can find me at Eric Liebe. And I want to make one thing very clear. This is my current understanding of how event sourcing works. If you want to do this as well, make sure you look around a little bit more also to other databases. So, for example, EventStoreDB is a larger database which is tested up on a lot bigger projects. And look around a bit on what it is that you can do with such a database. And start very small, because there's a lot to discover, and you need to make small steps. If you say tomorrow, okay, I'm going to switch over everything to this new thing, you probably won't end up happy. It's not a silver bullet. You need to understand it and find ways to place it correctly. So first, look again at Azure Functions. So it's serverless, or in most cases serverless, and it basically allows you to respond to things occurring and execute the small piece of code you have. It also allows you to write your code in different types of different languages. So, for example, if you have a very good Markdown package, you can use this Markdown package within a function that is written in JavaScript, because that package is for JavaScript. And if all your other functions are in C#, you would simply throw an event that you need to have this processed. And your other Azure function, which is written in JavaScript, would process it again. There is one downside to this. If you're used to a big monolith, where you could basically simply step through all your code or everything that occurs using the debugger, that's not going to happen anymore, because you now have all these small things. So you need to also get used to this, maybe this async model, which you use to get through everything, because the call stacks are now all small call stacks. Next to that, we have Azure Storage, which has been around for a long time. The 3 parts I will cover in this session are table storage, which is basically a key attribute store. So you can store a little bit like a key value store, only then it allows you to store more in the value. And it's very cheap and cost effective, according to the documentation from Microsoft. You also have blob storage, which allows you to store blobs, large files, like, for example, JSON files, but you can also store images there or extremely large files. And next to that, there is something else, which is Azure Storage Queues, which is not something to store things in, but it is to store or not something to store data in, but it's more or less a backlog of work. It allows you to have these small backlogs in front of your Azure function, for example, and let it process work asynchronously. And if you use that together with Azure Functions, you also get your poison queue for free. So if the Azure function fails after 5 times or so, I believe, it at some point in time places it in the poison queue. So if something fails within your system in a small part, you now have this queue and this poison queue, which you can look into and see which message failed. And you can reapply that message within the queue to see if the problem is now fixed. Oh, and of course, it's extremely cheap as your Azure storage. So the next thing is Azure Event Grid, which is basically this thing within Azure that has a ton of event sources which you can subscribe to. So you can, for example, say when a blob file changes, start this Azure function, or start this logic app, or start this, or write it down in this storage queue. So that's that. Sorry, I have a lot of police around. I hope it's not disturbing the recording. So what is actually event sourcing? Or why would you do event sourcing? So event sourcing is basically storing all the events that occur. All the events that occur over time in ordered storage. So this gives you by default an audit log for free, which is great. Which is great for. Gives you an audit log for free, which is great if you do debugging, for example, because you now have this whole trace log, and where you would normally, for example, look into the database, which only stores the latest state. You would see some strange state and try to figure out in, for example, application insights, what actually occurred. But with this full history of things, you can now basically walk over what occurred and see exactly what the changes are. So this allows you to quickly see what's going on. And on top of that, you can easily look at all the other streams that you have or all the other data that you have to see if it occurred more often. If there are more cases where certain sets of events occurred. So with this history, you can also easily go back in time. So let's say in 2 years' time, when you've collected a lot of data, certainly the product team decides they want to send out happy you moved message to customers that moved. And if you have that event data stored, you can now go back in time and answer for them if how often people actually moved. So now you know, before we even built something, by looking back in time and doing those temporal queries or temporal queries to see what occurred. Or you might be able to say, okay, what was the state of this project 2 years ago? And it's very flexible. You can certainly in combination with CQRS, you can, which is something we will cover later. You can basically separate the writing and the reading. So you have a store that's optimized for writing things, and you have one that's optimized for reading things. You could even have multiple. So for example, if you have something to search things, you can optimize that specific data store for searching and have another data store which is just for browsing things, for example. So how is this event sourcing working? Event sourcing is nothing more than storing events in ordered storage. So the only thing you basically need is an order number or a version number and a way to store events. So in this case, for example, I have client 1, and you have the client is acquired, which is some business event that occurred. The client is relocated. The new contact as a new contact person added, and for example, the delivery address is corrected. So we now can, based upon these differences and the payload or the data that belongs to those events, we can now build up the latest state for each of the clients. So you could have another client which basically has the same. So event sourcing is storing all the relevant business events that occur in your system in storage, in ordered storage. And to do this, an event is something that happens. So you also always name them in past tense, because if you name them differently, you might, it makes it simply easier to name them in past tense. And event streams should be append only, which is a very strange thing if you're used to just updating things in a SQL database, which is mutable. But we will cover this later as well. It's something to get used to, but once you're used to it, it works very well because it makes things a lot simpler. Because you can now simply say all the events or the state it has at version X or order number X will always stay the same. So you can do things based upon that. And it helps if you do event sourcing to keep those streams very short. If you have very large streams, and you would, for example, have 2 million events, then each time you would like to build up that state again, you need to go over all those 2 million events. So there are ways to keep those short but you basically need to think about that yourself. And events should be fine-grained. You don't want a event that is a customer is acquired and the account is opened and we gave him €5, for example. So you want those as separate events and not as one big event, because if you do that, you will probably run into issues later on. And event streams are for a single entity. So the transactional boundary, or if you want to do a transaction, should be within that event stream. So if it's a client, the transaction can go around that client. If it's a project, it's the same basically. So you have a given entity, and all the things you do to that, or the validations you want to do, need to be regarding that entity. So event sourcing is in terms of CQRS mostly in your comment model. And you don't need CQRS to do event sourcing, but it helps. It helps to basically get familiar with the pattern. So let's say we have this very large stream, which we just talked about. And we have a stream now of more than 5,000 events. So if you need to go over all those events and apply them each time to get the latest state, because that's basically what you do with event sourcing, because we have all those events, we do basically a for each loop over them and apply the state to the latest state to get the actual state currently. This can take quite some time. So what you can do is use a snapshot, which will basically say at point 5060, for example, in this case, we make a snapshot, which is the state of the data at that moment in time. Because we know nothing before this event, none of those events will change because we use append only. So if there is something wrong with the data, we do a correcting action after, which we append to the end of the stream. We can now safely say that we take this snapshot and we apply the other two events on top of that, which makes the stream fast again, because you now only need to do a for each loop over two things. Now, this works great, but there are also other ways to basically improve the performance or to reduce the amount of events you have within one of those streams. Because if you have 1,000 events, you can pretty quickly build up that event again. That's not taking long. But if you have 2 million, then it's taking long again. Or it's taking a lot of time to do it. So another way you can look into optimizing the performance is by what they do in accounting called close to books. So at the end of the year, they basically, what an accountant does is they write down a logbook basically of all the transactions. And at the end of the year, they say, okay, I'm now closing down the books, and this is the book for the next year. And we can do the same thing with our event stream, basically. So if we, for example, have this stream, and at some point in time we say, okay, this was, for example, a project, and that project runs in periods of years. So we can now say, okay, this is the end of the year. We close down the stream, or we terminate the stream. We create a new stream with the state at event 1000. We point it to that new state, and we start using that stream. And this also allows you to, for example, if you have events over multiple years, you can now simply say, if I, at some point in time, have old events with, for example, a different scheme, and I have new events, you could also do the same trick to basically, if you need to access the old data, then you need to have that scheme and something that responds to that. But if you want to basically clean up your code again, you can now use all the events used in this part, which are all new events. And again, this helps you out to have a small stream again. And another thing you could do is now with the terminated stream, you could also store it on even cheaper storage. So for example, cold storage, or because you probably would not be accessing that much anymore. So in this command model, or in this side of the event sourcing, we can also do refactorings. So what could occur is, for example, that you have a scheme that isn't really perfect, and you made an error, or you discover, for example, that you have very fine-grained events, but at a later moment in time, it doesn't make sense to have them so small, and you would like to collapse them up again to a little bit of a bigger event, or the other way around. So how you would do that is called a copy transform. So you have this ordered set of events again. You would basically start a process that copies them over. So we would copy the first event to a new stream on the first event. Then we would copy, or for example, in this case, we would introduce a new event, but because somewhere in the business we defined that this is what actually is occurring. And then you would copy over the rest of them. And at some point in time, you say, okay, this stream is now closed, and you move over the active stream to the new one. So now everything is appended on that stream again. But you still have access to the old data, so you never delete something. So if something goes wrong, you can always go back. Sure, you need to figure out what to do with the events you appended after you gotten into the new bad or incorrect state potentially. But you can go back and forth, or you never lose any data. CQRS. So CQRS is basically a way to separate your reading or your query side and your command side. There's no relation at all to event sourcing. Event sourcing can be done without CQRS, but it helps a lot if you do the two together. So in the command model, you basically have all the commands you execute, so everything you write to the database. And if you do something on that side, and on that command side, you would also do your validation on that command side. So you read data there, but only to validate if your command is actually correct. On the query side, you make basically optimized views for querying the data. So that could be the case that you have, for example, a list somewhere, which is stored in Azure Cognitive Search or somewhere else, which allows you to optimize it for that specific use case. And you can make another store which is optimized for just opening up your events. So you can have multiple of those. Because you do this, it becomes important again. It becomes important again to basically always be in the mindset that you only append events. You don't want to go in and change an event, because you now have on the command side data which you modified, but it also needs to be applied on the read model side. So let's say, to do this, you would use notifications. And as we've seen, Azure Event Grid is a great system to use those notifications, because you can simply create a topic and create subscriptions and like using, you can basically create subscriptions to basically hook things up to things and create projections based upon, hey, a new event is added to a certain stream. So event sourcing mostly is always on the command model side. On the read model side are your projections, which are basically made for reading your data. Now, if people have, I've seen a lot of articles about event sourcing, it's not usable. Most of the people that have problems with that are on the read model side, because over there you do things more or less, but which are closer to event streaming, which is basically how can I work around not have always being in the same transaction, but receiving events a little bit later and windowing them up or blueprinting them or watermarking them to basically get into that state. So event sourcing is very simple if you still keep thinking back to each time, keep thinking back to it's just ordered storage. So the append only thing is very nice and simplifies a lot of things. But can we really never delete anything? Because if we use, for example, GDPR, then we need to delete personal data. So what happens then is, what you can do with personal data is, for example, store it in a separate stream. So you would have two of those streams, one which contains business logic events or events related to the business, and one which contains that personal data. And when the request comes in to delete the personal data of a specific person, you simply throw away that specific store. So you append on the other store or on the original store, you append, okay, this is the request that happened, so that the system knows again, okay, I need to now update my projections because there's also personal data in those. Another option what that is used is to encrypt personal data. So each set of personal data gets a separate encryption key, and upon the request, you simply throw away the encryption key. So now you need to deal with that, basically. So if you can't decrypt it, you need to set it to empty or anything you find reasonable to use or what is clear. Another option is to simply say, okay, I use that same copy transform option, and we make the business decision to simply delete that terminated state. And that's a risk, but you can still do it. The only thing is then you need to deal with that no notification will be sent out around this. So that easy system we've created by just appending events now becomes complex because you're doing things that you're not supposed to do. So just deleting data breaks something in that notification system and makes it hard to get back that simplicity of the overall system. So that's why you also never want to fix a bug by just going into your event store, changing a number around, which is what you would probably do if you would be in a SQL database, for example. What you really want to do is add that correcting action, because that correcting action will cause a notification, and that notification can be processed again by all your systems. And you keep, back in time, you keep a record of that thing actually occurred. So you can later on see and do detection based upon how often does this specific thing happen? Do we need to do something about this? If, for example, if it is a sort of a bug or something. Okay, projections itself, how they work is, we already covered it a little bit. You basically have this stream of events. You have this stream of events, and as soon as something happens, you basically throw a notification. Something updated for this specific customer or for this specific client in their stream. A thing, which could very well be your Azure function, would say, okay, now I'm going to update a projection. So the projection is the view model we use to show to the customer. What it could do is go back to the event store and basically get the latest state and use that, because then you can work around a little bit if you have systems that do once or more delivery, so you always get the right state and don't apply things double. And then it would simply make those views needed. So in this case, I would have a view, for example, to email contact people. And I would have another view, which I would use to, for example, send them a package. And those could be stored on different locations. They could be stored in the same location. You could basically model that towards what's useful. This also means if you introduce, for example, a new feature or change around the data set, you can try that out now, because you can now build a projection, which is the first version, and build a projection, which is the second version. And you can basically see how it works and experience how it works, which is a lot harder in a database where we only have the latest state. And then you need to create a separate table, and now it all fits easier within the overall way of working. So one thing you will get into as soon as we start talking about projections, something happens, because there is time between when you actually save something in your event stream and when you have the projection done. And most of the times this ends up in being, we think of it in it's either strongly consistent, which is what our SQL database, we believed our SQL database was, or it's eventually consistent, which is basically it will happen somewhere, sometime in the future, which is very scary, because if you want to, for example, let someone add a project and then send them back to a list of projects, and that list is your projection, then it might be that that item is not, that was just created, is not yet in that list. But the real thing is that there are actually 30 or so different models of consistency, which mostly don't get mentioned. And there's a great article which is not about event sourcing, but about data replication in Azure Storage, I believe, from Microsoft Research, which basically explains these 5 consistency models in terms of a baseball game, and explains why not every stakeholder within that game actually needs to always know the latest score. I would encourage you to read the article. I'm going to go over this quickly here. So, for example, if you were to read all my rights, which helps out by this basically this project overview. So I am the one that created the project, And what I do is on the client side, I cache that and I show it back again when I load the projection. So it's not in the projection, but I show it for the user. So they don't notice or recognize any difference. So I now have a consistency that's somewhat okay, because it doesn't matter that someone else is seeing it. The performance is also somewhat okay, because I don't need to basically create this transaction to basically lock everything, to get everything done and release it again. So there are very many different ways to think about this. Now, and there are a few other things I would like to cover, which I'm going to try to cover a little bit quickly. If you do event sourcing, it's most of the work is not so much in what you do as a developer. Most of the work is discovering how we call those events. So it's more than important. It's not the developer that tells you that basically makes up names for events. It's the business user that defines those names, or the domain expert. So if you have a developer that is a domain expert, then that might work. But it's not a game of we're just figuring this out and we just throw some names. And you really need to go with your business users or with your domain experts into sessions. And there are different ways of doing this. You could do event modeling, event storming, domain storytelling. There are a lot of different ways for this. I encourage you to Google them and look at them. What I did here is give you a quick example of event storming, of how that would relate to what we've just been talking about. So what you would do is you would hang a big piece of white paper on the wall, and you would ask the domain expert to basically place yellow or orange Post-its on the wall with things that occur at certain moments in time. And you do that based upon a timeline. The next step you do is ask them, okay, is this event occurring because something else occurred, or is this based upon someone taking an action? So in this case, we have a shopping cart on a website, for example, and an item is added to the cart. The action for that is add item to cart. And the next step you can do is say, okay, this action is done by a customer. So you would have your command now. And the next step that would go into this is say, okay, what do they need to make this decision to basically execute this command? And I know this is not exactly what event sourcing says, but this is the simple down version for me to explain this. And what you would see here, the orange Post-it is what you store in your event store. The blue Post-it is basically the method you would have on a domain object, for example. And the green Post-it gives you an overview of basically the projection you need to make. Which data do you need to collect? So that helps you out a lot to have those things and to do those discussions up front. And you can basically also give this to your design team, UX designer, UI designer, and give this to your UX and UI designer. And this will give them a lot of information, so they can now build up a screen and an interaction based upon this information. And what you will mostly get then, or what's most likely to happen, is that you will get a task-based UI and not a CRUD-based UI, because those events work best, or this whole structure works best with a task-based UI, which basically is you need to perform a certain task, and this is the way you can do it. Because we can, so let's say, for example, in this case, this is my CRUD interface. I can basically modify anything I want. So I could basically set the status to deactivated and skip adding a comment. Or I could change the amount. I could correct the name to something completely different. If we look at a task-based UI, that is way more directed at which task are you performing. So for example, I want to deactivate a given inventory item. And this is the comment, and the comment is now required. And what do you want to do with it? But how do you want to deactivate it? Which is something we're all missing in the CRUD-based UI, which could be added in the comments. But we don't really know or have that data available anymore. It makes us we basically lose a certain amount of data. So if you do this, you basically give them Excel and let them program in Excel, because Excel is the biggest programming languages for business users, because that's where they can do everything they want. But you don't really know what they do. They could make mistakes or discover that they could do a couple of things which break the system or which you didn't intend to happen. And with the task-based UI, you give them an easier way to do it, and it's more controllable. You now record more data. So we can now see how often did we deactivate an item and did we destroy it? Or how often did we sell it to a liquidator? And we have now important information or business value, which we can use to make decisions upon. Okay, let's try to see if we can quickly go through the code. So this is still very experimental, and to give you a little bit of an idea what's happening is what I do is I create a blob file, and I use this blob file basically to store that number, because you can't, there is no auto increment number in table storage. So I use this blob file to store some data about my object. So for example, what the active stream is, how I can look that up in table storage. And what I can do on that blob file is basically lock it. So, or create a transaction around. So I could do an optimistic transaction, which allows me to basically, I could say, okay, give me the E tag of this object, which stands for, okay, this is the version number basically of that blob file. And I, for example, if I need to write two events to the database, I would say event active stream version +2 and try to write it back again. But only if the E tag is still similar or still the same. So if someone else comes in and does it before me, I could throw an exception. And this allows me to basically make sure I can have an auto number. And there are some other things in this. So for example, the terminated streams, which you can still access if you need to go way back in time. And I've played around with creating the snapshot, but because in most cases, if you do something in your comment model and you, for example, need to verify another entity, then you most likely always want the latest state, or in maybe 80% of the cases. So if we store the snapshot there, then we can basically access the data by only loading the blob file. If that's not the case, what it would do then is basically take the active stream identifier and query all the data in table storage. And in table storage, the active stream identifier is the partition key, which is the way you would partition data in table storage. And next to that, there is a row key, which is also a mandatory value for inserting records into table storage. And this row key is basically the version number of the stream. Next to that, I store basically the payload, which is the data string in this case, the name of the event, which I need to convert it back again to an object, and I store when it occurred. So to make this useful for myself and to actually share this code, I started building an NPM package to basically do this all, and sharing that code so people could see how it worked. And the funny thing is that we've been doing this for a long time, and someone else that's in the Azure Discord channel, I believe his name is Duncan Jones. He did exactly the same thing as I was doing, only in a little bit of a different way. But at least it showed me that I was not the only crazy person trying to do these kind of things in this way, which was fun for me, and also good to see, learn from what he discovered. So it's a simple package that you can install, and in Azure Functions, you can basically add a startup method to add additional custom bindings, or add, for example, the dependency injection you would also do here. Yeah, it still works. So how would we now use this? So the first thing I did, or the first version of it I had, was basically, so this is an Azure function. It's basically a HTTP trigger. So as soon as it receives a post message, client created, I can now say, okay, this is the event stream I want. I want this name, which is the client stream, and I want this ID. In this case, I use email. Don't ever do this, because you should not store unencrypted data, unencrypted personal data. But it is to make a point later on. So what I now basically get is the stream, and I can simply tell this stream, I would like to create a session. So that will basically get that blob file and make sure make sure I can do a certain somewhat of a transaction. I will basically say, okay, append these events to the stream. I would like you to constrain them based upon that they should not exist. So I create a client, and that client should not exist. And basically, this will do all the work for you to create a client. Then you probably want to give this client back to the HTTP, the caller. So you would say, okay, give me all the events, and you would basically build up your client object, walk over all the events in a for each loop, and return the client event again. Now, what happens here is that you get very large Azure functions because you start to do more and more of these things within your application or within your function itself. And let's go for the email address now. So what you would potentially want to do is only create a new client if that client doesn't exist yet. So if you can find somewhere within the object or the creational data something that's unique to that user or should be unique, and you use that as the ID, then you can now do that validation within your command model without trying to query everything to see if it exists, or having the need for a projection that contains all the email addresses and, for example, the client IDs to get back if this exists or not. Now, what you can do with the email address, I believe there is a paper from the government of Spain or their GDPR office, in which they look at when can you hash personal data and what's allowed there, which goes into those kind of things. So, for example, if it fits, you could, for example, hash the email address, which still allows you to do this pretty quickly without the need for a projection or something to do that check. Because again, everything you want to basically validate should be within your stream or within the boundaries of that object. Okay, so what is that event itself? So that's a simple class. In this case, client created with some simple data properties. And what you will see here, or let me first go over how this works. So it takes basically the client created class and will transform that in client.created. So that's the event name. You can also supply an additional attribute above it to basically specify the name yourself. Or if you, for example, have multiple versions of this event, if you add _1 or _2 behind it, it will automatically create a client created event and attach that to version 2. You can also do that again by using an attribute. So that's a little bit of the code within the system to make those things easier if you are in a case that you need to introduce a new version. What you will see here is that there is a personal data attribute. Now, this personal data attribute is just within my code, just an empty attribute. And what I allowed you to do within, or us to do within the system, is basically add actions upon points which occur within when something is, for example, stored or when you load something back. So in this case, we have a fake encrypt decrypt action, which is set up towards the event store. And that basically, before I append something to the store, I encrypt the data. And if I load it back again, then I decrypt it. In this case, it's simply doing the encryption by adding some encrypted string behind it. So it's not encryption, but it's for the sample purpose. So basically, with reflection, I go over the object. I see every property that has this personal data attribute, and I apply on top of those before I append them the encryption. And the same way is basically true for when I want to send out notifications to Event Grid. So I create a same action, which basically gives me my data object and the events that were appended. And now I can send a message out to an Event Grid topic and basically create a subscription towards the topic and, for example, update the projection. So this is the way you would do those notifications. And you can remove that, and it won't send a notification, so that's harder. But you could, for example, also say, okay, I don't like Event Grid, but I would like to just directly store things into queues, for example, storage queues. And what you need to do, we just ran over this, is that we had the default action factory, we had the builder.add event stream to basically let Azure Functions know. So store is in this case the connection string to the Azure storage, and I add these actions to every stream there is in the system. So this allows you to set that up, and you can also do that stream by stream if you would like to do that. Now, this was great, but it was still adding a lot of that code within the function. And if you do something more DDD-like, then you would probably like to have like a domain object or an aggregate, which basically deals with this. So I changed it around to be able to basically create this whole domain object for me. And now within my Azure function, I can do some logging or some things related to executing the function, but I could simply say, okay, object, this is the action, this is the command I want to perform. So in this case, correct the first name. What I can then do is I cut the code up a little bit to go to make it fit on the screen. So what I can then do is basically create this client class, add the properties, and basically the constructor, the only thing it needs is the event stream. And on that stream, I say, these are the events I'm expecting. I don't really like that, but that's what you need to do to basically transform the text client.created to the actual object. And then you implement a method with a switch statement, which simply does, which basically does very simple assignments. So if this, you go over all the events, or for each event, we call this method. And if I, for example, have a first name corrected event, then I would set the first name corrected. And it goes over all of this within that custom input binding and gives you back the latest state. And then you can still create within your methods, add data. So for example, this is the method correct first name, which uses the same thing we saw in the function, but now it's all within that object itself. So I can now also, from a console, run the same things. Projections I do them kind of in the same way, only then with a little bit of a different object, but the flow is basically the same. So in this case, I have some logic that basically allows me to save a JSON projection to blob storage, and the client projection in this case basically handles the new events and stores it again, or projects it when I call it. And yeah, so that's in short what I did. This is still very experimental. I'm still playing around with this, but I noticed this makes working with everything a lot easier. And that's roughly the whole session, and we're on the 46 minutes, so I think it's time for questions.
Yes, it is. Well, first, thank you for a great session. It was insightful. I really enjoyed it. So we have a lot of hi, Eric, and we have a lot of questions as well. All right, so using function as a kind of an interlanguage communication between processes, and they spoke specifically about Azure storage queue who signals to functions to process things. I'm not sure if that's a question, but maybe you have your intake on that, Eric.
I think that's maybe a comment around the possibility to basically have Azure functions and allow you to write certain parts in JavaScript, for example, and certain parts in C#, which allow you to take the language that fits best towards your problem. So if you have, for example, a problem that could be solved best by using R or Python, you can now do it in that way without having without the need to find basically a library that's transformed to C# to do your thing. The only downside currently is that you need to create 2 separate function apps for that. So you can't mix and match those functions in one app. But I hope the Azure Functions team finds some way to combine that. That would make me really happy.
Mm-hmm. Great input. Another question. If you change the data format midstream, how do you access that if you want to? And would you need to deploy your old code somewhere, or you can store it on Azure? I'm not sure what midstream means, but maybe if you start writing and then when you need to attend to a new data format. Surprisingly, I guess.
Yeah, so there's one thing we didn't cover. There's also something called which I don't know, can't remember the name for now. But what you basically do then is you can create a. Sorry, I know it again. It's called an upcaster. So what you can do, for example, if you have 2 types of an old event and a new event, what you can do within your system is build an upcaster that would basically, let's say that the structure of your schema changed. You create an upcaster that would basically take the old event or the older version and cast that to the new version. So all your basically code would work as if, because it only understands the latest version. And you can now slowly either keep that in and leave the event there, or at some point you could say, for example, okay, this is really not what I like, and I decided, and the business is okay with it, to replace those events. So then you can do the copy transform again, so the action to copy over all the events into a new stream and fix them all in there. And if you basically separate out, so use those closing book things, then you can also say, okay, for 2001, all those events I had back then, I have this set of handlers for them, basically. So this is how I process them. But because you don't have them in the newer streams anymore, you don't need to keep that code around. You only need that code when you need to go that far back in time. But because you have basically the starting point is 2020 and all the things that happened since then, and that's basically for most cases the most important, then you can basically deal with it that way. But it is a challenge to work with those.
Mm-hmm.
I'm not sure if that answers the question, but
Yes, absolutely. Because they spoke about how do you maintain the old code and how do you maintain support for the old version now that you have a new version, a new schema for your data. So another questions on that. Interesting scenario. Seems that you need to stay backward compatible or make breaking changes on snapshot applications. How do you maintain it? Do you need to be backward compatible, or do you do you delete or break the changes on the snapshot?
Well, the snapshot is just to improve your performance. So you only want to apply that if you have performance issues is if it takes too long to basically build up the current state again. It really depends upon so if you would have changes within your current events, and for example the schema changes, which is more or less the event didn't change, the thing still occurred, and the data on the thing is still the same. But let's say there's a typo within the schema somehow that came into the system. You can either choose to create one of those upcasters and deal with it that way, or you could say, yeah, I really don't like it and I would like to keep my code clean. I now make the decision to simply take those bad events out and basically fix them in there. And then deal with, okay, how am I now going to get those notifications out about those changes? If that's actually the case, because if you have something that's named incorrectly, then your projections might still work. So what you do then again to do that in production is you copy over all the events into a new stream. You keep the old stream because you never want to lose that, basically. And you do the correction there. And at some point in time, you say, okay, now this is the new active one. And from now on, we're using this one. I'm not sure if that's clear, but
Yes, absolutely. That's clear. And it answers actually your question, your answer answered a lot of other questions here in the chat. So that's brilliant. There was some comment on destroying an encryption key to delete the PII, because you mentioned GDPR in the beginning, where it's easy to append data, but it's hard to delete it, especially when we talk about different level of consistency and also ingesting the data to the system. So what is your take on destroying an encryption key if that happens?
I
think it might be a very specific scenario, so maybe you can.
In terms of GDPR, basically, that is what you see. Most people do this, and you simply need to deal with that case then. And I'm not sure. I'm not a lawyer, but I think that's somewhat accepted for GDPR as far as I know, to do basically that trick. What I like is just having the separate storing the personal data somewhere else and having that reference. The only downside is that each time you need to build up everything, you need to basically connect to that external thing or that other location and get the data there each time. But that allows you to basically, if you throw away that data and you are allowed legally to, for example, still know that people changed their name. And if the product owner then, for example, at some point in time asks, okay, we have this change name feature. Do we need to spend money to improve that? Then you can go back in time and still see, okay, it was used like 1,000 times or something. So I like that one in terms of I'm not feeling that comfort. I'm not feeling that much comfort into having these encrypted strings everywhere. But that's just my personal feeling. Not so much what you should or shouldn't do. I mean, you can also delete those events again if that's your decision. But you need to deal with what occurs then, and it's a lot harder to deal with those than to simply say, okay, whatever happens, everything that happens is always appended. That's way easier to manage, basically.
Yeah.
Awesome.
Yeah. Right. Thank you, Eric.
Yeah. So there are still more questions. So I would actually advise if you can go to the Discord chat. Like there are still some questions there. So if you can answer them there.
Yeah. I will.
Over here we are going to say goodbye to you because we have the next speaker lined up. So thank you very much for your session. It was really interesting. Like I learned a lot about event sourcing, and I knew about the concept, but this actually made it like much more clear for me. How does this work, and how can you actually implement this? So thank you so much for that. Enjoy your day, and thank you for being here.
Awesome. Thank you for hosting and having me.
Thank you. Bye-bye.
Bye.
Thanks.
So next up, we have Barbara Forbes. So welcome, Barbara.
Hi.
How are
Hi.
you doing?
I'm fine. You?
Yeah, doing really good. Having a great day so far. So
Hi, Barbara.
Hi.
So you're going to talk about Azure DevOps pipeline versus GitHub Actions. So that will be quite
Yes.
interesting because that's a discussion that has been going on for quite a while. What are we going to do? What is going on with Azure DevOps and GitHub? Do we all need to switch over now, or are we going to continue? So what is your feeling on this?
Well, I gave myself a challenge. I'm not sure if I can make it to do this as objectively as possible. And so I want to give the facts and then people can decide for themselves. But I'm not sure if that's gonna work because somehow there's always emotions involved here. So I'm gonna try to do it objectively and see how far I can come.
Awesome.
Great.
Yeah, so can you share your screen? Then I would,
Yeah.
and then you can talk all about what you are running into, what are the differences, what's actually the same, because I know there's also many similarities. So
Yeah.
it will be very interesting to see what your take is on this.
Yeah. And while you're sharing, I'm going to run a poll in the Discord chat so people can comment there as well and ask you all great questions.
Awesome.
Okay.
So good luck on your session and looking forward to it.
Okay, thank you. Let me just fix this screen to what I want to have. Yes, there we go. So as we said, we're going to talk today about deploying to Azure and whether you could use Azure DevOps pipelines or GitHub Actions. How do they compare and what are the differences? Before I get started, let me introduce myself real quickly. My name is Barbara Forbes, and I am an Azure MVP and an MCT. Live and work in the Netherlands, and I work as an IT consultant at SCCT. I write blog posts about Azure and automation at forbes.nl. I write one every 2 weeks, so you can find those there. And my Twitter handle is BA4BES, and that is also my GitHub handle. So with that out of the way, I just want to take one moment to thank our sponsors for making this event and all these sessions possible. Thank you for that. And let's dive right into it. So what we're going to talk about is the concept of having infrastructure as code and trying to get that to Azure. This is pretty broad, infrastructure as code, because it's everything that builds infrastructure and is code. So when you think infrastructure as code, you often think ARM templates or Terraform. But a PowerShell script can also be infrastructure as code, or an Azure CLI script, or something like that. That can be infrastructure as code because it's code that creates infrastructure. But what you also see a lot is that you want to deploy code directly into resources in Azure. So Azure Functions or web apps, for example. So what we've seen in the past is that we have used Azure DevOps a lot to make that possible. And what we see here in the diagram is that, let's say you have Azure DevOps or you have GitHub, you have code stored in there and you want to get it to Azure. We've got two services that can help you with that. And like I said, Azure DevOps has been a service that's been around for a while where you can create pipelines and connect to Azure. And then I think it was the end of 2019, GitHub Actions came around the corner, showed up its face, first in a very private preview, then in a less private preview, and finally available for everyone. And what they can both do is give you a CI/CD pipeline. And just to get the basics straight, what CI/CD is basically, in this case, so in this use case, CI/CD is a lot more of that. But when we use a pipeline, we have a set of tasks that we want to run on an agent. And an agent in this case is a virtual machine. And the set of tasks can be things that you want to do to accomplish your goal. So in this case, to deploy to Azure. That doesn't need to be the goal. You can also have the goal to deploy it to an on-prem service or just to compile a code or something like that. But it's a series of tasks that you would normally do manually. But with using pipelines, you are able to automate that whole process. So for example, if you update the code in the main branch, then that new code will be compiled or be deployed to Azure. So these are some examples of the tasks that you can find to run on an agent. That's, like I just said, Terraform or PowerShell or ARM template, but it can also be the code that you want to have in a function app or in a web service or something with containers or Kubernetes. There's a lot of possibilities that you can run in these pipelines. And the question I see a lot is, how do they compare? Azure DevOps versus GitHub Actions. They're pretty similar in some ways, but what are the differences and how are they the same and how are they not? And what I want to do in this talk is we're going to walk through creating a pipeline real quickly. And I just checked the time for 1 second because I see I forgot to set my timer. Okay. So what we're going to do is walk through it, first an Azure DevOps one and then a GitHub one. And then after that, we will walk through all the differences that we've seen while we were creating those pipelines. So these are the links I'm going to use. And let me just swap over to, is it this one? No. Let me just find the right window. This is the one. We're going to make use of a GitHub repository and a storage account ARM template that we want to deploy to Azure. So this is almost the same as the one that you can collect from the quick starts. And if you have seen if you have seen talks from me, you know I deploy a lot of storage accounts. Reason for that is storage accounts don't have a lot of parameters and they are quite quick to deploy, relatively very fast. So this is a basic ARM template in a GitHub repository. I'm going to use this GitHub repository as the base for both Azure DevOps as the GitHub Actions. So we start out with Azure DevOps, alphabetically the first, so it's only fair. And the first thing that I want to show you is that I have already created a connection to Azure. I used an SPN for that, the service principal. And you can create that yourself and connect it to Azure, or you can let Azure DevOps create one for you. I have not created it myself because this Azure DevOps environment is not in the same tenant as my Azure tenant. But there is a way to just do it with 2, 3 clicks of a button, if you would like that. So I've already created that, and I'll go to the pipelines. And here I can create a new pipeline. There's one also already here. That's in case the demo gods are against me and everything goes wrong, then I have some sort of backup. But let's create a new one. And when I choose create new pipeline, the first choice I get is to define where my code is stored. And this is one of the first things that you will not find in a GitHub Actions, which makes sense. GitHub Actions is attached to a GitHub repository. In Azure DevOps, you do have the option to connect to other Git repositories. So you have the Azure Repos Git, which is part of Azure DevOps itself, Bitbucket, other Gits. So there are a bit more options here. We're going to use that GitHub repository we just talked about. And we're going to select the first repository. That's the one that I just created. And I can now choose to have a starter pipeline or use a YAML file that I might already have. And I'm going to create a starter pipeline because we're going to get started from scratch. And here we see something that we will see in GitHub Actions as well. The pipelines are formed in YAML. And YAML is a bit love it or hate it. And there's not that many people I feel in my environment that actually love it. Especially if you come for an environment where indentation is not a thing. Then you can get a bit confused because here it matters how many spaces you have added at every place. So that takes some time to get used to. But once you get the hang of it, you should be fine. And there are some tools out there to help you, which we'll get to in a second. And the first thing we see is the trigger. So this defines when the pipeline will start running. In this case, it will start running as soon as something is deployed to the main branch. The code is changed in the main branch. And it asks to define a pool with a virtual machine image. And I'm going to use the hosted image that's provided by Microsoft. It's by default Ubuntu latest, which will work for me as well. And I am able to create my own pool image, if I want to have the agent running on my own VM, or I can use a Windows VM or a Mac VM. And underneath there are the steps, and these are basic Hello World steps, which we will not use in this case. We do not need them, so I'll delete those, and we're going to create the step that we actually need. Now, in a full pipeline, there would be some testing and maybe some configuration of the parameters and stuff like that, but we don't have that much time, so to keep it simple, we're just going to look into deploying that ARM template. And here I open up the assistant, and I really love this. It's going to help me create that ARM template. So I put ARM in the search bar and I get ARM template deployment. And here I can fill out all the details that are needed for this ARM template. And I can actually select my connection and select everything from the drop-down menu. And I can say I want to create or update a resource group. And I have a resource group for this one, which I'm going to use. And I set the location for West Europe because that's where the resource group is hanging out. And here I can set a template. By the way, if this is all going a bit fast, I do have to move a bit faster for the sake of time. If it's moving too fast, I've written some blog posts that go through this process step by step, so you can find them on my blog, which I will link in the end again. So here I can define where my ARM template is located. So it was in, it's wrong, storage account /Azure deploy.json. And the parameter file was storage account Azure deploy.parameters.json. JSON. And I have the option here to overwrite a parameter. And I'm going to use this because I want to see the difference between storage accounts that came from Azure or Azure DevOps and that came from GitHub Actions. So I can do that by overriding the storage account prefix, which is part of the storage account name. Because it needs to be unique, then the template will take this prefix and put a random string behind it. And I'll use the prefix as though, so I know this is from Azure DevOps. I can leave the deployment mode at incremental. I do not need the advanced ones. So I put my cursor in here and I click add, and it will create the YAML syntax for me. Really love this stuff. So I did not need to think about what that indentation is or what the syntax is. I could create it through that assistant. Now, of course, if I want to go further with this or I want to deploy more templates, I would work with this code, copy and paste it and fix it to fit my needs. But to get started with the first step, I think that assistant is really helpful. And if I want to change something, I can click settings here and the assistant will open again and I can work with it again. And this is pretty much all I need for this pipeline. So if I now click save and run, and I say save and run, commit directly to the main branch, and it will start running anyway because I commit something to the main branch and there's a trigger for that. So this will create that pipeline for me and that job will start in a second. It might take a bit longer because the example job is also running and I can only run one at one time. So what we'll do, we'll just leave this here to do its thing. And while we wait, we'll move on to GitHub Actions and see how we can create a pipeline over here. And I set the GitHub repository. This is the same GitHub repository that I used for the code we just showed. And I set it at the space where I would create the connection to Azure. This object is my connection to Azure. There are, in this is a JSON with some information about a service principal and about my tenant and a secret. And that is used to connect to Azure from here. There's a safe way to store it. As you see, I am not able to access it. I can update it, but I cannot see what the value of this is. So that makes it pretty secure. And I am able to use it in an action later. So let's do that. We'll move to actions over here in the menu. And I'm going to say I want to create a new workflow. Like before, there's a workflow over here already in case this goes wrong in one way or another. So over here, I get some templates that I can use to create a workflow for some different applications or use cases. But I'm going to go with set up this workflow, create a simple workflow. And what we see here is the first thing that I forgot to change in Azure DevOps, and I almost always forget to change here, is the name of the YAML file that you're gonna create. And I'll call this as deploy, and I can give a name to this workflow, which it will be shown in the web interface. It's called Azure Deploy. And the first thing we see is on, which stands for what will trigger that pipeline. So we're familiar with that. We've seen it already. Syntax is a bit different, but it does the same thing. In this case, it shows us this will start running when something is pushed to the main branch or a pull request is completed against the main branch. This one also shows workflow dispatch, which gives you the option to deploy the pipeline manually from the portal. Can be very handy, and it's not like that by default. As you can see, there's a lot of comments here that actually tell you what is going to happen. So this is pretty much what we already saw. And here we go to the jobs. And this is the name of the job we're going to run. We're going to only run one job, but you can have multiple of them, as you can have in Azure DevOps. We'll call this deploy because we're not building anything. We're just deploying. And here we see runs on. And we saw that just in Azure DevOps. It's Ubuntu latest. I'm pretty sure they're like the same agent. They're a lot alike. And here I can define the agent that I want to run on. So for this one, I'm going to use Ubuntu as well. And here are the steps we saw before. Uses actions. So in this case, it does a checkout of the repository. The Azure DevOps one does that as well, but in the background. And here we see scripts that are very similar that we saw before, which are hello world steps. We're not going to use those for this one. So we do need to take an extra step for this one because we need to log in to Azure. It's not part of the ARM template step. So here we have the marketplace with all the actions that we can choose from. And this is huge. There's a lot of actions here. And what I can do is say Azure login. And it shows me the Azure login action. With these actions, it's important to know that anyone can put stuff into the marketplace. This is very open source. There's a lot of community input and a lot of great actions out there, but it does mean that you need to be a bit more critical on what does an action actually do and does it fit my needs. There's one handy thing though, and that's that you see here, for example, the Azure is creator verified by GitHub. So this is created by Azure itself. So we can assume it's going to be safe to connect with Azure with this without reading the code or looking any further. So it is handy that there are some blue check marks over here that we can use. And if I click Azure login, it tells me what this will do. It will authenticate to Azure for me. And what I do to install it is copy and paste the code into my YAML file. So I copied it here. And here I'm going to paste it. And you're going to see something that I find really bugging, but there's actually a quick fix. It's never in the right indentation straight away. And I spent quite some time tapping away with the space before I learned about this trick. That if you click Alt, so keep Alt selected, and you drag your mouse, you can drag out your cursor and you can move them all at the same time. And another handy thing here is indentation, or is the the highlighting here that I will just keep moving until that red swirly thing is gone. Now I know it's in the right place. So that makes it all a bit more easy. And of course, this is only if you're creating a new pipeline, because the next time you're deploying an ARM template, you can reuse this pipeline and change this to that factor. So here it tells me what I would need to put in there, which is really handy. And for the credentials, I'm going to use that credential object I created earlier. And I'm going to copy and paste it because this is not going to work for once. So with secrets, I can collect secrets that are connected to this repository, and the secrets was called Azure Creds. So now it will put those secrets within this, use them as the credentials. And for the Azure PowerShell, I'm just going to say true because I might need it later. And the other two are optional and not needed, so I'm going to delete those. After this, we're going to look for the step that will actually deploy the ARM template. And here you're going to see what I mean with that this is a free marketplace where everyone can contribute. And while that gives a lot of flexibility, it also adds this. As you can see here, I have two different tasks that are about the ARM template toolkit, so ARM TTK. And if I scroll a bit further, I actually have another one here. So those are three tasks that are created by the community. And from here, I cannot see which one would be the best to fit my needs. The good news is that they might be different and one might fit my needs better than the other one. But what I have to do if I, for example, want to use this one, I would go to the full marketplace listing, and here I can find information on what it actually does, and I can open the GitHub repository, see who created it, see if what the code actually is. So it's very transparent in that. But what it does do is require that you spend a bit more time when you're getting started with it to see what actually fit my needs the best, what is what I am looking for, and what what action is the one that I'm going to use. The good news, though, is that to deploy an Azure Resource Manager template, we have one that is verified by Azure. So we can assume this is the correct one next to that. I don't see any other ones. So that saves a bit of time. So I can just click this one and copy the text again, paste it to the pipeline, and then again, press Alt, select them all, and press space until the red wiggly thing is gone. There we go. So here it says uses this template. You are able to define if you want to use a certain commit. Because like I said, these are often from the community, so they can just commit something to the code, and maybe that's a breaking change and you didn't know about it and your pipeline fails. You can say you want to use a specific commit in here if you want to prevent that. Now, the first thing I need to set up here is the scope of the deployment, and in this comment, it tells me what my options are. So I want to deploy to a resource group, use that one. And I need to provide a subscription ID, which I will copy and paste again, because I do not know that by heart. And this one I do not need to use. It says here it's only required for management group deployments, so I can just delete this. I do not need to require the region, because it says here it's only for management group or subscription deployments. I do need to provide the name of the resource group, which I will copy and paste again, because at this point I'm getting lazy. And again, I can set the template path like I did before. So that's storage account / Azure deploy. The deployment mode, I want to use incremental. And the deployment name is optional. You do not have to create one. But here is one quick tip that I found out when testing. When you deploy something to an Azure DevOps pipeline, the deployment name will always have something that is connected to that pipeline, so some sort of ID. If you deploy from a GitHub action, in this case, the deployment is always called Azure or something like that, which means that if I run this one twice and I do not define that deployment name, it will look at the deployments and see one called Azure that's already there, and it will not deploy anything. So it is handy to define a deployment name that actually changes when each time this template runs. And what I did is I used GH, so I know it's from GitHub, and then a variable again, like we did in the Azure credentials, and in this case, GitHub.runID, which will give the ID of this specific run, so that each deployment has a unique name. And then the last one is the parameters. And what I can do here is I can define a parameter file. So like this. But I am also able to define, to override one of the parameters like I did in Azure DevOps. I can just add it behind it. So this way I have both of the best of both worlds in one template. So this should be enough to start a commit and to deploy an ARM template. I'm going to commit directly to the main branch again, which you should never do, but this is a demo, it's fine. And this is a bit counterintuitive for me. It just goes back to the folder where the workflows are stored. But at this point, that action is already running because I commit to main. So if I move to actions here, I see that it's already running. Well, there's two of them running because I had the backup one running. And I will take the first one that started. And here it's going to start that workflow in a second. So we have set up that deployment now. And while we're waiting for that, let's just move back here, and the demo worked. So that's good. It does a checkout and it has deployed the ARM template from here. And here I would expect it to start running already. I'm just going to see if the other one's running. No, they're both queued. And what it will do in the end, just wait till one of them is running, it will deploy to this resource group where it will start deploying. It went from 1 to 30, so I had this open for a while. And did I mention already that I deploy a lot of storage accounts? So a lot of options every time this pipeline runs, and there's now 4 pipelines running with every commit to main. There will be 4 storage accounts created. And here you can see what I saw with the set with the deployments, that the GitHub now has an ID behind it. And before it was just an Azure deploy. So let's see if it's running now, and they're both running at the same time. That's not very kind of good for the speed. But as you see, kind of familiar. It's just a bit different. It does a login and then it starts deploying everything. And we have now deployed the storage account, basically. So let's move back to some of the elements that we just saw. We saw that both of those pipelines are in YAML, in YAML language. And they had some options that are pretty similar, but have a different name, just so you know on what platform you're actually working, I guess. Now, something that I wanted to test was how quickly those pipelines run. Is there a difference in speed between the two of them? So I ran a bunch of storage accounts, and I did them together at the same commit, and I did a few of them separately from each other to see if they do not influence each other. And this was pretty consistent that the speed of the Azure DevOps pipeline was between 44 and 54 or 55 seconds, while the GitHub one was between 1 minute 9, 1 minute 20, something like that. It was pretty consistent in speed. And I saw that the GitHub one was consistently running a bit longer. But then I looked at, while I had 5 of them running on both sides, so that's 10 storage account in total, I looked at the Azure portal to see what was there. And I found this. I found that it had only deployed 2 Azure storage accounts in the time that it had deployed 5 accounts from GitHub. And that's when I realized that this timer starts when the agent is ready. So it queues the job for an agent, and then it starts when it actually starts running, then the timer starts. So I guess it took a bit longer for the agents in Azure DevOps to be ready to start the job. Now, this is a very small test. As you see, 45 seconds, that's nothing. And the storage account is very small. And I wouldn't have tested this often if it was not. But there are pipelines that are running for like an hour. And then it doesn't matter if it takes a bit longer to queue. So, well, an hour is pretty long, by the way. But half an hour is not unrealistic. That can happen. So I think it's not that much of a difference in the speed. I think it's neglectable to say it like that, but I must say I have not tested this with very long running pipelines. Now, if we look at all the elements that are part of this pipeline, or at least some of them, first thing we have is the agent that the pipeline is running on. Both Azure DevOps and GitHub Actions provide you with agents for Linux, Mac, and Windows OS. And in both, you are able to create your own agents. So you have a virtual machine, you install an agent on there, and you can run the pipeline on there. This can be very handy if you need very specific software for your pipeline to run. So you do not need to install that every time. Or if you want to have a bit more control on that pipeline, or if it's running on-prem, for example, if that agent needs to deploy something to on-prem, then you can have an on-prem a device that is connected with an on-premise environment and run the agent there. So this can be very handy if the hosted agents don't fill your needs. It's not that difficult. It's pretty simple to install an agent, and I installed in Azure in GitHub Actions. They call it a runner, and I started installing it just for testing for this talk. And I might be wrong, but I think they have the exact same installation file. The configuration is a bit different because in Azure DevOps, you have projects to think of and organization names, while in GitHub Actions, it's connected directly to the specific repository. And this is also a difference to take into consideration, that agent in GitHub Action, you configure it for a specific repository, while in Azure DevOps, you can create an agent that's available to multiple repositories or multiple projects. Then again, you can easily install multiple agents on one virtual machine. So you can work around that as well. The configuration was a bit easier on the GitHub Action side, but these two are very similar in what they can do and how they work. Now, the tasks that we talked about, these are quite a bit different in the way of working. In Azure DevOps, you get a set of default tasks, and you can get a very long way with just that default tasks. But that also means that it's a bit more of a threshold to start using custom tasks. And there are a lot of available for that. There is the marketplace for Azure DevOps, and you can install extensions there, which you can use in pipelines. And you see the front page here, you have Sonar Cloud or Terraform, for example, which you can use in your pipeline. So it's a bit of a larger threshold. It does need to be installed for the complete organization, so not everyone can install those custom tasks. But what is interesting on the Azure DevOps side is that you are able to create your own task and only make it available for certain organizations. That's an interesting one. And if we look at GitHub Actions, it's more open. When you start looking for actions, you get the whole deal. It's not like you need to install something separately. No, everything is available for you. This gives a large freedom and a great way to have something that's almost customized for your needs, because there are so many different actions available. But it also means that you need to take a bit more time to find your way around the actions and find the action that works for you and that is properly maintained and stuff like that. So a bit of a difference here, and it's really about what fits your needs the best. We just saw how you can connect to Azure. They both work with a service principal. You are able to use a managed identity in Azure DevOps if that fits your needs better. Then you are able to use it, and I'm not actually sure if you can do that in GitHub Actions. But for both, it says that you can use the credentials for a service principal and use that to connect to Azure. And again, with Azure DevOps, this is connected to a project. So you can use that service principal for multiple projects, while in GitHub Actions, it is connected to this one repository, which for security is debatable. Which one is the best? Again, what fits your needs? So in both of them, you can work with variables in your pipeline. You can set them at the top of your connection file. So you see here in Azure DevOps, it's called variables, and in GitHub Actions, it's called env, for environment variables. In Azure DevOps, you are able to set variables that are connected to that pipeline run, and you can change them at the run step without changing the code, which is pretty nice, and I haven't found that yet in GitHub Actions. You can work with secrets in both cases. So in Azure DevOps, you can create a new variable and define that you want to keep it a secret. And in GitHub Actions, you can set secrets for the repository. In both cases, of course, the better way is to make use of Key Vault in Azure. And in both cases, you are able to have a step that collects the secret that you need from Azure, as long as that service principal has the permissions to use that Key Vault. And then there's enterprise integration. And this is a bit tricky in the sense, it's a bit tricky to stay objective in this one, because I think Azure DevOps is more prepared at this point in time to connect with your enterprise. If you are running in Azure, this is assuming that you're running with an Azure AD. It's basically connected all throughout. There's even Azure AD role assignments that give you permissions to do stuff in Azure DevOps. So it's very flexible, very a lot easier to set up. Even the billing can be done through Azure. So that connection is pretty clear that Azure DevOps is more prepared for that at this point in time. What you see in GitHub, if you have GitHub Enterprise, you are able to create SAML authentication. So you can create a single sign-on from your Azure AD or other identity providers and log in like that. So it is possible, but you do need to use GitHub Enterprise, which, let's face it, you're basically, if you're using Azure DevOps, you're also using an enterprise version, to say it like that. So you are able to set up a SAML authentication. I have not been able to test that yet, but I think it's safe to say that in Azure DevOps, it's already completely integrated. So, yeah. And then I want to consider the costs. And let's consider you want to get started with Azure DevOps or with GitHub Actions. It's completely free to use. You can use Azure DevOps with a personal Microsoft account or with a GitHub account, and you can use a GitHub free account. And for both, you get free minutes of running. So in Azure DevOps, you can get 1,800 minutes in a month to run on CI/CD. And with GitHub Actions, you get 2,000 minutes in the free version. And those minutes go a long way, especially if you're using it for deployment cycles, which in most cases aren't that long. I have never had any issues with running into that limit before. So I think you should be fine for a long time, even with that limit. And it gives you a lot of room to play around with it. The license model is a bit different in Azure DevOps. It's based on the organization, while in GitHub, it's based on the account of the user, especially with the free and the pro version. You see that stuff. So there's nothing stopping you, if you worry about cost, from trying out both of them. So I think this was a pretty objective overview. And there's one conclusion to this that I think is really important. That is, if you know one of these technologies, you can get into the other one in a relatively small time because they're so similar. This means that you can broaden your horizon without too much effort, which I think is really great. I think I'm like most of people. I started out with Azure DevOps, and then GitHub Actions started existing. And I started working with GitHub Actions, and it felt comfortable very quickly and like something you can work with very quickly. So I think it's great that these products are so much alike that you can start working with both of them and master them both. If you master one of them, it's not that much effort to master the other one. I think that's a great thing. And they both do have their charms on where you can use them. I think it's a lot dependent on your use case, what works best for you, and specifically the tasks and how you can collect those tasks are very specific. How you can create these tasks even, it seems all a bit better documented and a bit low threshold on the GitHub Actions side, which you can see in the marketplace. It has grown very quickly in the time that GitHub Actions are a thing. Where it's a bit more constricted in Azure DevOps, where you can get a long way with just the standard task. It's a bit more work to make use of custom tasks, either created by you or created by someone else. A bit more secure maybe, and a bit more focused on an enterprise where you do not want every user to be able to run just about anything, to say it like that. So maybe Azure DevOps finds its place more in an enterprise environment where GitHub Actions have such a close connection with GitHub. So if you have a GitHub repository, this means that your actions are really close to that GitHub code. So that's also a very nice thing. If you have a repository, then the actions are really a part of your code. Where in Azure DevOps, the pipelines can feel like a separate place, especially if the code is stored in another place. So these are all things to consider, things to think about. I can't give you the answer which one is best. I simply can't. It really depends on your use case. But my recommendation is, without a doubt, if you work with one of them, try the other one, because I think it's a great opportunity to learn about both of them. So that's basically it. And what I want to recommend is, if something went too fast or you want to have a step-by-step guide on deploying to Azure DevOps or deploying to GitHub, go to my blog at forbes.nl, and I have posts step-by-step guides on both of these things, so you can look through them and get a real feeling with it and start your own journey. And I will make this repository available somewhere in this weekend. It's still private now, so I will add the templates and make this available somewhere this weekend. And my GitHub handle and Twitter handle is BA4VES, and you can find it there. So that's it for me, and I want to say thank you for listening.
Thank you, Barbara. It was fantastic. So we do have questions from the audience. I hope you're ready.
Yeah.
Awesome. So the first one is, are there any scenarios where there isn't a way to use GitHub Actions for a GitHub project, or the other way around?
A scenario where you are not able to use GitHub Actions.
For a GitHub project, so you had to use the DevOps pipelines.
I don't think there are scenarios where it's impossible to run GitHub Actions. The one use case you see a lot is that people are already using Azure DevOps, for example, for the boards. And then it's nice to have the pipeline connected there as well. But if your repository is in GitHub, then GitHub Actions can do anything one way or another that an Azure DevOps pipeline can do.
Cool. More questions. Is there a way in GitHub to have a private marketplace tasks?
I'm not sure, I have to say, because I was asking myself the same thing and I forgot to check. I expect them, if they're not available at this point, I expect them to become available. I don't think I've seen them yet.
All right. Cool. To the next question. So with GitHub Actions, do you install them like you do with DevOps? Or if you view something in your pipeline that refers to a task in their marketplace? Anyway, to simplify it. So you do not... Yeah.
Yeah, I think you mean like in Azure DevOps, you need to install the extension. Like you need to install the task from the marketplace into your organization. And in GitHub Actions, you do not need to do that. That marketplace that I just showed when I was creating those tasks, I didn't install anything on that. You get the complete marketplace in your search window every time you create a task. And it just provides you with the code that you use. So you do not need to install anything or have a previous action for it.
All right, cool. So does it automatically knows which one to use?
Yeah, there's the uses line in there. So there is a line, if you create a step, there's a line in there that defines which action it uses. And I suppose on the background, it refers to the repository that the action is in, because all the repositories that the actions are in are public. So you can see the code that's happening, which is great because that gives great transparency. But I would suppose that there's a line that defines the code for the task is in that repository.
Cool. Yeah, it makes sense. All right, and that's regarding prices and costs. Do you get unlimited minutes in GitHub if the project is public?
Yes, I think so. I'm just thinking, I know you get them in GitHub also. If you're researching both of them at one place, you're thinking which one was which, but they're both, if it's an open source project, so if it's public, you get unlimited minutes. And I think in Azure DevOps, there is a limit, like it's 10 projects or something like that, but you do get unlimited minutes.
All right, cool. We have some more questions. Oh, we did some poll in the Discord chat with thumbs up too, if you're using, which kind of CI/CD pipeline are you using? Are you interested to know which one? Right, so Azure DevOps got the highest voting for being used by the community. And Azure GitHub got some people mentioned that they're curious to learn more about GitHub Actions, especially after you mentioned that once you master one, you can easily go to the second one.
Yeah, I was actually surprised by that myself. I thought it would be confusing, but it's just enough difference to know which one you are doing. And you already know a bit of the syntax that's working. So it's If everyone remembers how hard it can be to get into the Azure DevOps pipeline when you first started, and if you then go to GitHub Actions, it's not that hard. Really, it saves a lot of time if you already know Azure DevOps.
Cool. We have another question. Does GitHub Actions support something like variables group?
Not that I have found. I have found just the environments which you can set in the pipeline.
Okay. Yeah, that's all for me. Elder, do you have more questions on your end?
So, question, and I think I'm not the only one that is looking for this, but how can we get started on GitHub Actions? So I see a lot of people that want to get started on GitHub Actions. Like I see people that want to go do this weekend. How can people get started with this to actually find how this works?
Well, one option is to go in there like I just did. So like you just saw, go to the Actions tab and see how far you can come. Because especially if you know Azure DevOps, then you will know what steps you need to take. So create a new workload and select those tasks. Yeah, and another method, but that's shamelessly promoting my own blog. I have a blog post and I can post it in the Discord later, which is step-by-step deploy an ARM template to GitHub Actions, which I will say, and that's how fast it is going right now. I wrote it, I think, somewhere in the last half year. And at that point, there wasn't yet an action to deploy an ARM template. I did it with PowerShell. Okay. So that's how fast the development is going, which is really cool because it feels like a living product.
Yes.
But I will link that step-by-step guide so you also know the hardest part about it is the credentials, the Azure credentials. Because you need to find the documentation on that.
By the way, what tips do you have for people who kind of struggle with YAML syntax?
Make use of that web interface. You want to start using Visual Studio Code probably, because that's a great tool if you're writing ARM templates. But that web interface in both Azure DevOps and GitHub Actions is really incredible because it tells you what you're doing wrong if it's not correct. It will tell you, well, here's a red wiggly line, this is what you did wrong. And you saw that assistant that you can use in Azure DevOps, where it basically creates it for you. And then you can use that to translate it to other steps. And I found that really helpful to start out with that YAML.
Wow, that's really cool. I see we have some more comments and people speak about the different pipeline versus actions versus workflow. Definitely.
Oh yeah. That's one thing I saw discussion on Twitter is the naming. Is it GitHub Actions or is it GitHub Workflow? I believe it's GitHub Actions because that's the marketing that GitHub is using for it. But GitHub Actions is basically a row of actions. But the file that I just created, the pipeline file, is called a workflow. So to make it all a bit confusing, that one file is a workflow. An action is one task that happens in the workflow. And GitHub Actions is the broader picture that GitHub made when they marketed this to the world. And I think GitHub Actions sounds a lot better than GitHub Workflow. So I keep using that.
And when you need to compare the workflow to the DevOps pipelines, what would be, are they the same or actions are more like pipelines? What do you think?
Yeah, workflow and actions are the same thing. The official name for the file that is the workflow is the workflow. So the pipeline file officially is called a workflow. But they're basically the same thing, potatoes.
So if someone is completely new to CI/CD on Azure, what do you think it's a good resource to learn from on the different scenarios that they can build?
Well, what I think is a good resource where I know they are working on some ARM templates and they're working on Azure DevOps. I don't think that GitHub Actions is in there, but if you go for what CI/CD is Microsoft Learn. And in Microsoft Learn, you have modules that are talking about specific subjects that you can learn about, and you get a bit of theory on it, and then often you get some sort of practice. So you can go to your Azure DevOps tenant and you can start trying things out. So they combine the theory and then the practice, and if you finish a module, you get points and you can level up and level down. You can use for Azure as well. It's really a fun way to learn about Azure. Very lively. It's not like reading a book where you have trouble with imagining what it will look like, because it will show you what it will look like. And that's also my advice. If you want to create your first pipelines, you don't really know what's going on. Next to knowing the theory, just go click through stuff. Go find out what it actually does. Be careful with, don't do this in your production tenant. You might make people very unhappy, but if you have like a free Azure tenant that you can use for this, go wild. Just try stuff out. Work with storage account because they barely cost any money. And just try stuff out. And if you're creating a pipeline, I think most people are still like me, even if you're pretty experienced with them, it will take about 20 tries if you have a complicated pipeline before it does what you are doing. And that's just the fun of the game, trying to find out how you can reach your goal.
Yes. Eldert,
Yeah,
did you capture any more questions that I might have missed?
No, so I think that were all the questions. So I would say thank you so much for the session. Like, very interesting. I think this made the picture quite a lot clearer. I also like how you, like you said, you tried to be objective about this. So I think you did a great job on that. Of course, there's always a bit of subjectivity, but I think you made, like you did measuring and stuff like that. So I think this will really help people. And I've seen in chat already, like a lot of people want to dive into GitHub Actions to see what it's all about, how does it work. So definitely a very good session.
Thank you.
So thank you for being here today. Enjoy the rest of your day, and I hope to see you soon.
Yeah, and just for the people, because I have some stuff coming up, I will go to the Discord, but it might take like an hour. But I will go to the Discord and see what everyone has said.
Thanks so much.
Thank you.
So next up, we have Mark Hayes. So welcome, Mark.
Hello, how are you doing?
Good. How about you?
Over here.
So your sound is a little bit low. I don't know if you can.
Is it better up here?
Yes.
Yes.
Oh. Very good. Sorry that this thing now was in my way, but anyway. So yeah, thanks for having me here, guys, and thanks for organising a conference. It's great. Brilliant.
Thank you for being here.
And
so,
might I say, I love the Lego behind you. That
Thank
Lego
you.
is all awesome.
It's only a small collection.
Oh my gosh. Well, I'm looking at what you've got, 80. No, you've got 80. You've got some interesting things there in the background as well. That's a lot of. Are they stress things you can squeeze behind you?
Yeah, some of them are. Some of them are just Funko Pops that I'm collecting for many years now. So it's only a small collection.
Yeah. Unfortunately, I have nothing to display other than a mess. Okay, but anyway.
So
you've got the important stuff.
Go ahead. So you are going to talk today about how we can migrate a data capture solution with Event Hubs and Stream Analytics. Now, myself, I'm a big fan of Event Hubs, so I'm looking forward to what you are doing with this. But can you already give like a little bit of introduction what you are going to show today?
Yeah, sure. You've made me nervous when you said you're a big fan of Event Hubs, because I like people who aren't. Okay, because then like I could just show you this. I mean, I have a confession to make. All right, what I'm showing you here is not a system I have in production. It is a system that I've had in kind of proof of concepts with a few places. And the reasons why they've gone ahead has never been to do with technology, more to be doing with the data and realizing they didn't need that solution, all right? But where it has its genesis actually is 9 years ago, I was approached by a company to basically create a streaming solution, okay? Except certainly at the time, there was no commercial offering that had been out there from a Microsoft point of view to do the streaming solution. So I ended up creating a streaming solution in SQL Server by just having integration services packages running really quickly, you know, and doing things and moving it around. Okay, and it was good. So then when Stream Analytics kind of came on board, it's part of the ongoing learning, right? You just like, we like to learn about technology, and it all struck me as, God, it would have been a lot easier to have fixed that problem with Stream Analytics. Okay, so one Friday night, I decide, hey, let's build a streaming solution and recreate that system, So which is what I did, and I says, yeah, that's pretty cool. It works. And to be honest, this talk has come out of that in various guises. It started off as a 5-minute kind of overview, and the next day I was doing it as a 20-minute session. And then I was like, well, I just might as well create a kind of a full session around it and kind of dug a little bit deeper into Stream Analytics and into the monitoring and the tuning and stuff. And from what I can gather, at least in Ireland, I haven't come across anyone using it in production. So I'm kind of going, well, I might as well just keep talking about it. So, right? Because clearly people still want to learn about it. And, whatever I know, if they pick up a few tips, great, But I don't want to really set myself up as you can never call yourself an expert if you don't have a production system in it, right? So it's kind of more a kind of high-level hobbyist, maybe, is how I would kind of position it.
I'm curious. I mean, how do you take SQL Server and build, a streaming system that has good latency? This is like I see it as like the main challenge is facing the latency and reducing the latency as much as possible.
Yeah, I mean, with great difficulty, basically, is your answer there, okay? It just depends. Look, it's going to be the usual IT consultant answer. It depends, all right? And for the latency, for my client, they didn't need latency down to the level of milliseconds or even down into the level of maybe a minute. You know what I mean? So there's a reasonable little bit of wiggle room you can get away with in there. But yeah, if they wanted millisecond latency, it'll be, hey, go away. I mean, you're just going to have to go talk to some other provider who can do that type of stuff out there, right? I mean, you wouldn't have been trying to build that unless you were going into literally writing your own service, which would be .NET code way beyond my levels of skill. Okay, and so short answer, you can't. But in their circumstance, for them, they could. Okay, it was we made it work for them. All right. The interesting thing was, though, that ultimately I don't want to say I shoehorned in a solution, but it was like they said they wanted a streaming solution, but they actually didn't need a streaming solution. Okay, it's kind of one of those situations where you want
Classic.
this. Are you sure? Yeah, okay. And then you're kind of looking at how to use it and says, to be honest, guys, I could have written a batch solution for you, okay? Because they were still doing the whole, let's look what happened yesterday. And if you kind of go, well, if you're looking at what's happened yesterday, I didn't need that streaming thing. Theoretically, yes. Theoretically, they had this whole, it was a startup company, okay? So they wanted to be kind of very much on the finger on the pulse and kind of be able to say, yeah, we can react to something that's happening inside at the moment, But the reality is they never explored that route into it, So, but it was still streaming in the sense of lots of data coming from lots of systems coming onto it, having to bring it together, aggregate, do a bit of analysis, and go on there. So, it fitted, and I more use it now. Anytime I'm doing a presentation, I like to do presentations with a business requirement. All right. As opposed to, I think it just helps to position it for the audience a bit. So I still refer back to it because it's kind of my business requirements that I kind of use to kind of go, well, that's what they wanted. That's what I did. Now let's look at how I would do it this time and see how much better it is,
It definitely makes sense.
Yeah.
Cool.
Really looking forward to this. So I will give you the stage. You just need to share your screen.
I have to share a screen, and so I'm going to move this out of my way because I don't want to be looking at myself. Okay, and share screen, sharing the ease with dum. Okay, sorry.
No worries.
I'm just going to hit share screen, and we work it out from there. Yeah, great. I want to share that screen.
Awesome. So
okay.
Fantastic.
The stage is yours. Good luck, and looking forward to your session.
Yeah, take it away, Mark.
And now, 2 seconds. I might have to do a reshare again, guys, and I do apologize. Oh, no, we're good. No, we're not. I I just shared up the incorrect screen there, right? So I actually want to share. I'm going to stop sharing and reshare, and I do apologize.
No worries.
I really like the logo you have there, by the way. Really cool logo.
Oh, on my T-shirt?
On the presentation.
Oh, on the presentation. Oh, that'll be back. Don't worry, that'll be back very shortly. That's much better. You can now see SQL Server Managed Studio. So there we go. Yes, yes. There's my.
Fantastic.
There's my goal.
Take it away.
Perfect. So great. So everyone, thanks a million for being here. I want to do a quick introduction. I don't really like talking about myself that much, so this bit will be quick. All right. I've been working with data since 1999, doing a lot of work in business intelligence, OLAP services since way back in OLAP, when we called it OLAP services, back in OLAP 7 days, or SQL 2000 days. I lead a few different user groups and a few different conferences online, do a bit of speaking on data platform topics, and I do have a blog pending on this topic. So if you're interested in it, hopefully in the next couple of weeks, I'll have something up and running in there. Okay. There's my contact details along at the top. If you want to, spam me on Twitter or something like that, feel free. A big call out to the sponsors. I mean, it's actually, I had an interesting conversation with people before about sponsorship in the online space. And it was kind of because I've organized a few online conferences and haven't had sponsors. So actually, it's great to see sponsors getting involved in there because they need it too. They need a way of getting out and talking to their audiences and getting to meet people. So thank you to them for sponsoring this and many other events. So what am I going to talk about? I want to talk about streaming. I want to give you my business requirement, and we're going to go back in time. We're going back in history here, right? So circa 2012, 2013, a company approached me and they had the following need. They wanted to develop a system that captured your phone MAC address as it appears on a Wi-Fi router and turn it into insight on customer behaviors. I.e., when you walk past a Wi-Fi router, even if you don't connect to that Wi-Fi, the Wi-Fi router is aware of you're there by virtue of the fact that you probably have your Wi-Fi turned on in your phone. If you capture that information, you get some interesting things. Like how many people pass by your shop versus call into your shop. How long do they stay in a shop? How frequently do they visit your shop? Basically, footfall, loyalty, dwell time. You can kind of derive that out of the statistics that comes from it. They also, however, wanted the ability to react to live data, i.e. if the shop was really, really busy, do something. So that was kind of an interesting little twist that they had on it. So if I was to look at this, both from the need to potentially load large volumes of data, because lots of shops means lots of data, and also income, and also react to that income and data, I basically need to create a system that continuously loaded data. Okay, they didn't want to have the solution of let's just load it at the end of the day. Okay, it was like no, take it in, take it in, take it in, read it all the time. So basically, stream, as we would like to call it now. Okay, let's have a quick look at what that looks like. Well, I had my routers. Those routers were sending information to a web service that had to be written for them. That was dumping it down onto a set of file shares because it was just a message and putting it into a JSON file and a file share. It was then being picked up by integration services, which you then put it into a SQL Server database. And then in front of that, we had some dashboards or reporting services was used at the time in there. And that whole thing was managed on a VM. So it was an IIS solution, IIS solution. And you've got to configure up your FTP, your IIS, your operating systems, your patches, your SQL servers, etc. Basically a bit of a pain. All right, so that's what had to be done. But we got there, it worked. If I now want to, and what I'm going to be talking about in the rest of this basically is how I kind of would now migrate that, how I would approach that from a streaming point of view. And then we're going to dig a little bit into windowing functions and into performance and monitoring and stuff like that. So hopefully kind of gives you a good idea of how I'd now approach this. Let's talk about streaming. What is streaming data capture? It's one of the big V's of big data. All right. If you don't know them, volume, variety, velocity, varicity, and value. Okay. I swear at the start there was only 3 V's in big data, but another 2 appeared along the route somewhere. I'm going to be looking at the velocity side of that really, because I suppose that's kind of to a degree what streaming is almost aimed at in there. All right. So velocity is the speed at which data is generated. Data that arrives continuously and where you want to perform analysis on it as it arrives. That's really one of the big call outs and kind of one of the big reasons why stream analytics would maybe be necessary in there, all right? Because data that arrives continuously, but you don't need to analyze it. You can just hold it somewhere, right? And then you could process it later on, batch. But if you need to do some sort of analysis on it, being aware of how much analysis you could do, but if you want to do some sort of analysis on it as it arrives, that's then suddenly when the streaming and the stream analytics side of things starts really kicking into play here. So the solution now would look a little bit like this. I'd still have my router, but this time I'd be sending it to something called an event hub. My event hub would be passing data into an Azure Stream Analytics job, and then, in my case, to finish it off, load it into a SQL database where I would then probably put Power BI in front of it. It's really these two bits in the middle. That's the streaming solution. These bits over here are somewhat incidental, all right? So these are the bits I'm going to be looking at. And of course, that whole thing now is Azure Platform as a Service type of functionality going in there. So I removed all that whole need for patching, maintenance, etc. all going in. So that's a little bit of background about streaming. Let's go into demo world. Just to give you an idea of what that is looking like. I'm here. I've got a connection up to an Azure SQL database at the moment. Let's see how many messages have arrived in at the moment. I'm just going to count on the table. And I've got 2,959 messages in there at the moment. And if I do a quick look at the top few that have come in here, this is what I'm showing. And I'm basically simulating a MAC address at the moment. Okay, just to give you an idea of how it works. I've got a single access point on simulated at the moment, and I'm receiving client MAC addresses. And you can see over here, I'm classifying that into whether this is a visitor, i.e. it's someone who went into my shop, or whether this is a passerby, who's someone who walked past my shop. And over here, then I've got a little basic bit of information about my scene count, basically, you know, how frequently have I seen them within that window. If I follow back along, I'm seeing on here, this is a window that was done at 20 seconds past. If I go back a few rows, I should see there, I'm at 40 seconds past there. If I go back a little bit further, you can actually basically see it. It's kind of every 20 seconds, there's an update happening in here. So let's see, has my count updated? It was 2,959. And now it's up to 3,116. Okay, so data basically obviously is continuously arriving in here. You haven't seen me do any load, it's just arrived. So there's something running in the background in there. Okay, great. Let's have a look at what's running in the background. This is my Azure portal. All right, I've got a data plane up here, and over here I've got a couple of jobs going on. All right. The sharp-eyed observer might notice there's a password up there. That service doesn't exist anymore, so it doesn't matter. I've got event hubs, and I got a stream analytics job. If I go in initially looking at my event hub, it's kind of quite boring, other than you can see a line. So clearly there's something going on. Basically, it's giving me an idea that messages are arriving into an event hub. Down there, I can see I've received 6,000 messages so far since I've turned on this system. Okay, we're going to look a little bit more at event hubs in a while. This is just to give you the flavor of what we start with. Let's click on this, the much more interesting stream analytics job. So let's scroll down a bit. And you will see some monitoring things going on here. And you can see I was receiving data, and then I was no longer receiving data. That was simply earlier when I set up my simulation, and my simulation came to an end. So it dropped down, and my stream analytics job was doing nothing. And then just before the session, I turned it back on again, and now I'm processing data in there. So messages are arriving in. Over here, you actually, interestingly enough, you'll notice my resource utilization. Even during this period of inactivity, I was actually still clocking up CPU in here because my stream analytics job was still running. It just wasn't receiving data. Okay, so it's in here, a nice flat 16% utilization going on. But the actual stream analytics job consists of three key components and one fourth optional component. There's an input, there's a query, and there's an output. So if I have a look at my inputs in here for a second, here are my inputs, and you can see I've actually got 3 inputs set up. I can go in here, I can see is there any more inputs, and at the moment, because my job is running, I can't go changing anything in here, but you can basically see that I've set up 3 inputs, and they're all event hubs, so just pointing at different event hubs at the moment. So Stream Analytics job pointing at an event hub. If I look at the output, well, the output we can just read off the front in here, right? I'm outputting to something called Sycamore Stream Analytics demo, and that's a SQL database, okay? The query bit over here, this is the bit that's doing the work. So if I do a quick look and go in and edit that query, and again, I won't be able to edit at the moment because I'm running live, and I got lots of things commented out, But there's my bit of SQL that's running at the moment. All right, this is my bit that's taking in data and doing counts and a little bit of analysis. Again, we're going to look a little bit closer at this in a few minutes, but it's giving you an idea of what we build in there. And the fourth thing, which I'm not using at all in here, is a function. You can see it over here. My inputs, my queries, my outputs. There's a fourth one, a function. The function in here I haven't done set up, but a function actually would be a way of calling a different resource inside an Azure to do something. So say if I was taking in data and I wanted to do some analysis on it, maybe for fraud, right? And in a fraud situation, you're then saying, well, taking this data, run it through some cognitive services algorithm that I've created and give me back a fraud yes, fraud no result in there. That would be a way that you would extend Stream Analytics. On the input, getting your data from an event hub, say. On your SQL statement, it will be gathering that data and passing it to a function, getting back a result, and then writing that function and writing that result off to somewhere or reacting on that result, which would then all be defined in the output. In my demo, I don't have functions set up in here, but it is a kind of fourth critical part of it. So that's the Stream Analytics job in action. The input, if we want to talk about the input, it's an event hub. So really, what is an event hub? You can just think of it as a service that receives messages and holds them. It will hold them for a predefined period, depending on the version you're on. It can hold them up for 7 days. And then other activities can then connect to that event hub and say, hey, give me those messages. Okay, so in come the messages, they stay in the event hub area, Stream Analytics gets turned on, it starts taking the data out of the event hub. Event hubs can do some other little things in there as well, but that's the kind of fundamental description of just receive a message and hold it. Wait for something else to do something with my event hub. So let's pop back to my demo or pop back to my slides. So that was a quick demo in terms of what I created, all right? And that in essence is the heart of Stream Analytics, okay? Let's talk through, though, about the SQL statement, because the SQL statement that I showed you, most of the time we'll use a windowing function, something we call a window function, which is kind of critical to a Stream Analytics job, all right? So what is a window function? It's analysis of streaming data and involves the segmentation of data into temporal windows. It's a very Star Trek sounding definition in there. But basically, a temporal window is a window of time that you capture and go, now that I've captured my window of time, let's do some analysis on that window of time. So ways of grouping events over time is an easier way of looking at it. And there's the tumbling, hopping, sliding, session. And today I discovered Snapshot. I'm not quite sure how long it's been around. I did not see it the last time I was inside in the Azure documentation. Today, when I was checking a few things, I said, oh, look, there's Snapshot now. So I brought it in here. So the next few images I'm going to show you aren't my own. They're all from the Azure documentation on Stream Analytics. So they can take all the credit, and if there's something wrong, they can take the blame. In terms of window functions explained, we're going to explain it via tweets, because tweets is very easy to consider, right? We all know what a tweet is, and a tweet is a natural stream, okay? It's continuously happened. Tweets are continuously out there, okay? A bit less now that Donald Trump's not around, but, you know, happens a lot. If we look at a tumbling window, it basically comes down to count the number of tweets every 10 seconds, okay? So if I had a tweet stream that looks like this, well, basically a tweet happens here, a tweet happens here, a tweet happens here, a tweet happens here, a tweet happens here. That's a 10-second window, so that's my result. If I was counting this, I would say, well, hey, 5 tweets happened. I now go on to my next 10-second window, which is from 10 to 20, and 2 tweets happen. I now go on to my next one, 20 to 30. Another 4 tweets happen, and that's my result. So quite a simple, bang, what's going on in the last set period of time. Let's go in and have a look at a hopping window. This is where we count the number of tweets in the past 10 seconds, but do it every 5 seconds. Now, by the way, obviously, I'm only saying 10 seconds and 5 seconds. This can be minutes, this can be days, this can be various periods of time. So we're just using seconds as part of our explanations, okay? So number of tweets in the past 10 seconds, do that every 5 seconds. So now my stream for the same tweet feed becomes, well, be in the past 10 seconds. So the first one kicks in here at 10 seconds and goes, well, how many tweets happened? Oh, there's 5. But now, 5 seconds later, it does another window looking back 10 seconds, and it sees, oh, well, there was 3 in this window. Now, another 5 seconds later, it looks back 10 seconds, it sees 2. Another 5 minutes later, it looks back 10 seconds, it sees 4. And another 5 seconds later, it looks back 10 seconds, it sees 4. So it's a very kind of verbose way of looking at how busy. If we're all unfortunately familiar with COVID at the moment, right? And in Ireland, I don't know about what country you're from, but in Ireland, there's the how many cases there's been in the last 14 days. Okay, so actually that's a window and function that they're calling out every day, because every night they announce what was the case count for the last 14 days, as well as they announce how many cases happened today. So they're actually giving us 2 window and functions. They're telling us the hopping window today and the tumbling window today and the hopping window, how many were in the last 14 days. Then we got the sliding window. So the number of tweets that occurred in the past 10 seconds from when a tweet arrives or is past 10 seconds ago. This is kind of a little bit of a head wreck, okay? But basically, if I look at my time stream, nothing happens here. A tweet here happens at 10 seconds. So because this happened, that's my window. A couple of seconds later, another tweet happened. So that's another valid window, and it looks back 10 seconds. You see that there's 2 tweets. And then a little bit later on, another 2 tweets came in, so it looks back 10 seconds. Now there's 4. Now it moves forward. Now what happens here? Because there's no tweet, but we have a window. The reason why this window exists is 1 has fallen out of the window. So remember, it says when it goes in or out of the window. So something moves out of the window, so the window is valid. And then it moves forward again. We get to here. More things have moved in or out of the window. And then finally, we get over onto the very end. When we're on the last, I moved out of my window. So therefore, this is the last tweet that I see in my window. A very noisy, verbose kind of, I almost think of it like it's shouting at you. This has happened. Oh, now this has happened. And now something else has happened. Now this has happened. That's what's going on in a sliding window. And then we got the session. Session, count the number of tweets that happen within 5 minutes of each other over a 10-minute period from the first tweet. Why have I gone from minutes to seconds? Sorry, seconds to minutes. Simply because for some reason they've done that on the Azure documentation online, and I'm using their pictures. So I was like, oops, I better change what I'm saying too. So they decided to go for 5 minutes. So in this case, what happens is a tweet happened. So it will start counting to kind of go, well, how many more will happen within 5 minutes of each other over a 10-minute period? So this is the first minute of the period. It goes on. Well, look, another thing happened within 5 minutes, in which case it will log that. And then it will start counting forward 5 minutes from there. Nothing else happened, so the window's over. There's no window goes on here because nothing's happened. But then it all starts again. Oh, something happened, open my window. Something else happened within 5 minutes, extend my window. Another thing happened, keep extending my window. Another thing happened, keep extending my window. Another thing happened, keep extending my window. Nothing's happened, my window's over. And then finally over here, we get into another thing happens, in which case, okay, my window's opened up again now. All right. So a more kind of case of looking for something to have happened and then kind of keeps watching that particular event until it's no longer happened. All right. The last one, snapshot, a slightly different twist, count the number of tweets that happen at the same time. So in this case, it would be a case of say on 5 seconds past something or minutes they're using again. 4 tweets came in, so they go, okay, that's the window, just this moment, and then nothing happened, and then another batch came in here, and another batch came in there, and nothing happened, and another batch came in here. So a bit more kind of like clustering up your stuff in terms of, oh, lots of things happen right now, lots more things happened over here. So that's window and functions. So let's go back into demo world and have a closer look at window and functions. All right. Oops, sorry, I went to the wrong window, didn't I? No, what I should have done earlier was I should have stopped my job, but I'm going to stop my job now. All right. Now I'm going to go in and edit my query. And the reason why I should have stopped that job earlier is I'm not going to have to wait for my job to stop, which will take about a minute before I can actually go in and start editing. Oh, not too bad. It's actually got there. Okay. I want to know what it's actually showing me down here is it's showing me a preview of what it had captured. All right. This is the type of stuff that it was bringing in. So you can see there's my MAC address. There was the scene time, partition IDs, etc. What I'm going to do is I'm actually going to load up a sample input data. So I'm going to load up a sample input file. There's so I got a text file here, which is my test JSON data. Open that up. And now here's my sanitized rows of data. Okay, so let's look what we have in here. I've got 11111111212. All right, so I've just simulated 2 MAC addresses. Okay, let's see what's happening there. Let's actually look at the time saying. Let's try to understand this on our head. So I'm basically saying, well, at 41 seconds past something, I saw a MAC address. At 46 seconds, I saw it again. At 49 seconds, I saw it again. At 55 seconds, I saw it again. So you would kind of think that, look, those 4 events all happen really close to each other, right? And if my rule of, in my case, did they visit my shop or pass by my shop, I'd probably kind of argue they probably visited my shop, okay? So I'd like to count those 4 rows as 1. But now let's relay forward. What happens again? Well, we see the same MAC address sometime later, but it's a minute later. So for me, I'm going to say maybe they weren't in my shop anymore. That makes sense. They leave your shop, right? So maybe they're outside somewhere or passing down the street. So I don't want that to be counted with this 4. And then I rock on forward again, and now I see another something else happen. And if I look at that, well, it's a different MAC address to begin with. So kind of same thing. Oh, I saw it at 13 and I saw it at 15 and I have nothing more. So my output for this would be, I'd actually like to see 3 rows of data. One telling me that basically this guy was in my shop, another one saying he wasn't, and a third one saying he's not in my shop. Okay, I'm kind of expecting for how many rows of analysis in? For my 7 rows in, I'm expecting 3 rows out. That's the way I want to analyze this, okay? So let's have a look at how we would do that. And we're going to go through my different windowing functions. I just want to check, guys, you're hearing me loud and clear and all that, yeah? Okay. Is everything okay? Can we hear me?
Yeah, everything is okay.
Yeah, perfect. Sorry, I was beginning to freak out. I was like, oh my God. So let's turn this off. Okay, so I'm turning off one window and function in here, and then we're going to step through, first of all, the first one, the tumbling window. Okay, so that's my SQL going in there. Let's do a test on that. So that's going to run that over my my test input. And oops, sorry, I'm going to have to load up that sample again. Load it in. Go OK. And test results. Preview. Go test results. That's better. So let's look at my SQL. All right. I'm selecting my access point on my client Mac, and here's my little bit of logic. So remember when I said in stream and analytics, you probably want to do a little bit of analysis. Okay. So my bit of analysis is very, very simple analysis. I'm simply counting how often I've seen something. And if it's greater than 2, I'm saying you're a visitor. And if it's less than 2, you're a passerby. Okay. So I'm grouping up in my window. But what's my window? Well, my window's down here. My tumbling window is defined down here. I've defined one in seconds for 10 seconds. I've put it into the group by statement, my access point, and my MAC address. So basically it's saying, go away, look at 10 seconds worth of data, group it into AP and MAC, and then do a count on it. And that's my analysis. Okay. So when I go on that, then the into, by the way, that's my inserted into my stream, into my SQL Azure database, which was one of the outputs. And my from is my console source. You can see them over here. Okay. Here's my input. I'm reading from that event hub, which I've called console source. And here's my output. I'm outputting to that SQL database. So if I look at my results in here, well, I've kind of got my first hit correct, all right? Because I got 1 visitor, but I got 3 passerbys, all right? So why have the 3 passerbys happened in there? Well, it's happened because it is just a 10-second window. So if I follow from here and going from 41, that 55 is more than 10 seconds later. So it'll analyze it separately. So these first 3 fall into one row, but everything else then is independent. So that's the results I get from there. let's go looking at another window and function. So now I'm into my hopping window. So my hopping window is 10 seconds, but do that every 5 seconds. Every 5 seconds, let's look back 10 seconds. So let's test that and see what results we're going to get out of here. So now I got more rows. Okay, I got lots of data coming out in here. Remember, this is kind of very shouty because it's kind of going every 5 seconds, look back every 10 seconds. So if I follow the logic in here, well, it came along and it's at 45, it saw something. At 50, it saw something again, so it shouted out as a visitor. But then 5 seconds later, it looked back another 10, still saw it. So I said, hey, still a visitor. And then another 5 seconds later, oh, it's a passerby now. And then another 5 seconds later, it goes passerby, and it keeps kind of shouting at me. So I imagine it's like a person outside the store shouting at you, saying there's someone coming in, they're still in, yeah, they're still in, oh, they're gone now. Okay, it's kind of like that's what's happening in there. So in my case, I don't want this data to happen. I don't want to look at my data that way. That's definitely way too much detailed data. So let's go on and look at my sliding window. I want to go into my sliding window and we go test that. So this is it goes in or out of a window. Okay. So when in our tweet example, the tweet is made, it comes into a window, but after 10 seconds, if nothing else has happened, it falls out of the window and then it decides to tell me that as well. So this is actually even more shouty. Okay, there's a lot of data coming out here now because here's my initial, oh, I've seen a Mac, it's a passerby. I'm still seeing a Mac, he's still a passerby. Oh, he's in the shop, he's a visitor now. And then suddenly he drops back down to passerby status, but now he goes back up to visitor status, and now he's passerby, passerby, passerby. So actually in this example, I get more data than I actually had on my input data. I've got more rows out than I had in my rows in this case, okay? So quite heavily verbose going on. And let's look at the last one, the session window. My session window is go looking for tweets. When the tweet happens, see does something else happen within 10 seconds. If it does, extend my window. All right. So that's what I'm doing in here. Let's run this. And now I get 3 rows of data. And actually from what I said at the start, that's kind of what I wanted to get out of here. All right. Because if I was to look at my data, it's basically turned around, followed the analysis, and when I said, well, this happened. Let's see, does something else happen in 10 seconds? Yes, it does. Has something else happened in 10 seconds? Yes, it has. Has something else happened in 10 seconds? Yes, it has. Has this happened within 10 seconds of the ending of that? Or sorry, 20 seconds within the ending of that? No, it hasn't. So that's a new event. So these 4 now got considered one event or one unique outcome underneath that session window of 10-second window extended up to 20 seconds. So that's in my case, that's actually, in my case, that's the type of analysis that I would go with that kind of seems to best suit what I need to do in this case. But obviously, depending on what your use case is, you might find one of the other windowing functions is a better route for you to go. Okay. I don't have the 5th one set up, seeing as I discovered it 15 minutes before the session started. I figured I wouldn't go writing more SQL at that point. Okay, so there are my 4 windowing functions I want to show you. Okay. Now, before I kick that off, I am going to comment this one out just for my last bit of this session. I'm going to run this one. And yeah, that's fine. Let's save off my query. And I'm going to start up my job again. Start up. So know when I'm starting up my job, actually, there's a question in here. From now, customer, when it last stopped. If I was to actually look at what's sending my messages, I've got a C# program in here that's been continuously sending messages to my event hub. Remember I was saying the event hub will receive data and store data. So that's all that's happening. That event hub is still receiving data, still storing data. If I was to go back out of here and go looking at my event hub, you would see its activities up all the time. I can go back and say, hey, go back and start this from when I last stopped my stream analytics job. and it will go back and pick up those messages from the Event Hub and continue on processing. So quite a nice way you can turn off your Event Hub, sorry, your analytics job without actually disrupting the inflow of data coming on. For me, I'm just going to go run it from now, okay? I'm just going to just grab the latest set of data, and that will kick off there, and that will take a minute or two to start up, all right? But meanwhile, over in my Event Hub world, you can see I've got my messages coming in all the time. The other thing I'm going to do in here is I'm going to actually break this job. Click in there. You're about to see some of the worst C# code you're ever going to see in your life, okay? I'm not really a .NET developer, so I kind of just wrote something quick and dirty, and I'm sure there's a much more elegant way that lots of people online are about to tell me, which would be amazing, because then I could incorporate it into my design. But basically, I'm declaring lots of access points. And down here, I am taking out this guy, bringing in this guy. And finally, I'm going to up the messages. So let's say send me 200 in there. It would be a horrible time for this to crash, wouldn't it? Living on the edge. So that's going to kick off a new job now. And what's actually happening here is I've sent way more messages. Okay, I was sending a nice little once a second. Now I'm sending 20 access points a second, each with 200 messages packed into it. So I'm trying to swamp the Event Hub. So let's go back to my slide deck. Talk briefly about costs. So people generally kind of wonder what this is. Obviously your database, which is kind of incidental, from €5 a month. The Event Hub, you got a basic and you got a standard variation going on in there, all right? They charge you per TU, transaction unit. You can have maximum 20 transaction units going on in both cases. You also have a dedicated Event Hub option. There's also a charge for the amount of ingress events, pretty small, but it's per million events. Whereas from a stream analytics point of view, again, we've got a dedicated and standard variation. It uses what they call a streaming unit. So a streaming unit is charged at 10 cents per hour. That's €75 a month. You can have up to 192 streaming units running on an analytics job. So if you did have a stream analytics job with 192 streaming units, it would cost you $15K a month to run that. Okay, so that gives you an idea of the costs. The question is, how much work can they do for you? Okay, so if I was to go look at the performance, I got 3 key areas: the Event Hub, Stream Analytics, and the database. I'm completely ignoring the database. It's a completely different area of performance tuning. But let's talk about the Event Hub. The Event Hub consists of a namespace tier, basic and standard. There's some differences between them in terms of number of broker connections, plus how long it retains messages, and it has a facility to capture directly down to blob storage as well if you wanted. You can change between basic and standard, so that's kind of okay. There's another thing you set up in an Event Hub called a partition from 2 to 32, and really this comes down to your downstream concurrency, all right? And when your data coming in and the ability for the downstream systems to be able to run efficiently in parallel is also dependent upon the number of partitions you have going on there. So if you can have a very parallel running job, then the more partitions you have, the more data you can send down and handle it. Interestingly enough, you can't change that one. That cannot be changed dynamically. They measure it in number of throughput units. Basically, one throughput unit is 1 megabyte a second, or 1,000 events a second. You can change that manually or auto-inflate. So if you think about that, I can handle up to 20 megabytes a second into an Event Hub, or 20,000 events per second. It's a fair amount of data to come into an Event Hub. If I look at it from a stream analytics point of view, it's all about streaming units. So my Event Hub gets passed to my stream analytics unit. We can go from 1 to 192. A unit is a combination of CPU and memory, and each streaming unit can roughly process 1 megabyte a second. Okay, I love the way it says roughly. So basically, it's a real "it depends" answer. Okay, that efficiency is affected by the windowing functions you use and the cardinality of data. So if you've got a short windowing function, it doesn't have a lot of data to analyze. But if you've got a long window going for hours or days, then that's a higher cardinality of data you're capturing inside there. It's not going to be as efficient. It's got harder work to do. It depends upon the joins. We didn't see any joins in my in my SQL statement, it was a very simple group by, but if you are doing joins in there, or if your JSON message was complex and you had to rip it apart in a few different ways, and that might require some bit of work, that adds to the complexity of the streaming unit. Depending on how many partitions you got coming in, adds to the workload of the streaming unit. If you use functions, which I called out briefly, they actually engage JavaScript runtime library, so that will incur an overhead on there as well. And finally, reference data. A reference data in a stream and analytics job is a way of saying, here comes some data in. I want to join that with data from, say, my data lake or my Azure data warehouse or my SQL servers to bring in a bit of data to add it in, basically a join. Then that also incurs an overhead in there as well. So really that 1 to 192, because if you're doing maths initially, well, if my event hub can only if my event hub has a max of 20 megabytes a second, surely I only need 20 streaming units to handle 20 megabytes a second. But you can go to 192. Why? Because it depends upon the complexity of the streaming unit job. So my demo architecture, in my demo that I was running earlier, I'm roughly sending in 100,000 events a day, okay? Which if you look at the maths behind that, 60 events a minute, 1 a second, 1 TU, 1 streaming unit. I'm watching my time here, so I'm probably going to go a little bit quick in some things. Basically, a nice, easy €9 a month and €75 a month to handle that level of volume. If we throw up the values, though, we're going to get a higher utilization going on. And then the question becomes, how much do we need? All right, so I'm going to briefly pop back into demo world just to kind of see, have I started noticing a difference in my event hubs on my incoming messages? Okay, so over here now, we can see straight away, this is my demo running earlier, okay, and I was around 100 events, less than 100 events a second. But now, bang, I've got a big spike up in here. So I'm hitting a significant amount more, bunch of messages kicking in here. If I go looking at this from a stream analytics point of view, my stream analytics job should be up and running. And if I look inside in here, same way as before, I had now what effectively was a flat line of data. There was so little coming in. But you can see in here now how that's jumped way up because there's significantly more messages coming in. Jumping up to around 70,000 events in a minute. Now, if you think about that, it's not gone that much higher. It's trying to, it actually won't get there. And it won't get there because if we think back to the event hub, I think I currently have a 1 TU event hub, which is 1,000 events a second. Multiplied by 60,000 events, roughly that's what I'm seeing in here. So I've kind of hit a limit. I'm actually sending more than that into my event hub at the moment, but I've hit a limit on what Stream Analytics can actually process. Now, it would take some time to walk through all the different scenarios. So the rest of this is going to be basically show you some slides to kind of give you a flavor of what happens. So this is me looking at my streaming units utilization when I had 10 concurrent access points sending 100 messages. And pretty efficient, okay? 15%. When I decided to up the pressure a little bit, go 10 by 100 and with a sliding window, so I changed my windowing function, same volume of data, but different windowing function. You can see in here, my resource utilization has increased. Not radically, but it does show you how, okay, my windowing function was different in here, so now it requires more CPU. And then over here was when I changed it to a sliding window and used it with a longer duration, 5 minutes and a 10-minute max. And now I'm seeing again, okay, this is getting a little bit heavier again. My baseline seems to be somewhere around 25, but it's crept up as high as 35%. So you can kind of get a sense of, with the same volume of data coming in there, when I start changing things that my stream analytics job does, it asks to do more work. You need more CPU. What happens if I go 10 concurrent, 100 messages, 100 sends with a 30-minute and a 60-minute max? So I've just extended my windowing function. Now I get a longer feeder time and it slowly creeps up. Basically, as that window gets longer, it begins to get a bit more aggressive in terms of the workload. So now it's up around the 80% area. And you know, when we're getting to 80%, you begin to think, maybe I should actually start increasing my streaming unit here. If I was to look at those 4 scenarios from a message throughput, I'm seeing the same thing. My message going up, bang, that's what happened. I increase my messages, I'm getting more. over here, I did a big increase on my messages. I initially see a huge spike, but actually then it settles down, back down to roughly that 40 to 50,000 events a second. I kind of a flat line because I haven't changed my number of throughput units. So it can't actually handle them all, but it's just sending me through the efficiency it's getting. So you start stressing that, going 20 concurrent messages, 200 messages. So I've doubled up in here. And now my resource utilization, again, it's handling it from here. That's my baseline because I'm capped. I'm 1 TU. All right, so my 1 TU is still capped in here. So I haven't seen a huge difference on this output, even though I've increased the volume of messages, but I'm also not able to handle them. All right, they're all not coming in. If I go looking at from the bytes per second sent from my VM, you can see I'm capped out of that. So when I change that to give me 4 TUs on my event hub, now we can see my messaging has gone way up. I've got more messages coming through in here. My resource utilization on my SU, which was capping out at around 40%, is now capping out at the 80 to 90% area. So more messages have now been taken. My SU can still handle it, but it's working a lot harder, right? It's up there at a 95% rate at the moment. Okay, and you can see in here on my memory, on my event hub send the job, you can see it's now sending more data. So that was as a result of changing my TU. And then I up this to give myself 3 SUs because we're not maybe comfortable with 100% 95% utilization. Here is another interesting. Here was my flat line that I hit because my SU was under a bit of pressure. Now that I increased my SU, I'm actually taking more events coming through on my TU side of things. And what's happening over here, as opposed to flatlining out up at the 95% level, I'm now getting into a more of a kind of going, yes, it's growing up, but then it's dropping down as it's hit its window, growing up, drop it down, growing up, dropping down. So kind of seems to be in a better situation to be able to handle it. And my net utilization roughly the same. So that's just giving you an idea of how you use TUs and SUs to try to find your level of optimization that you want in there. So you're then actually managing the jobs that you need, but you can dynamically change them as you go through to kind of get to that volume using your monitors to see what's kind of going on there. There's a reference blog up here on the DevOps Microsoft blogs about a reference architecture for 1 billion events a day, which breaks down to 700,000 events a minute, which is basically 12,000 events a second. Allow for a peak of 1.5, so you need 18,000 events per second to be handled in there. 1 TU is 1,000 events, so you would say, well, I'm going to need 18 TUs to handle 1 billion events a day, all right? Let's pretend each message was 250 bytes. That gives you 4.5 megabytes a second coming in. 1 SU, streaming unit, can handle 1 megabyte. So technically, you would say, well, I probably would need 5 SUs to initially consume that 4, but you also need to allow for query type and scale, and basically got to experiment. So actually, the recommendation from this blog is to go, hey, I'd start from 6 and really take it from there. Each SU would have 1 partition, create 10 partitions. They'd end up creating this architecture to handle 1 billion events a day. Basically, a TU with 18 TUs capacity. That's 18 out of 20. So my event hub is up near my capacity here. But my stream analytics, depending on the complexity of the stream analytics job, we're setting at 6 TUs to handle it, or 6 SUs to handle and loading it in. The rough cost to host that, to give you an idea would be $1,000 a month. Okay, so that's a reference blog architecture you can check on there if you want to kind of go in. It obviously completely, again, depends upon how intensive my stream and unit work is going to be in terms of doing stuff in there, whether I can get away with 6 or whether I have to scale all the way up to 192, in which case that's going to be a hell of a bill. All right, but gives you a bit of an idea in there. Summary and conclusion. Basically, it's quite straightforward to build a solution that could handle 1 billion events a day. And that's pretty impressive to say you could spin up a solution that could handle 1 billion events a day in a matter of minutes. Okay, it is certainly quick to build. I mean, the only dev is the stream analytics function, and the dev in that is a SQL statement. All right, easy to scale, to cost, to unit, 1 to 20, 1 to 92. Obviously, if you have a database, there's loads of different ways you can scale a database going on in there. So I suppose it's just giving you kind of a flavor of how you could go about and start using event hubs and stream analytics to actually handle that incoming stream of data that you would have there. And that's me done. I think I'm 2 minutes overboard, so apologies for that. But hopefully you've picked up something from there, and I'm delighted to take any questions if you have any, guys.
Hello. Wow, this was a lot to take in. A lot of people.
Yeah, sorry. There's like, throw the information at them quickly.
That's amazing. It's like you mentioned in the beginning, it's like 9 years of research that you know, since you started your project all the way till now with adding on features and
into a small yeah. So look, there's a lot in there. I will get that blog up and sorted to kind of try to break that down a little bit more into kind of what details going on there. But that last reference blog that I put up there, the one that's up on Azure DevOps somewhere, is quite useful actually. I've referenced that quite a few times in there myself, just kind of checking things and stuff like that. So you know, yeah, absolutely.
Yeah.
But yeah.
That's fantastic. Yes, so we have a question. So you ready?
Absolutely.
All right. So someone asked how this Windows functions work with eventual consistency, or if it's related somehow to eventual consistency.
So eventual consistency. So it will get written in there in the order that you kind of want to happen in there, right? If I'm getting my consistency definitions correct in my head, I hope. I think the call out in here would be the partition inside of things. Okay. If you need events to be processed in a particular order of that they come in, and that order is actually is important, then you would look at a partitioning key, which I didn't mention, but there is a partitioning key inside in the event hubs, which will then line up with your stream analytics units. So you would have to consider that in there, because otherwise, theoretically, by incoming a message, my event might come in, and my event hub goes round robin allocation into a different partition. All right. And my stream analytics job then is picking up in there, and you may not actually get the order right going on. So yeah, if things like that are important, certainly there's a need then to send in your data and get it popped into the correct partition, and then your stream and analytics unit is then picking up sequentially from that partition. But the data is coming in sequentially from that point of time into it over the windowing function. So because it's coming in sequentially, your consistency should be fine. And of course, I'm not going to speak for the database side, because if you're dumping that I'm dumping into an Azure SQL database. So, you know, consistency is essentially guaranteed inside in Azure database world. If I was put into something else that is in itself doing eventual consistency, then it's under its rules. So, but the stream analytics, I think it's the partition and functions is what you're going to be watching in there, if that's important.
All right, cool, thank you.
No more questions like that. That was a hard question.
Well, we might get another hard question. I'm just filtering out multiple chat while we're speaking. Yeah, so there was a notion about costs. So how do you calculate costs, and what is, you know, kind of best practices or tips you have, advices for people to when they want to calculate costs for their streaming workloads?
Oh man, I'm going to quote Matt Damon when he's up in Mars, right? And he says, "Do the math." Okay, you know, just do the maths at the start. Okay, I mean, you're going to have some sense, hopefully, of how much data you're kind of coming in. I mean, if I'm taking on a project, I'm going to be asking, "Hey, what the hell are you sending me? You know, what type of volume? Run a proof of concept. So, you know, even just send it into an event hub and do nothing else or something like that. Just get a sense of how much volume you're going on. After that, you're going to do the maths. I mean, it's 1,000 events a second, or it's 1 megabyte. All right. So you're kind of going, all right, if I'm sending in big images into a stream, I'm going to mess up on my megabyte size, right? Probably wouldn't send big images into a stream, but anyway. But if I'm sending in little messages, little transactions, okay, you know, I'm counting down in the bytes now, all right? So I shouldn't be worried about it from the megabyte size, but how many of them I'm going to get is my question. And then you transpires, okay, I'm going to get 2,000 events a second hitting me. Well, I need to have at least 2 TUs. Straight away, I'll be putting on 3 in that case. Okay, just kind of go, okay, let's pocket on 3, see what happens. Same on the stream analytics side. You're just doing the math, except now your math's a bit easier because you've done the math on the actual event hub. And you kind of go, well, if it's taken in that, then technically I only need to match what it's doing. So I've got three TUs, so I'd probably give you at least 3 SUs, and then I'd add on a couple for fun. All right, just to kind of go, okay, will that handle it initially? But you only have to run it briefly, right? If you're worried about clocking up huge bills in here, you turn it on, turn it off. Like I'm running this on my 70 euros credit I get with my Microsoft partnership thing that so I turn it on when I need it, and now I turn it off.
Yes.
But yeah, it is just simple. Just the maths is pretty straightforward. Just do it and see what happens.
Yeah. There was another question about compression. So when you work with data that comes in streams and later on you want to process it, there are some advantages if you compress the data in terms of retrieving it faster and also being able to analyze it faster. Do you have any advice on that part of compression with Stream Analytics and Event Hubs?
I told you, no hard questions. She's not listening.
It's not me, it's the audience. I mean, all the people.
I don't know. I'm going to take Elder's question. That'll be a much easier question. Short answer. I'm not sure. All right. Short answer is I'm not sure on that one. Okay. Because in my case, it's the Event Hub that has taken data. So if an Event Hub receives compressed messages, first question, I'm not sure. I'm not sure if that even can, but let's assume it is receiving a compressed message. Then it's just a message. The Stream Analytics job, however, is going to have to do some work to try to decode that message. And I don't know, would that involve passing it out to one of the UDF functions to kind of go, okay, I'm going to pass you in something to do a bit of work and you're going to pass it back, right? But really, I'm doing guesswork in there one, so apologies. I can't help in that question. I can't help in it really. Not something I thought of.
That's fine. Okay, last question is about. There's a tail in your background. We weren't sure if that's a dog or a cat.
Oh, this is Alfie. Yes, there was a tail in the background. He wanted to kind of come in, and he likes being showed off to people in there. Although he's a bit kind of going, I was in the middle of a sleep there, dude. What the hell are you doing? So he's just going to snuggle down there now and be happy. Yeah, that's the dog.
Such a cutie. All right, Elder, it's your turn now.
Yeah, so I don't have any additional questions. Like, I think you already had enough questions fired at you. I definitely say it was a really awesome session. Like, I like how you also had like the real life scenario that you now are like, how could I have done this if this tooling to my advantage?
Yeah, absolutely. It's like, to give it an idea. All right, my initial dev that I did on this didn't take particularly long, to be fair. Right, it was a startup company. There was a certain flexibility of how we do things, i.e., throw it in. Okay. But like, it was probably 5 to 10 days of work the first time around when you're doing that in SQL Server world, between creating your integration services packages and getting them tuned and all that. I mean, it wasn't huge, but that's what it was, right? 5 to 10 days worth of work. Recreating that, I recreated that on a Friday night, okay, in 3 hours. That was the difference. And that was me learning on about Stream Analytics right from the start, kind of going, I'm just going to turn this thing on. I'm going to turn on this thing called an Event Hub. I'm going to throw some data at it. Okay. Most of that was trying to work out what are my correct permissions. Okay. So really completely different approach. You can't really compare them, to be honest. You can't really compare them. But yeah, so 3 hours versus 10 days, a lot to like.
No, but yeah, I really liked the scenario. I liked how you can explain it. Like, you had the thorough explanation. I saw some very nice details there. So thank you so much for this. I hope you enjoyed your time here.
Have we gone?
You're back again. You had a little bit of. So I hope you enjoyed your time today here. And it was awesome to have you on the conference today.
It was great. Listen, I really appreciate it because it's the first session I've even done in 6 weeks. And I kind of feel like, oh, okay, right. Now I know what to do again. So it was great to have me. Thank you so much. And thank you so much for taking the time to put these events on. It's really appreciated.
Awesome. Thank you so much.
Cool, guys. Sloan, take care.
Take care.
So, Eddie, with that, I'm just waiting for the other organizers to end their sessions. So in the meantime, I want to take my time to thank you for being here today. You were an amazing co-host.
Thank you, Albert.
So yeah, you are one of the best co-hosts around here. Like you do so much. You ask the questions. You go into the chat. You make sure that people are interacting. I could just focus on the other stuff, like the whole producing, and I just you had everything under control. That's really good as producer to have someone like that next to me.
That's my pleasure. I love the community and I love working with people, and it's a true joy to be able to join in and help and support. And a lot of people asked a lot of really good questions, and also it was great to learn about the different services that we have in Azure. Some stuff I wasn't aware of, like the differences between Azure DevOps pipeline and GitHub Actions and Stream Analytics. There were some few things there I wasn't aware of. And I learned a lot of stuff, so that's amazing, and I'm super happy to be here and learn with all of you.
Awesome. Yeah. So yeah, I'm hoping that we can next year we can actually do this in person again, and we can just have you over here. For now, this was the next best thing. So I really enjoyed this. So with that, I would like to say thank you to you. I see track 2 is still running, but I sent them a message. But I do see track 3 is already done, so I will bring Angelique in the stream now. Because so I just want to know, Angelique, how did your session go? How did your track go?
Really, really good. Rick was a great help. I mean, first time hosting also for me. So thank you for Rick for helping me with questions and stuff like that and how to do it. The speakers were all great sessions, great response from the community also. So I'm proud of it.
Awesome. So I see track 2 has also ended. I just need to get to Sejan here in the stream, and then we can finish up.
Mm-hmm. There was one quick question. Where are we going for the raffle on Discord? On lobby or?
So I will explain it all in just a minute. So basically what will be happening is once Sejan joins in, we will I will open up a few slides. I will explain the whole process that we are going through, but the raffle will basically ask me show my screen, picking up a name, calling out the name, and you have to respond to me in person within 15 seconds.
Yes.
We have a tight schedule in here.
Yeah, also because we had 600 something registrations. I know there's not 600 something people in the Discord, so I don't want to spend 10 minutes just to find someone that's actually here. So I will go through this quite quickly. So, okay, I see that Sejan is also joined. So Eddie, once again, thank you so much. I will talk to you later. And thanks for being here today.
Thank you.
Thank you.
Thank you, Eddie.
Welcome, Sejan.
Yeah, we just finished up in track 2. So great session by Holly and Izzy.
Awesome. Yeah, so I hope your track went okay as well.
Yeah, went all fine. No problems, no issues. Good sessions. So yeah, pretty pleased. I think the audience as well. So of course I could see a bit, on the other screens how things went with track 3 and track 1, of course. But little tidbits left and read. But I think your guys were doing well as well, I think.
Yes.
Yes. Yeah. So okay. So I'm going to share my screen for a second. So
okay.
First of all, once again, thank you, everyone. I had a really great time today. There was a lot of discussion going on the Discord. I've seen a lot of discussion on the YouTube and the Twitch channels. So it was really good seeing this. So I will go to the sponsor slide first. If I can actually go forward, there we go. So once again, a very special thank you to all of the sponsors, because without the sponsors, we cannot do these events. So thank you to all the sponsors. I hope you visited them today. You have seen the slides several times today. I do have one sponsor that I want to bring in. It's Sportiva. They also want to do a raffle of their own. So I will bring Albert Jan in. He will talk a little bit about what is Sportiva and do a raffle for us. So welcome, Albert Jan.
Welcome.
Hi, Albert. Thanks for having me. I wasn't under the impression that you would do the raffle for us. So I didn't expect the raffle itself. Sorry about that.
Oh, no worries, I can do that as well. Let me actually just share my screen instead of, just give me 1 second because I have to move some stuff around for this. I'm now sharing slides instead of my screen, but I of course need to actually share my screen.
Technology. So first, I'm not going to talk too long about Portiva. I just wanted to make sure that thanks for having us. Even though it was not a physical event like last year, it was a really, really cool day, at least for me. So I'm pretty sure that it was for the other attendees as well. There was tons of awesome sessions, great organization. Really, really loved the demos. I'm not going to keep you away too long from the raffle. We are a Dutch ISV. We focus on doing cool stuff for customers, mainly around operation reliability. We have almost 100 colleagues, and I'm pretty sure that I can say that we have the best colleagues out there. We are the funnest company to be with. But then again, that's probably what you've been hearing all day long. Traditionally, Portiva has been focusing on Microsoft 365, but over the last 2 years, we've seen that we shift away from just Microsoft 365 towards both enterprise security and building cool stuff in Azure with modern apps and cloud infra. If you want to hear more about that, just reach out on Twitter, ping me, whatever you like. Obligatory nudge. If you want to hear more about it, visit our website. That was pretty much the marketing stuff that I have. Now, I'm really, really interested in seeing what we're going to raffle out. So I'm not sure.
So it will be an Amazon gift card.
Ooh.
So yes, so it will be a 50 euro Amazon gift card, or the same in your local currency.
Okay.
So I will explain how we set up the raffle. So everyone should see my Excel over here. So what we are going to do is I have all the names, like you will see. I have like 600 something columns in here. I have all the names of all the registered people. And I just, like Excel is always nice, I just said, okay, I'm just going to pick a random number and go to one of these cells, and whichever name comes up, that's the winner. So what I'm going to do is move this one false to true, and at that point, I will find the name. So, Razul Hassan, I don't know if I pronounce it right. You got about 15 seconds to message me personally on Discord. After 15 seconds or so, I will actually just put on a timer here. And by the time I'm done with that, it should be like 15 seconds. So I don't see anything coming in yet. There we go. So,
which Discord channel is it?
So no, just message me privately, like just send me it. So I will give a couple more seconds because this is the first one. So 5, 4, 3, 2, 1. Okay, so now, and that's like I said, there we have 600 something registrations. There are like 200 people in Discord or something like that. So there, I will go to this a bit more. So next one, Johan Benskop. So I think I've seen him. I will wait
Is he still here?
So let me just, because I did hear a ping. Yes, there's Johan Benskop. Yes, so Johan, so you get a 50 euro raffle Amazon ticket. So thank you to Portiva for this, and thank you everyone for being here today. So
thanks again for having me.
And we will we'll contact you again next year to see if we can do this in person again.
We'll definitely be there.
Awesome.
Cool. Thank you.
So with that, we are going to the next raffle. The next raffle will once again be among on-the-addressed people. Only in this case, it's going to be for Lego set. And I'm just now trying to find out how I can actually put this side by side. There we go. So, so this is the Moonlander set. So Ashley can tell a bit more about this because she's the one that's actually building everything that's behind me is actually hers.
Nice.
Yeah. Everyone knows from Microsoft, of course, they are doing some things in the space. So we thought this is a nice set to have for the people that's going to get this one. So you have the Apollo 11 lunar lander. So this one was there, not this not the bricks. So maybe we can go for the raffle now.
Yes. So I will move to 1 second. I've lost my mouse. So that's a nice thing if you have 4 different screens. Your mouse hops around a bit. So next up, Santa Sashdev. So once again, about 15 seconds. So let me just start my timer this time. So Santa, if you're here, call out to me, like just mention me or message me privately or something. Otherwise, we are going to the next one. So that's about now. So I didn't hear for anyone. So let me just reset this and go to the next one. Jos van Schouten. Jos, if you're here, call out to me. Once again, about 15 seconds. And otherwise, we will go to the next one. So 5 seconds left. No. Next one. Arnold Riet. Arnold, if you're here, this is the time to call out. So let's hope we are actually going to find someone that is here.
Jos Schouten was there.
Oh,
I think.
so,
yes.
Okay, so Arnold Riet is not responding. So because Arnold Riet is not responding. Oh, wacht, he is actually no. So Arnold Riet responded within time. So sorry, the previous one, but you did not respond in time. Like I explained it from the beginning. Arnold Riet is here. So Arnold, I will actually. I have your email address here. So I will contact you on your email address to find out where to ship this. I think I know about approximately where this should be shipped, but I will contact you on your email address. So it is this one. So if you are not Arnold Riet and you're telling me this, then you don't get the prize because I will send it to this email address because you don't have your own name, but I trust that you are this. So Arnold, very much fun with your Lego set. And with that, we are going to the final raffle. And the final raffle will actually be a much smaller raffle. And I know all these people are here because they have been talking quite a bit today. So I know they were quite happy to actually fight for this. So this is a raffle for the people that were most active on Discord. Some of you might have seen this come by with the whole rank stuff. So what we have done is we have used one of the bots for this. Like people that were active, were discussing, were talking to each other. Basically, they were keeping the whole chat alive. We took the top 10, and this was the top 10. And so this set is a little bit bigger set.
I need to go backwards.
So tell about this set.
This is the crane for WAF terrain. It's a lovely build. I built this one myself. You can move it. There is an adapter in it to move all the pieces you see, the crane, the wheels, everything you can move. It's a lovely build, and you have so much fun with this one.
Yes. So actually, like she said, we have it is over here as well. So it's here on the top shelf. So it's a very cool build. Like she says, everything moves, and you can. It's like a really nice build. So let's see who of these 3 is the luck. Of these 10 is the lucky one. Once again, using the same method. This one should be A1, by the way. There we go. Because in the other one, it actually had name here, but this one doesn't. So A1 to A10. So good luck. So Wootix. So just let me know, because I know you're around here. So just give me a quick call out. So let me just see over here. You are still around, I hope, because otherwise we will actually go to the next one. I do see you online, so you should respond. There we go. Yes, there he is. Yeah. But there they are. I don't know. So there they are. So, okay. So this was in time. So awesome. So thank you once again. So that was the raffle. So congratulations to all the people that won the prizes. Let me go back over here to my, so I have to share the other one again. This one. So like I said, thank you to the sponsors. Thank you to Congratulations to everyone that won the raffle. And thank you to everyone that was here.
Thanks.
So,
yeah, definitely.
I'll start. Thank you for being here today. Like, I had an amazing time. I saw there were a lot of people watching the stream. I saw a lot of questions coming by. I hope everyone enjoyed the sessions. So thank you from me, Stevian.
Yeah, no, same thing, Elder. Thank you for setting us up. This was a great experience doing it virtual this time, straight from our respective homes. Yeah, thanks for everyone attending. Thanks for the speakers doing a good job, presenting today, also from their respective homes. Yeah, what can I say? Of course, we all hope to do it again in person next year. But yeah, this let's say a different type of virtual experience was great too. So it was an interesting journey. So thank you. After you, Eldert.
Yeah. So Angelique, you're up next.
Yes. All thank you for joining us. Also, the sponsors, thank you for making it possible that we can do this also virtually. We hope next year, of course, for a real live event. Yes, it was for me the first time I did presenting, so I loved it very much. I had fun, and I want to thank everyone that's been here, presenter, hosts, attendee, speakers, everyone. Thank you. So back to you, El.
So with that, we are now done. Yeah, let's hope that we can do this in person next year. We might even look into it like a hybrid model, because I did see there were quite a few people from all around the world. So we might look into a hybrid model if we can do something like that. That's for next year, though. Like, we have a whole year to think about this.
Yeah.
If you want to know more, like, follow us on Twitter, on LinkedIn, on Facebook. Like, we will update you. So the recordings have been made. We will edit them over the coming weeks, and we'll contact all the speakers to see if they want to either that we host it, if they want to host it themselves, or if they say we don't host it. So it's all up to the speakers. But we will send this out, so you will all know, like, once again on your email that you register to it, but also on our social media. So there will all this information will be. So with that, I would like to say thank you. Enjoy the rest of your day, and have fun, everyone.
Yes, fun. Enjoy the upcoming weekend.
Yes. Okay, have fun.
And
bye-bye.
See you next time. Bye.
Bye.